session in Lucidchart. Sure, Lucidchart has the most advanced data and automation capabilities, but did you know it makes building diagrams fast and easy? Simply drag and drop shapes onto the canvas, connect lines that snap, curve, or have double arrowheads, then add text and customize colors. If you get a great idea later, jump back into your shared document and keep collaborating asynchronously. Add comments to explain your work and tag team members to request feedback. Diagram with confidence, anytime from anywhere. Say goodbye to collaboration anxiety.
When we hear the term wireless technologies, most of us probably think about the wireless networks that we use at home or in our business to be able to connect to other devices on the network or to the internet. This type of network is one that is standardized by the IEEE. This is the Institute of Electrical and Electronics Engineers. And the committee that handles the standards for this type of network is the 802.11 committee. That's why you
all right, good morning, everybody. How y'all doing today?
Good morning.
Yeah, Mr. T, look at him. Hold on, I'll be right back. Hold on, I gotta get that shirt. Let me bring it out of the closet. Hold on.
So in order to make this a bit easier to follow, they've changed the naming convention so that the 802.11 AC standard is also called Wi-Fi 5. They then refer to the 802.11 AX standard as Wi-Fi 6 and Wi-Fi 6E for extended. And the 802.11 BE standard is also called Wi-Fi 7. This makes it a bit easier to differentiate between versions, so instead of using those 802.11 names, you can simply use Wi-Fi 5, Wi-Fi 6, Wi-Fi 7, and so on. Our Wi-Fi networks have a number of different frequencies that they might use to be able to facilitate this communication. And different standards of Wi-Fi use different frequencies. Most Wi-Fi networks will use frequencies in the 2.4 gigahertz range, the 5 gigahertz range, and the 6 gigahertz range. And some access points and devices can communicate.
Yes, indeed. I had it, told you I had it prepped and hanging on. Good morning, everybody. How are y'all doing?
Good morning.
It's great to see you. Happy Hawaiian Friday and favorite hat Friday. So it's good to see y'all. All right, let me go around the room here. Let's see. Good morning, Miss A. Good morning, Mr. D. Good morning, Mr. T. Morning, Mr. M. Morning, Mr. Elaine.
Morning.
Mr. C. Mr. M. Mr. J. Look at y'all, boy. Y'all chilling. Loped out. I see your name's loped out. All right, then. Okay, so what we have up on the slide this morning? What we got going on? All right, got day 13 in the networking today. Complete the course final. Again, there's 3 of them I need. Usually we wait till the last minute. Let's see if we can get something in. That way we ain't waiting till the last minute. We all stressing for a grade. Let's not do that. Let's get it in. Minimum course requirement again, 70%. And then you need 80% of your hours to pass the course. This is midpoint requirement too. So you have to reach that minimum hours requirement of 224. Everybody's on track for that. So just get across the finish line. That one. Of course, we'll have some questions and some quiz questions during the day. We had a great study hall yesterday for Net Plus, so that was pretty cool. We can fit in another one. We will this afternoon. Good morning, Kev. Mr. K, what's up, man? Okay, he's got the hat going on. Yeah, he's matching. Mushroom belt, mushroom hat, mushroom belt, mushroom hat. Remember Boomerang? Y'all seen that Boomerang? Yeah. I'm matching.
Yeah.
So what we'll do for the first hour, because it's some admin stuff I got to do. So let's go ahead and jump into some coursework, classwork. 9, we're going to kick this party off on the road and get into knocking out these last 2 lessons so we don't have to worry about them on Monday. We just start chilling on Monday. Cool?
Yeah.
All right, I'm here if you need me. Let me get this admin work and some emails sent out and be with you in about 45 minutes.
To be able to connect those devices to your computer. Bluetooth technology uses the 2.4 gigahertz range. You might also see this referred to as the unlicensed ISM frequencies. That stands for the Industrial, Scientific, and Medical Band. These are frequencies that don't require any specialized licenses to be able to use them, which is why we can simply turn on our computers and be able to connect to other devices using 802.11 or Bluetooth. With 802.11, we can move around a building and still have access to the network, but Bluetooth ranges are a bit more confined. This is why we often will see these being used with devices that are personally connected to us. If you're using consumer devices with Bluetooth, they have a maximum range of about 10 meters. Another popular wireless technology is RFID, or radio frequency identification. RFID has many different uses. You might find it in the badges you use to gain access to your building. There might be RFID tags inside products you might purchase or across an assembly line. You might also find RFID technology inside of our pets. This allows you to scan the pet and know immediately who that pet belongs to. This is an example of an RFID tag that's about the size of this grain of rice that's right next to it. There are also other styles of tags. This one is flat. Commonly see this inside of access cards. This design around the outside is the antenna, and if you look closely at the middle, you'll see the actual RFID chip. You'll notice there's no battery connected to this RFID tag. It usually sits idle with no power whatsoever. But when you bring a scanner close to this device, the power from that radio frequency is enough to power the RFID tag. The scanner then receives an ID code from the tag and then compares that to the information it has in a database to determine what that ID tag is referencing. There are also other types of RFID tags you might run into that do have batteries that are able to be actively powered so that you're able to scan that device from a longer distance away. And many of our mobile devices these days have another style of wireless technology known as NFC, or Near Field Communication. NFC builds on the technology of RFID, which is generally a one-way communication, and extends that to have two-way communication to your NFC devices. One popular use of NFC is to use your phone or your smartwatch to pay for products at a point-of-sale terminal. And if you've ever set up a device that needs to connect to a Bluetooth network or a wireless network, it often uses NFC in conjunction with your mobile phone to be able to give it the configuration parameters it needs to connect to your network. And since many people are carrying around their phones with NFC functionality, you could use that to open a door or to provide a type of identification.
Building your cybersecurity stack isn't rocket science. Simply create your own security apps with Solva. Get answers to the security questions you really care about and act on them instantly. Set up custom alerts, build workflows, or create dashboards. And guess what? No code needed. Don't want to DIY that ish? Sola's app gallery has plug-and-play apps ready for you to use. And with Sola AI, you get your own super talented security wingman. It can do all the work for you. Whether you just need to tie together some loose ends or build up your security stack, Sola's there for your needs. It's simple, quick, and free. Get security done with Sola.
We can start whenever you're ready. Ready? Yeah. Wait, no, stop! Wrong pedal, other pedal! Over here! What do you want? Stop the car! That's a kid! Kid! Did I pass? Hello, the MVPs?
Hi there, mister. Oh no. How close did you come?
My life flashed before my eyes. I can't throw away my life in some dead-end job for crappy pay and no hope of happiness. No offense, Greg.
Oh, I wasn't offended until you said Greg.
Sorry. What do I like the most about working here? The constant rush of superiority.
Coupons are not a valid proof of residence.
Did you realize your job is to ruin people's lives? This is mine now.
It's out of ink anyway.
You guy, you started wearing makeup, stopped eating tuna. You staged the house. Don't blame me for checking out the Zillow.
Oh, hey.
You see what I see? The connection between them? Like the menstrual pad stuck to her skirt.
I'm back in there. It's a shame we can never, ever speak again.
What we do here makes a difference. I love working here.
Why? I mean, why?
I love every single person who works here. We're one big happy family.
We've got to jump her.
Oh, good morning. How you doing? How you guys doing? Good morning. Good morning. Good morning.
They take away the free coffee, I'm out of here. I'm lying, I'm not going anywhere.
I know.
Now serving PT.35, October 13.
You have no idea how hard it is to be a single woman in her 30s, okay?
Is it any harder than being a black man in the 60s?
I don't know. Is it? I mean, no. I'm so sorry.
Here's an image of a pretty common data center where you have rack after rack after rack of equipment, and you can see there's a lot of equipment on one row of this, and there are many rows in this particular data center. There is a lot of technology in this data center, and there are many different services running on each of these individual racks. In this video, we'll look at different services that you might expect to find in a data center like this one. We're all very used to typing in a website into our browser address bar, so we might go to google.com or professormesser.com. But behind the scenes, there is some work done to convert that fully qualified domain name to an IP address. The device that's doing that conversion is a DNS server. DNS, of course, stands for Domain Name System, and it's responsible not only for resolving an IP address from a fully qualified domain name, it can also provide that same service in reverse and provide much more as well. This is a distributed platform with thousands and thousands of DNS servers running on the internet at any particular time. And the load across these DNS servers is distributed primarily based on the domain names that they support. So there are a group of servers that support ProfessorMesser.com, and anytime you type in my website, it accesses either those servers or a cached version of information from those servers to be able to provide you with the appropriate IP address. This is something that's usually managed by your service provider, or you may have a number of internal DNS servers that's managed by your local organization. Another important service is DHCP, or Dynamic Host Configuration Protocol. This is the protocol that's able to automatically assign IP address and other configuration settings anytime you start your computer. You don't have to remember IP addresses or type anything in. DHCP will take care of all of that work for you. This is a widely used service that you will see not only in a local network at home, but also the networks that we would use in our enterprise. And in the enterprise, we tend to have multiple DHCP servers for redundancy. If one DHCP server is suddenly unavailable, we have other servers that can still provide IP address information for devices on the network. File sharing provides a way to centrally store information so that you and other people in the organization can easily access it. This is a great way to share spreadsheets, documents, and anything else that you need to share with other people within your organization or with people that may be outside of your organization. There's usually a standard type of file service. If you're running in Windows, you probably have a service that is using SMB, or Server Message Block. If you have Mac OS in your environment, you're probably using Apple Filing Protocol. There are many different standards for sharing information, and it depends on the applications and the operating systems that you happen to be using. Most of the time, you don't even know if you're using SMB, AFP, or some other type of file sharing system. The operating system tends to hide those protocols, so all you see is a file management front end where you can drag, drop, rename, and modify the files that are stored in that folder. Although a great deal of our work is done digitally, there are still times we need to print information onto a piece of paper. To be able to do that, we're going to use a printer, but we need some type of service that will manage the process of receiving these print jobs, queuing them up inside of the printer, and then making sure that all of those print jobs print successfully on those printing devices. Sometimes this is a separate computer that is connected to the printer, and that separate computer is running the print service software. Or it may be built into the printer itself. There may be a network card that you slide in That card not only provides your interface to the network, it also provides the print service software.
What's the secret to peak health?
Going micro with Noom.
Micro habits, micro wins, even microdose GLP-1s.
Micro? I can do micro.
With Noom, we all can.
I'm doing it. I'm going micro.
I can do micro.
It's micro season, baby.
Micro changes, big results. Get started at noom.com. Do not micro poop on my shoulder.
Get fresh groceries delivered to your door with Kroger Delivery proudly serving King Soopers.
If you were to look at the documentation for your printer, you'll probably see that it supports a number of different protocols for printing across the network, such as SMB, which is Server Message Block, IPP, which is the Internet Printing Protocol, and LPD, which is the Line Printer Daemon. Email continues to be one of the most popular applications used around the world. And of course, we need email servers so that we can send and receive these email messages. These email servers may be in the cloud and managed by your internet service provider or cloud service provider, or you may have local email servers in your own data center that you're managing yourself. This is one of those rare services that has a very high uptime expectation. You always expect your email to be flowing, and you always expect there to be access to your email messages. And as system administrators, we have to make sure that we're planning, designing, and implementing email services so that they are available as much as possible. If you're managing switches, routers, servers, firewalls, and almost any other type of device on your network, then you're probably collecting log files on all of those devices. Often you'll want to consolidate all of those log files back to one central database. And the protocol that allows you to do that is syslog. There's usually a central server called a SIM that stands for Security Information and Event Manager. The SIM is a central consolidation point for all of your log files, and it allows you to correlate information together even across very diverse systems. Since you're bringing back a lot of log information to one central point, it's very common that your syslog server have a lot of log space available because you will be keeping logs for a very long time across many different systems. If you're accessing information from a browser, then you're connecting to a web server. A web server is one that responds to all of these browser requests and generally is using the HTTP or HTTPS protocol. That, of course, is the Hypertext Transfer Protocol and Hypertext Transfer Protocol Secure. Developers build pages in a protocol known as the Hypertext Markup Language, or HTML, and those are web files that are stored on the web server. Your browser accesses those files, interprets the HTML, and presents to you the graphical display in your browser. If you've ever connected to your corporate network and provided your username and password, then you've probably interacted with an authentication server. You'll sometimes hear this referred to as a AAA server, which stands for Authentication, Authorization, and Accounting. The primary job of the authentication server is to check your username and password and then provide access to whatever services you might need. This usually has a centralized database so that you can easily administer all of the users on your network all from one central point. You don't generally see an authentication server on a home network, primarily because there's not a lot of services that you would need to connect to, and secondly, we usually will just use a username, password, and share that among our family members. But in an enterprise environment, we have to provide the highest levels of security, and we do that by making sure that everyone has their own set of credentials. Since the authentication server is an important step to gain access to every other resource in the organization, we usually create redundant authentication servers so that if one happens to fail, we're still able to authenticate. Most organizations are collecting a lot of different types of information, and we need somewhere to store that information. One of the most common places is a database server. Database servers store information in database tables. You can think of these tables as a very large spreadsheet, and they have the ability to connect tables to each other to form a relational database. That way you can have separate links where different types of data have relationships to other types of data in other tables. This creates relationships between different tables and allows you to easily link data together and find exactly what you're looking for. A A standard language used to store and retrieve information from this database is known as structured query language. You'll hear this referred to as SQL or SQL. You'll see SQL mentioned in some of the popular database servers such as Microsoft SQL Server, MySQL, and others. Have you noticed that the time and the date on your computer is always very accurate? We're able to get that level of accuracy because your computer is talked to an NTP server or Network Time Protocol. This is more important than you might think because we use time for so many different things on the network. Not only to compare log files across multiple systems, but many of our encryption technologies require that all of your systems are running with the correct date and the correct time. We will generally have one or more NTP servers running. They are referencing a central clock so that all of them have exactly the right date and time. And then on your local computer, whether you're running Windows, macOS, Linux, or any other operating system, there's an NTP client. Your NTP client is configured to access a particular NTP server, and it checks in with that server periodically to make sure that the date and time are always accurate. All of us have received unsolicited emails known as spam, and often we have a separate filter that puts spam into a separate folder or keeps it out of our inbox. We're able to perform that function thanks to a spam gateway. This is often a separate service that's in the cloud or on a separate server that evaluates every email message that's coming in, determines if it might be legitimate or might be spam, and then categorizes it properly in your email system. You'll notice sometimes that you have to go into your spam folder to see if you can find legitimate messages because this process is not 100% accurate. This is an important service that keeps the unsolicited information away from your eyes and allows you to focus on what's important in your email inbox. Many organizations will put an all-in-one security appliance on the outside of their network between them and the internet. Sometimes we refer to this as a next-generation firewall, a unified threat management system, or UTM, or perhaps a web.
Good question, Lee. I don't remember anything about distance ranges, like range for 2.5. 2.4 or 5 that you need to know. They usually ask which ones goes further, which is 2.4. I think they have more questions about distance or proper cabling to use. CAT cabling. That, I think that was more prevalent than the Wi-Fi distance. So 100 meters typically for most CAT cable. Until you get the Cat 6 augmented, it could be 55 meters. Yeah, it'd be 55 meters, half the distance. If you're pushing more data. Yeah, so you gotta look out for that for Cat 6A.
And there might even be VPN functionality that allows you to connect securely to other sites or to have end users connect directly to this device over a secure channel. One of the ways
You're correct, Charles. So yeah, it depends on the speed and the megahertz
is to have
for the cable.
Running on a load balancer. Load balancers are designed
let me take my mental Rolodex when I see anything about megahertz for the cable.
And be able to share
I don't remember megahertz for the cable. Do remember distance.
So an organization might build a web server farm with multiple web servers, and they have those web servers connected to a load balancer.
Is it normal within 100
incoming
meters?
requests are received, those requests are distributed evenly across all of those servers.
It's normal. Typically, it's 100 meters. A lot of them are typically 100 meters.
Yeah.
You'll have to have a repeater in the middle to reboost the signal if you go past that.
Yeah.
So you have to hook it up to something, and then it reboosts the signal to continue the signal if you ever had to do that. So you're correct. You can have a more than 100-meter run, but you better have something in the middle that's gonna reboost the signal for the network.
That it's back in service and begin sending additional requests to the server now that it's up and running. This process occurs very quickly, and the end users have no idea that an outage even occurred.
I like that Rolodex picture.
Some organizations will take advantage of a proxy server for either inbound or outbound communication. A proxy server receives a request from
Good morning, everyone. It's Friday. Just comment some good stuff. And I also just created my Instagram. So now you can click on any one of my videos, scroll down in the description section, and you'll see my Instagram link. So you can start going there and show your support as well. Follow me there. So I just created the Instagram mainly for you guys in here, so you can text me, text or message me on there. And a lot of the stuff I will be posting in combination with this channel as well. So a lot of some of the stuff that you don't see on this YouTube channel, you will be seeing it on my Instagram.
SCADA is the Supervisory Control and Data Acquisition System. You might also see this referred to as a Industrial Control System, or ICS. So if you work for a company that provides power services, maybe you work in the oil and gas industry or a manufacturing company, you're probably very familiar with controlling that large-scale equipment using the SCADA technology. This is a specialized system that allows you to view, manage, control, and maintain these systems remotely. And it does it all across the network, which obviously means that we need a very secure network so that no one else gains access to these very valuable and in many cases, very important systems. Most organizations with these SCADA systems will have a completely segmented network that is only accessible either by physically visiting that particular part of the network or accessing it through a very controlled system. One of the interesting characteristics of technology is once you set it up and turn it on, it will go forever as long as it has power and the system continues to be working properly. And it's not unusual to walk through a data center and see equipment that was installed 10, 15, 20 years ago, or even longer. We usually refer to these older systems as legacy systems. Just because something is old doesn't mean that it's not important. And in many cases, these legacy systems can be very important, which is probably the reason that they haven't been swapped out already. And you may find that learning how to manage and maintain the legacy system can be just as important as managing and maintaining the brand new systems. Another important service might be an embedded system. An embedded system is a purpose-built device where very often we do not have direct access to the operating system that is running on that embedded system. For example, if you think about a fire alarm system or a time clock system, these are usually self-contained units where you are interacting with those devices on a daily basis, but you don't directly interact with the operating system. It's up to the manufacturer of that equipment to provide you with the tools to support it, but very often it's a system that doesn't require a lot of ongoing maintenance. The manufacturer of the system will usually give you everything you need to be able to keep that system up and running, but very often you don't have to do a lot of ongoing maintenance with an embedded system. Another category of services that has become very popular are IoT devices, or Internet of Things. This is a broad category of devices, which could be appliances such as refrigerators or coffee makers. It might be smart
Just want to make sure everybody did get the measurement notes right.
And have it perform a series of functions.
That was,
Or
okay.
maybe this deals with air conditioning or heating controls within your organization. Some IoT devices can provide access through a doorbell or a garage door. And one of the challenges with IoT devices is that the companies making refrigerators or speakers or thermostats are very good at making those appliances and air control systems, but they may not be good at connecting to networks and maintaining security of those networks. For that reason, you may want to put these IoT devices on their own segmented network to limit any access that could occur should someone gain access to an IoT device.
My hard drive's in the garage on my other computer. I got like 5 computers around here. So I got to go down there and get it, plug it up, then hook up a link so y'all can download it. Here is the cider cheat sheet, just in case y'all need it. Put that in your Rolodex.
As a baby, typically you say ready before you throw it.
Disney Plus, Hulu, and all ESPN. 3 All-Stars, 1 incredible offer.
You here for Tracy?
We're here for everyone. Limo and I help people save hundreds by customizing car insurance with Liberty Mutual.
We ordered a limo. That'll do.
Oh yeah, we do that too. At your service. Only pay for what you need.
Liberty, 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 liberty.
DNS stands for the Domain Name System, and this is one of the most critical resources and services available on our networks. That's because we use DNS to be able to provide IP addresses when all we remember is a fully qualified domain name. For example, you can type into your browser www.professormesser.com, and behind the scenes, a DNS resolution occurs that translates the name www.professormesser.com into the IP address that is associated with that particular web server address. This means that we don't have to remember any specific IP addresses. All we have to remember is the name of the server that we want to communicate to. Behind the scenes, DNS will make sure that we're able to connect to that IP address. DNS provides this resolution and many other features as well, some of which we'll learn about in this video today. This DNS database is a hierarchy that allows us to find the IP address of any fully qualified domain name on the worldwide internet. We refer to DNS as a distributed database because this is a database that is scattered throughout the entire internet. Portions of this database are contained on different servers located on different networks around the world. If we were to drill down on the specifics of the DNS standard, you would see that there were 13 separate root server clusters. This cluster is more than simply 13 separate servers. In reality, there are over 1,000 servers making up that root server cluster. That root cluster allows us to then communicate with DNS servers that are handling top-level domains. These generic top-level domains, or GTLDs, are the ones that you might recognize: a .com, a .org, a .net, and so on. You might also see these top-level domains separated by country. There are about 275 country codes. For example, the United States is the .us domain, Canada is .ca, the United Kingdom is .uk, and so on. When we say that the DNS database is a hierarchy, this is a visual representation of what we mean. Underneath the top-level domains is a domain name such as ProfessorMesser.com. And you'll notice there's the .com, and just under the .com is the .ProfessorMesser. You can continue to add layers to this hierarchy. For example, our web server at Professor Messer is www.professormesser.com. We might also have a mail.professormesser.com, and so on. And of course, you can have individual servers and devices underneath those domain names as well. So you can have a katie.east.professormesser.com or a judy.west.professormesser.com. This allows you to organize your DNS infrastructure into a way that makes sense for your organization and have it accessible to anyone in the world. If you wanted to get some insight into how a particular DNS server might be configured, you might want to use different tools to be able to access that database. One of these tools is the dig command. Dig is a common command on Linux and Mac OS, and some versions of Windows also have a dig version that you could install. Dig allows you to perform a query against a DNS server. So if we dig www.professormesser.com, we get the results that are on this page. It shows us what commands we are using, gives us exactly what question is being asked of that particular DNS server, and then provides answers to the question that was asked. In this case, making a query for www.professormesser.com results in 3 separate IP addresses being returned. This represents the 3 possible addresses you could use to communicate to our web server. The reason we get 3 separate IP addresses in the results is that we've created a redundant series of web servers, so that if one IP address is suddenly not available, you can use any of the remaining IP addresses to communicate to our web server. If you're on Windows, you can use the nslookup command to provide the same information. For example, nslookup of professormesser.com will return the same answers with the same 3 IP addresses.
At King Supers, you never compromise. You get up high quality that's guaranteed fresh and down low prices on over 1,000 items. With quality and savings that add up, King Supers shoppers never compromise. King Supers, fresh for everyone.
Whataburger Bacon Wrangler Double. It's got 2 fresh beef patties, crispy onion strings, football, bacon, honky tonks, Monterey Jack, and American cheese, rodeos, and Chipotle aioli. It's the Texiest thing in Texas. Whataburger.
When we make that query to the DNS server, we are returned information that is contained within the records of that DNS database. Those records are referred to as resource records, or RR. Those resource records contain information about the IP addresses we'd like to query, their certificate information, email details, host alias names, and much more. This is one of the reasons that we often say that a DNS configuration is not something you should toy around with if you're not familiar with what you're doing. One mistake made to the database inside this DNS server could cause one or more of your devices to suddenly become unavailable to anyone else on the internet. If you are going to make a change to a DNS server, just keep in mind that you should always have a backup and a way to easily revert to that backup if you run into any problems. If you manage your own DNS server, then this will probably look familiar. This is a configuration of a DNS server. You can see there is an SOA record at the top, an MX record, some A records along with that, and CNAME records also at the bottom. In this video, we'll go through each of these different record types so that you'll be familiar with why we would add that information into our DNS server config. My DNS server doesn't provide me with a way to look at the raw text configuration file, but there is a web-based front end that I can view. So this is the same information, but it's from a web front end for my DNS server. From this web-based front end, I can add new records, I can modify the records that are already here, or make any changes that I need to in my DNS configuration. One of the most common records in a DNS server is an A record. You might also see these as a quad A record or AAAA record. These are records that define the IP address for a particular host name. If you're adding or modifying an A record, that address record is used for IP version 4 addresses. If you're modifying a quad A record, that record is being used for IP version 6 addresses. To be able to see what this might look like in a configuration file, I have a record here for my web server, www.professormesser.com. This is an internet address or IP version 4 address, and the A specifies that this is an address record. And the other part of this record shows it to be 162.159.246.164. That is the IP address that I would like returned to an end user if they request it for www.professormesser.com. So if someone sends a request to a DNS server and asks, what's the IP address of www.professormesser.com? This record is accessed and it provides the answer of 162.159.246.164. If you're not editing a DNS server's text-based configuration file, then you might be adding a record through the web-based front end like I do. I'm adding an A record. The name of the host is www. The IP address is 162.159.246.164. And the time to live, which is how long someone will remember this IP address, is set to 15 minutes. After 15 minutes, this record will time out from a user's workstation, and they will need to re-request that IP address to continue communicating to www.professormesser.com. This allows me to make changes to this IP address at any time, and I know that all of those changes will eventually be rolled out across the internet in no more than 15 minutes. The process for adding a quad A record is very similar. We specify a quad A record, the name of the device, the IP version 6 address that we'd like to use, and the time to live that we would like associated with that record. There may be times when a particular server is referenced using different names. For example, you might have one server that's used as a web server. That might also be your DNS server. It might also be an NTP server, and it also might be a mail server. But instead of referencing that server with a single name, we can use different names to associate the different resources. For example, if you have a server called mail.example.com, you might also want to use canonical names or CNAMEs for that server for chat, FTP, and www. This means every time somebody references chat.example.com, ftp.example.com, or www.example.com, they're all really communicating to a single server called mail.example.com. This makes it very easy to administer. If you ever need to change the IP address of mail.example.com, you simply change the A record for mail.example.com, and all of the canonical records can stay exactly the same. One of the most critical records on any DNS server has got to be the MX records. This stands for the mail exchanger records, and these make sure that you're able to both send and receive email messages from your domain. The MX record itself is relatively straightforward. It starts with an IN for the internet. MX stands for the mail exchanger record, and then you simply
All right,
of the mail server.
all right, I have a series of questions and answers that I'd like to go through.
Send an email message to james@professormesser.com. They reference my mail server to see where the MX record is, determine the name.
Okay, here are the questions, and I will give you the following answers after. Here is the first question. What will a layer 2 switch do when the destination MAC address of a receive frame is not in the MAC table? Now, here are the answers. It notifies the sending host that the frame cannot be delivered. It initiates an ARP request. It forwards the frame out of all ports except for the port at which the frame was received, or it broadcasts the frame out of all ports on the switch.
So it's truly a perfume for you. You know, why don't you here? You're welcome.
In this particular case, that remote email server would reference our DNS. They would see that there is an MX record specifying mail.example.com.
Yes, moving on to the next question.
Mail.example.com is 123.12.41.41.
Which network device has the primary function to send data to a specific destination based on the information found in the MAC address table? Now, here are the answers: router, hub, switch, or modem.
.hostedemail.com. By using this front end, I'm able to make changes to that MX record to be able to send mail exactly where I need it to go. If you're configuring your MX record through a web-based front end, then it's the same editing process we've already used, where we would choose the name of the record, specify.
All right, thank you. Moving on to the next question. What addressing information is recorded by a switch to build its MAC address table? Now, here are the answers. The source layer 3 address of outgoing packets, the destination layer 2 address of outgoing frames, the source layer 2 address of incoming frames, or the destination layer 3 address of incoming packets.
Human readable text records that anyone could reference from our DNS server, and we'll look at an example of those in just a moment. Sometimes you'll see these DNS records being used for verification. Often you'll be configuring an email setting, and the email.
Yes, now moving on to the next question. What is the purpose of the FCS field of in a frame? Now, here are the answers. To compute the CRC header for the data field, to verify the logical address of the sending node, to determine if the errors occurred in the transmission and reception, or to obtain the MAC address of sending the node.
With a dig professormesser.com and then specify TXT. It will then show you all of the different text messages that are currently configured on my DNS server. In this example, there are two text records that appear, one for a stripe verification and another one that's being...
Yes, thank you. Moving on to the next question. What is one function of a layer 2 switch? Now, here are the answers. Determines which interface is used to forward a frame based on the destination MAC address. Learns the port assigned to a host by examining the destination MAC address. Forwards data based on the logical addressing, or duplicates the electrical signal of each frame to every port.
I mentioned earlier that we often use these text records to be able to minimize the amount of spam that someone might receive, or to be able to verify that the email messages that have been sent really did come from your domain. One of the ways we do this...
Yes, thank you. Moving on to the next question. Which information does a switch use to keep the MAC address table information current? Now, here are the answers. The source and destination MAC addresses and the outgoing port, the destination MAC address and the outgoing port, the source MAC address and the incoming port, the destination MAC address and the incoming port, or the source and destination MAC addresses and the incoming port.
From the Professor Messer website are digitally signed with my private key. When another mail server receives an email that I have sent, it sees that that message has been digitally signed. It then can refer to my public key.
So, moving on to the next question. What information does a switch use to keep the MAC address table information current? Now, here are the answers. The source and destination MAC addresses and the outgoing port, the destination MAC addresses and the outgoing port, the source MAC address and the incoming port, the destination MAC address and the incoming port, or the source and destination MAC addresses and the incoming port. Yes, thank you. Now, moving on to the next question. What process is used to place one message inside another message for transfer from the source to the destination? Now, here are the answers. Flow control, decoding, the source MAC address, and the incoming port, encapsulation, or access control. Yes, thank you. Moving on to the next question. Which three fields are found in an 802.3 Ethernet frame? Now, this question requires three answers, and here are the answers. Frame check sequence, source physical address, destination physical address, source logical address, destination logical address, or media type identifier. Yes, thank you. Now moving on to the next question. What will a host on an internet network do if it receives a frame with a unicast destination MAC address that does not match its own MAC address? Now here are the answers. It will discard the frame. It will strip off the data link frame to check the destination IP address. It will forward the frame to the next host, or it will remove the frame from the media. Yes, thank you. Now moving on to the next question. Which statement is correct about Ethernet switch frame forwarding decisions? Now, here are the answers. Switches build up their MAC address table based on the destination MAC address of incoming frames. Frames addressed to unknown MAC addresses are dropped. Frame forwarding decisions are based on MAC addresses and port mappings in the MAC address table, or unicast frames are always forwarded regardless of the destination MAC address. Yes, thank you. Now moving on to the next question. What criterion must be followed in the design of an IPv4 addressing scheme for end devices? Now, here are the answers. Each IP address must be unique within the local network. Each IP address must...
You were good. We have that verified. I will put that in for you.
Let me rephrase all the answers. Each IP address must be unique within the local network. Each IP address must watch the address that is assigned to the host by the DNS. each IP address needs to be compatible with the MAC address, or each local host should be assigned an IP address with a unique network component. Yes, thank you. Now moving on to the next question. How many octets exist in an IPv4 addresses? Now here are the answers: 16, 8, 32, or 4. Yes, thank you. Now moving on to the next question. Which two parts are components of an IPv4 address? Here are the answers: broadcast portion, logical portion, physical portion, host portion, or network portion. Yes, thank you. Now moving on to the next question. What is the purpose of the subnet mask in conjunction with an IP address? Now, here are the answers: to mask the IP address to outsiders, to determine the subnet to which the host belongs, to uniquely identify a host on a network, or to identify whether the address is public or private. Yes, thank you. Now moving on to the next question. A technician is setting up equipment on a network. Which three devices will need IP addresses? Now here are the answers: a wireless mouse, a PDA that is attached to a network workstation, a printer with an integrated NIC, a server with two NICs, an IP phone, or a web camera that is attached directly to a host. Yes, thank you. Now moving on to the next question. Which statement describes the relationship of a physical network and logical IPv4 address networks? Now here are the answers. Any device on different IPv4 logical networks can communicate with each other if they all connect to the same switch. A local network supports one IPv4 logical network. A physical network can connect multiple devices of different IPv4 logical networks, or all devices connected to a physical network need to belong to the same IPv4 logical network. Yes, thank you. Now moving on to the next question. Which statement describes the relationship of a physical network and logical IPv4 address networks? Now here are the answers. And devices on different IPv4 logical networks can communicate with each other if they all connect to the same switch. A local physical network supports one IPv4 logical network. A physical network can connect multiple devices of Yes, thank you. Now moving on to the next question. How large are IPv4 addresses? Now here are the answers: 64 bits, 16 bits, 8 bits, 128 bits, or 32 bits. Yes, thank you. Now moving on to the next question. What is the network number for an IPv4 address 172.16.34.10 with the subnet mask of 255.255.255.0? Now here are the answers. 34.10, 172.16.34.0, 10, or 172.16.0.0. Yes, but before moving on to the next question, tell me why the 34.10 was replaced with 0.0. Okay, yes, thank you. Now moving on to the next question. What are two features of IPv4 addresses? Now here are the answers. An IPv4 addresses contains 8 octets. IPv4 is a logical addressing scheme. An IPv4 addressing scheme is hierarchical. An IPv4 address is bound to a network interface card to make it unique, or IPv4 addresses are only used for communication on the internet. Yes, thank you. Now moving on to the next question. What are two features of IPv4 addresses? An IPv4, here are the answers. An IPv4 addresses contains 8 octets. An IPv4 address is logical addressing scheme. An IPv4 addressing scheme is hierarchical. An IPv4 address is inbound network interface card and make it unique. Or an IPv4 address are only communication on the internet. Yes, can you repeat those two answers for me?
All right, before we go to break, save that link I just put in the chat. This is going to help you. Not just this course, but other ones. This is 101 Labs, the website. Okay? They walk you through. Okay. They walk you through free. You already got the books, most of the books, but they have free labs in here. They walk you through. Credential harvesting, webs, in-map, just different things. They'll walk you through. I actually have another book for Sec Plus, and I have a CYS 101 Labs. Y'all getting the whole thing from me. Listen, better get some good reviews on them. Bribe y'all or something. Listen. No, but it's free stuff. So please use these tools, the hands-on. It's good. They also have free 101 Lab courses that you can go through. So take advantage of that if it's something you don't know. Now, I don't ask y'all to go through all the labs. If you don't have time, you don't have time. But target your learning. You know if there's something where you're weak at or you just don't know, then take that one thing and go do it. You know what I'm saying? So I'm not asking you to sit down and do all of them because we all have a different way of studying. But at least target what you kind of shaky on and do that. That'll help you out a lot. All right, so let's go ahead and take a break. See you in 10 minutes. And we'll get started with the class when you get back. And Aaliyah just dropped another tip, so take a peek.
Yes. Now moving on to the next question. Consider the group of 5 IPv4 addresses, each with a subnet mask cap 255.255.255.0. Which two IPv4 addresses belong to the same local network? Now here are the answers. 192.167.10.74, 192.260. So let me give you all the answers pertaining to that questions. So the first one is 192.167.10.74, 192.168.10.156, 192.168.10.16, 192.168.100.62, or 192.168.10.2. So according to the answers that was provided, there is not a given answer that is the 192.168.10.155. The closest one that is closely associated to that is the 192.168.10.56. Okay, thank you. Now, here moving on to the next question. Which technology is required to enable computers on different logical networks to communicate with each other? Now, here are the answers: routing, switching, hosting, or mapping.
Get your favorite OGIT. In effect, boy. Your favorite OGIT. What? In full effect on Friday. Got my spinner gold. Look at this. Got this from Cash Money Records when I was signed with them. It's a hot mess. Leah like, this is a hot mess. That's what we do here. I'm the IT from the streets. Got my nerd glasses on. Don't mess with me. What we got going on? I thought that was a clock change. Like Flavor Flav. Funny story. Me and my wife went to go see Wu-Tang, right? So, yeah, we went to the Wu concert. So when we were there, my wife sees Flow Rider, right? Flow Rider said, oh, go take a picture. She said, you want a picture? I said, I am not going to take a picture with a 6-foot dude. No, you go take it. So she takes me. Then Flo was like, you want to meet Flav? Flav was right there. So she's taking pictures and hanging out with Flavor Flav and Flow Rider. Then they called me over. I'm like, hey, what's up, y'all? So we at the back of the venue.
How are you guys doing? It's Friday. Go ahead and leave your comments. Let's interact a little bit.
We went to our seats. Who comes to hang with us for the rest of the concert? We got Flo on one side and Flavor sitting in regular seating the whole Wu-Tang concert. I'm like,
yeah.
Who does that? I'm like, y'all know y'all could go up there. Yeah, we like it back here. They was just chilling.
Yeah.
I'm like, okay. So we got pictures with them.
Nice.
Right? They just regular people just like us.
Yeah.
They were like, we just want to blend in. We don't want to go up there. But Flav is one of the biggest Wu-Tang fans ever. All right.
Yeah.
We are back. Thanks for joining us, boy. This is James, the OGIT. Thanks for joining us for another street lesson. Today we're going to be talking about...
Can I say one thing before you start? My only brush with a rapper star was Redman. I walked into a Best Buy one day, and I was in Georgia. I walked into a Best Buy, and Redman was there supposedly doing autographs. And I had to go, but it was like closing at the same time. And I was like, Redman's here? He's like, yeah, he's just, whatnot. So I heard that he was tall. so I'm trying to look to see where he is, kind of ducking through the aisles. I finally found him, and I looked, and he looks at me, and he saw me say, this motherfucker is tall. And he laughed. I was like, oh, he recognized what I said. And I did that. He was really tall, though.
Yeah.
It was just funny. I was like, wow. So after that, I just went ahead. So
yeah, Redman. How tall is Redman?
Let me see.
You're like 6 foot or something like that. 6 foot. Well, yeah. I remember I met Ronnie DeVoe from New Edition when I was doing loss prevention for Target. 6'1". I didn't think he was that tall. Wow. Okay.
Yeah, that's pretty tall.
I was doing loss prevention for, and I was on the store on Cobb Parkway down by in Cobb County. So everybody would come through there. Robin Givens, Allen Iverson, like that was the one that they'd run through.
Yeah.
I really didn't care about them. So I'm walking around the store looking for shoplifters. I look and I say, that's Ronnie DeVoe from New Edition. I'm like, so his wife was standing there. I was like, are you Ronnie's wife? She's like, yeah. I said, can I walk up, can I interrupt y'all personal time just to walk up to your husband and say hi?
Yeah.
You got to go through the wife, man. You just can't roll up on Ronnie DeVoe.
Yeah.
She's like, yeah, go ahead. She said, Ronnie, baby, somebody wants to say hi. So he stood up. He was in the pillows. He had 2 pillows with that Boston accent. Hey, y'all. Like, Ronnie, man, I just want to say what's up, man. Thanks for the memories. That's all I said. Walked away. He's like, no doubt, no doubt. Went back to what his kids was doing. And what,
Yeah.
yeah, he's a tall dude too. He's about 6'1". Yeah, he's pretty tall. Crazy stories. Thanks for sharing, everybody. All right, so that's what we're going to get into today. This will be, I wouldn't say a short lesson, but it's a good lesson, about 40 minutes. Just to go back over networking and security, and as far as comparing remote access methods, VPN. Now, I will, disclaimer, when we go into this, it's a reminder, we learned about VPN before, but now we're going to introduce like certificates and different ways and different tunneling that comes along with it. Is to set the expectation for the exam. A lot of stuff we're going through with this lesson, you won't see in the exam. You'll see the typical 3389 as the port.
Yeah.
Certificates can be used when creating the tunnel in order to go through the radius server. You know, different things like you're normally accustomed to.
Yeah.
So don't think you have to do a deep dive to learn everything about this lesson. If there's anything in here you should know, I'll make sure I point it out. Is that cool?
Yeah.
All right. So as we go through here, domains 1 point, well, you got 1 and 4 and 5, comparing network appliances and applications and functions. Then we'll talk about ports, protocols again, and services. Again, basic security, because now we're in Net Plus, about to flow over into Sec Plus, so it starts to introduce some type of security that you'll use. Defense techniques and some troubleshooting. So as far as the troubleshooting concerned, yeah, I'd say pay attention to that too when we get to that. So let's talk about the remote access methods. If anything, you have to think about these two things here: remote access considerations and implementing a remote access policy. When it comes to the consideration, first of all, you should know who's working from home and who's not, who's approved and who's not. But you have to authorize access only, and you want to make sure you do strong identity verification. Now, I brought this word up the other day, which is identity and access management.
Yeah.
Right? You have to make sure you have strong identity and access management. So when Big Sugar come and want to get on that VPN, y'all have already verified me, right? Through the Active Directory, the LDAP, and the radius server. Use the VPNs because VPNs, we know it is encrypted traffic. Okay? It's automatically encrypted traffic, uses a private tunnel over a public network. Please remember that term. VPN is a private tunnel over a public network. You want to implement secure remote devices? Anti-malware needs to be implemented on the radius server and the VPN servers. For the policy, here's some things you want to think about. Role-based access. Now, we've seen this before. Elaine said is that also considered? Yes, you have encapsulation. The sandwich analogy will apply. You're correct. It will. I like the way. See how we're talking about the sandwich. We're talking about the sandwich today. So it does apply. The tunnel will be built, and then you have to make sure you have IPsec in there.
Yeah.
Please remember, when you want to add additional security, you have to go into these switches and stuff, and you have to add it. Remember we were talking about that yesterday, Martin and Leah? You have to add to some of this stuff. You have to go in and configure to add.
Yeah, like
some is
manually
generic that
configure.
comes with the protocol, but sometimes there's more stuff you have to do.
Yeah.
Okay, please remember that. You're gonna have to look at the access logs constantly to make sure nobody's getting in that you don't want there, and then you have to do your regular network updates. So never forget that. Let's get into the tunneling protocols. Virtual private network tunnel. Secure data passes across the public networks. We talked about that. There you go. lane encapsulation.
Yeah.
Encapsulated packets within the packets for security. So when it goes inside that tunnel, that data is already starting to be wrapped. But when it gets encrypted, it gets wrapped again,
Yeah.
and then it gets sent through the tunnel. Where is that data vulnerable, people? Is it truly safe?
Nope. Endpoints.
You got it. Endpoints. Each end is vulnerable. When it's in the tunnel, okay, nobody can touch it. But at the ends, the entry and exit points are the most important that you have to pay attention to make sure nobody's tapping the line.
Yeah.
All right. Ensure the sender or receiver has exclusive access. Nobody's in the middle, which they call an on-path attack. We don't want that. And of course, it's going to go through the various layers of the OSI. So let's take a look at what we're doing. Here's some tunneling protocols. Yeah, what? PPP. That's on the exam.
The point-to-point
right there.
protocol.
I'll remember seeing that one. All right. But that was a little sloppy. Let me clean that up a little bit. Chicken. All right. So point-to-point protocol. See that on the exam? Of course, point-to-point is going to use the data link layer operation because that's the link local, right? Point-to-point. That's, to me, straight to a lane, right? Can anybody remember the numeric value for the best route for a point-to-point directly connected? What is it?
Oh, it's...
Dang it! God, Charles, you pay attention too much.
Yeah.
It is 0.
Yeah.
If you see this on the exam, he says sometimes. If you see 0 on the exam for quality of connect, oh, that's a point-to-point connection. Yep, ad hoc. Point-to-points are used for digital lines, but you say it does not have security. It has security, but not inherent. It's not inherited. It's not like it's already there waiting. You have to implement more security to make it get it? All right.
Okay.
Then you have what they call generic, I've seen this too, generic routing encapsulation. That's at the network layer. So layer 3. It's a wide protocol used already. All right?
Yeah.
So basically, generic routing encapsulation looks like this. Okay? It's out of the box. It's already built into the protocols. No matter what you're doing, it's some sort of protection that's already inherently put in there. So when you start doing it, it starts wrapping to be encapsulated and it can go. That's all it is. All right? It comes along with, okay? It's able to use various things that you're doing right now. You're using Zoom, you're checking email, Lane's looking at stocks, you're doing all this different stuff, right? So no matter what you're doing, it uses a wide range of protocols to encapsulate your data in order to be transported. That's all it's doing. Then you have IPsec. Again, it's the network layer focus. Secures IP via authenticate. Now we start introducing, you will see this one. Please associate that with encryption.
Okay.
Okay. Now you have to implement or start making sure IP security is there. And basically you want to authenticate those that need to know and need to access. And you will use encryption to do so. All right? In some form or fashion. Then you have TLS and datagram TLS. So transport layer security and datagram transport layer security is It's on the session layer. So as you can see, now we're getting higher. There's a gap here. Let's see, 1, 2, 3. These are on layers 2.
Layer 2, layer 3.
3.
Yeah.
Now relate that to your OSI model so you can get a visual. Then it jumps. Woo! What layer is layer session? I mean, what did I just say? What layer? Thank you, Fi. What layer is layer session? What? Okay.
How you doing? Happy Friday. Much
Application layer, what layer?
appreciated.
Y'all already had me. Look at this. So it's gonna jump. Pretty much anything that travels between these two layers, data. You can pretty much put all these together. These are all your data. Data's traveling between 5 and 7.
I also include a poll
This
in
is
the
what
chat
your
as
computer's
well.
responsible
You could
for, between 5 and 7.
you could
Because you have
go ahead
layer
and vote
8,
on the
which is
poll
the
as
user
well of
that
the
sits down at the
implementations,
computer and
things that
starts
you'd like to
typing
see on the
directly into the
channel, or
application
things that you'd like to see
right?
me do.
There you go. Then it starts making its way down the OSI model. Y'all are on it today. Look at this. So with TLS, DTLS, you do have increased security. It starts here with the encryption, but you have more overhead because you have to verify even more stuff. And you see it? See the theme that is following? Once you go from 3, 5, and 7, yeah, you're using certificates and encryption as you go up the OSI model, okay? So that's the way you can look at it. Ding! Big Sugar says next slide. Ding! It's Friday. All right, here we go. Now, this is what's happening. You have AH. They call it the authentication header. You'll start seeing AH. Okay, now picture this.
How you doing? Go ahead and vote on the poll that I put in the chat.
Everything has a header. Is that correct? As it goes up and down the OSI model, please finish my sentence for me as I start to talk. As the application layer starts to build the packets or the frame, and they start going down each layer down to the physical, what's being added at each layer as it goes down? Correct. Does the old header go away? No. What happens to it, Mr. T? It stays.
Yep.
Gets sent to the back of the line, though, right?
Yeah.
All right, there you go. Gets pushed back because the other one goes. When you start adding these security protocols, the same thing happens. Inside the header for the security protocol, they start getting added to the header of the frame that starts to travel. Y'all with me? That's like, it's the originated host or header, yeah. So the originated host or header on the inside of there, right? It gets augmented a little bit, and they have to add if there's IPsec in there, right? Yeah. Kevin says everything correct, everything builds on itself. That's sort of like this. We know week 2, he's been eyeballing those pink slippers on Amazon.
Oh, thank you. Much appreciated. Here in class, we have, what is it, Hawaiian Friday. So
from Amazon to his house. But before he checks out, they ask him,
I had something pertaining to that theme. The shirt, something that you would be wearing in Hawaii. For the glasses, it's nice and sunny in Hawaii.
For $2 more, we can send it express. Right? These are things that are added
You can wear a shirt or a hat or a glass. So
It'll augment the header. So no matter what
that's
he
why I'm
orders,
wearing the
that
glasses.
header is already there. But if he adds these
And the shirt
additional
pertaining to the
features
theme we
on
had today
checkout,
going on in
he
class.
still gets the package, but they do the little add-ons, right? That's the same thing with IP set and other configurations, okay? Did that make sense? All right. So with that, with the transport mode, TLS.
Yeah, I looked at the song, and I also looked at a movie that was not a movie, a series that was recommended on Netflix yesterday. I looked at it last night as well.
Header provides IP header integrity. ESP is used and it encrypts the payload for confidentiality. So encapsulating security payload, okay? For IP, Internet Protocol security. Again, you have the IP header here. You have the authentication header that's put there. ESP will be added and they will ensure proper language or proper traffic language is being used for the communication, and right there, they're protecting the payload. All right. Next one. Next, we have tunnel mode. Woo-hoo-hoo. Cool thing about this one, the one before was transport mode, primarily used for private networks. Authentication header protects the payload, correct? All right, so now we got tunnel mode. Tunnel mode is good for VPN networks, for secure communications over public. Tunnel mode, VPN, securing stuff over public networks. Encrypts the entire packet. And the entire packet is treated as the payload. Okay, wait a minute. So this one says the entire package is treated as the payload. Where if we compare and contrast, transport mode encrypts the payload only. Know the difference between the two.
Yeah.
If you're presented this on the exam, transport mode, private network, encrypts the payload, where tunnel mode encrypts the entire packet and is used over public networks, VPN. That's how you want to read it, okay?
Yeah.
Now with this stuff, Big Sugar says you have to configure IP set. You have to select the transport mode or tunnel mode based on the network requirements. Decide if you're going to use an authentication header or ESP. Authentication header, internal traffic. Excuse me. Yeah, authentication header. Yep, internal. I'm like, I don't know why I'm getting backwards this morning. Authentication header. It's going to be used more for private network, ESP over public. Now you got to decide if you want to use an internet key exchange right here, number 3. Or manually configure keys, meaning I want this traffic to be secure, but before we start, we're already going to agree. Me and Charles, we're already going to agree on what keys we're going to use. And we'll make sure that's implemented in the traffic. Or we're going to use internet key exchange, where you exchange your key, I exchange my key, and then from those 2 keys, we create a key. Y'all heard about that, the Diffie-Hellman exchange? We talked about that. So this is when public and private keys come into play, and then certificates for whatever you need to access to give you permission.
Yeah, but that
all of this needs to be negotiated and configured. Yeah, it does sound like a headache. Has to be configured in the authentication servers. That is the key part of this whole thing. Please tell me the authentication servers that you'll see on the network to verify who you. There's one. Radius. Taco Tuesday. TAC-ass. Yeah. Plus. What's the other one? I'm gonna take Kerberos because this is a security protocol.
Yeah.
I'll take it.
Yeah, that sounds like Kerberos.
Yeah, Kerberos. And don't forget the servers that keep track of people and devices. What are those? They need certs too. They get certificates too for you to access. LDAP, there's another. Okay, what's the other one? What's the equivalent to LDAP but for Windows?
What is it?
And LDAP will make sure you have the proper permissions and access to said resources or devices. Lightweight Directory Access Protocol, what port is that? Because you're going to be asked the Active Directory, you're correct. What is the port for LDAP? 636. You're going to see that on the exam. Or 636. Great. Is that the secure port? Let's take a look.
Sir, so
that's LDAP secure. Thank you. That's why I asked. Okay.
Oh, the Active Directory PowerShell. Okay. Active
There's
Directory.
one more. So let's look at this. Let's look at this. Let's recap. Active Directory is to Windows like LDAP is to Linux. I'm gonna tell you why these two go together. Active Directory was created by Windows, so it keeps track of people and resources and what you can do and what you can't do and computers that's added to the network. Yeah. LDAP, it's open source. Seems to team up well with Linux. That's open source. Do they do the same thing?
Basically,
yes. Both Active Directory, do both of them do the same thing?
Yeah, basically.
That's all you need to know. They do the same thing. One is just more open source, one is proprietary. Ooh. Bam. All right. As we move along, we've got to identify Internet Key Exchange. Do we manually want to do that? Or provide keys? Make sure you put in place your policies on how to manage the traffic from host to host. And always test. Okay, you should have somebody always testing your network. Penetration testers or whoever. Big Sugar got a team of testers if you want. Just let me know. They'll show up. They don't turn. The ITOG. I got you. All right, look. You can't unsee this, Mike. Next. Internet. With the Internet Key Exchange. Ike is what we call him. Tina ain't here, but we'll deal with Ike. I know. Bad joke. Listen. Ike says it's a protocol in IPsec for secure communication over the internet. Essential for secure, reliable VPN infrastructure, combines the strength of Ike version 1 and version 2. All right. Now, as the versions get better, the security gets better. Always remember that. When you have newer versions, version 2 is essentially going to start incorporating encryption and certificates for authorization. Yeah. Bam. Rolling in the river.
Yeah.
Purpose, negotiations and establishments of the sessions, mutual authentication, and then again they exchange keys. Here's the difference between 1 and 2. 1, if you want to use the Internet Key Exchange for VPN, it's going to go site to site, host to host. Pretty basic. It's very basic. Site to site, host to host.
Yeah.
it's secure, it's authenticated, it's flexibility and key management. Here's where it gets different. Down here, supports EAP. Who remembers what EAP is for user and device authentication?
So it's
If we're looking at
authentication protocol.
Basically it's saying, yo, I set up the front door to be open. If you can get in, you're in. Ike 2 comes along and says, yo, Tina, need you to do this song again. I know we got site to site and host to host, but baby, we got to make sure we have some EAP in it. We need to make sure that these hosts that are connecting are authenticated. There you go, extensible authentication protocol. Extensible, extend the authentication to the hosts. We just don't want people connected to our VPN. Now, do we, Tina? No, Ike. I thought the same thing. Okay? So, therefore, we need to make sure that when they are authenticating, we have these extra, it's simplified setup. It's good for NAT. And for mobile connectivity, we are making sure that these end items are who they say they are, Tina. Eat the cake. All right? So, when we're putting this together, remember, if you see this version on the exam, please know that this is the better version. Okay? Okay.
Like version 2.
All this stuff's gonna help you remember it on the exam. You know that, right? I've had students say, they sit there and say, James, I remember when you was acting a total fool and you did this one thing and I remembered it. Who's been there before already with me? Anybody?
Yeah.
Say, y'all are not alone. Craziness. All right. Client to site VPN. You're at home, right? Elaine said, I knew he was gonna drop. I knew it. I knew he was gonna drop it. I was waiting for somebody to do it. I thought Jesus was gonna do it. Or B kind of slips him in too. Like, he just, all right. So client to site, you're sending me home. Hi, I'm your new IT OG. I've set up your new computer. You should be able to work from home or go home. I'm gonna tell you a little tidbit. This is what my wife went through. She couldn't connect to her VPN last week. I'm going through, I'm looking at the certs. I went to the cert manager. I said, well, you got 2 expired certs. Look down. I said, they expired yesterday. They gave you new certs. She says, I can't get in. So she's trying to change her password. It was due for her to change her password. Then she got an email 2 days before saying that they changed servers. I was like,
yeah.
Where's the problem, y'all? Let's look at the problem. Should we be looking at this issue from the top down or the bottom up? She can't get in her VPN. Bingo, top down. We're looking at an authentication issue.
Yeah.
It's not a hardware issue. So I went and started there for troubleshooting. And I said, I know why you can't get on the VPN. She says, they should be able to push updates over there. They can't. It's not secure. They're not going to push all these updates that need to get done. The most important ones, they don't want to do that over VPN. They're just going to do minor updates. For security, they want to make sure you come to the job. And I bet when you log on the network at your job,
it updates.
The TACAS and radius server geolocation, they know you're in the building, and then they will allow you to fully change your password.
Yeah.
It's like, why would they do that? To make sure nobody stole your computer. So she goes to work. As soon as she logs in, what comes up? She goes to change her password again. Another prompt came up that didn't come up when she was at home, and it says, are you sure you want to change your password? Welcome to the network at work. Boom.
Yep.
Then they let her change it. I said, I told you. Right? So that is the other IPsec protocols that you can put on that to make sure nobody's getting on your network when they're not supposed to. And she had to hardwire. Couldn't use wireless.
Yeah.
So you had to plug in with an RJ45.
Yep. Connect back to the system.
Right. To make sure that her device was on the access list.
Yeah.
So all these steps you have to go through to ensure that these devices can work. With VPN topology, the client, the person at home connects to the corporate network over VPN. You have to put software on there. Make sure you establish or connect a VPN gateway. And then please have the person log in to VPN from work while they're connected to the work. Why? I just told you why. The very first time you look somebody up, why? Usually I have them turn on their hotspot.
Yep.
And try to connect to the corporate network via VPN while they're at work. We just got done setting it up. Why would we do that, y'all?
Yeah, it's authentication.
Secure connection, and you're correct. You want to make sure you are authenticated, but we're going through another medium to make sure, right? I'm going to have you go in through wireless, and it'll tell us right here and there if you can't get in through your hotspot that there's a problem, and we can work the issue. Once that initial connection gets done, then they can go home and start working. Good stuff. Next, with the VPN protocols and security, you have to make sure you're including SSL or TLS for the VPN. Remember, those are introduced in the certificates. Or layer 2, transport protocol, L2, TP, IPsec, widely used for strong security. Now, there are certificates. That is a certificate. Right. If you look in your cert manager or your search store for your computer, if you've ever VPN'd, or even if you've used when you guys log into my computer, what is that again? When I need help, what is that?
Remote.
There you go, RDP.
Yeah, remote.
Y'all was so quick. So when you RDP, quick assist, you will have an L2 TP cert because you've used it. It is a security protocol that is in RDP and quick assist. Those certs will be in your search store for the machine or the person's profile. Now, I'm gonna help y'all out. Y'all go get out into the wild. Y'all gonna run into this. Y'all gonna be like, I have no freaking clue. I'm gonna tell you this is what you need to do. For all certificates, you got three areas you gotta look at. The local machine. Look at all the certs under the local machine. The person's profile. Look at the person's profile to make sure they have proper certs. Third one, make sure your Active Directory is storing all the certs it's supposed to for the network. It's in one of those three places, something might be lacking. Okay? So you have to make sure they're in all three places and they apply. And for traffic management, you can use split tunnel versus full tunnel. Now, a lot of people get in trouble with split tunnel. Let me give you an example. That's a laptop. This is work. That's a work star cloud. It's a Nimbus Cumulus, okay?
Right, a Nimbus?
It's a Nimbus cloud, okay? It's about to rain. Anyway, you're hooking directly to work. This is work over here somewhere, okay? That's my brother's cat. Oh, Nimbus? Or Cumulus? Nimbus? Okay, yeah. So when you hook up the VPN to get to work, a full tunnel means no matter what you do on that machine, IT has made sure everything is going through here. Everything. No matter what you do on that machine, you have to go in and configure full tunnel. That means you're relying on the whole network to do everything you want to do on that computer. Y'all got, okay, here's where it gets wonky. If I want to save bandwidth on a computer or on a network, this is a full, everything goes. Or I could do what they call a split. Meaning, if it's company data related to company use, you stay in the full tunnel. But the minute you check Amazon to make sure you getting them pink slippers, everything goes through the split tunnel, meaning you're on your own. Does that make sense? If you do anything outside of prescribed company data, it will now go through a split tunnel. It will use your network, your computer's resources to do whatever you need to do. But this is bad. How can this be bad? Split tunnels have a vulnerability. It's not secure. Bingo. Think of it this way. Mr. T's online. He's in a full tunnel. This man is in the middle. He's watching his traffic. Okay? He's at the point where he's made his way right there. Right there. All traffic's going. And Mr. T looks on Amazon. He's watching the traffic. It's not secure anymore. Bam. Now he gets this traffic, credit card numbers, anything he's putting in. Oh, and by the way, if he gets kicked off of here and Mr. T has to log in again, he just got his credentials. So split tunnels are not really, not secure, and it's gone. Yep, he's gone, right? So you have to make sure which one fits good for your organization. I'm probably telling you a little bit more than what you need to know, but you're going to run into this issue right now in IT as soon as you get boots on the ground and get somewhere. So you got to know this is going to be something you're going to see. Mr. T, how many calls do you get for RDP? See, he's laughing. See, it's a common issue. A lot. What's the most predominant question, your top 2 questions you see on help desk? Okay, the password, yep. By the way, he's the admin, so he can reset the password if they get locked out for over VPN. So he's the last line of attack.
Yeah.
Last line of defense, excuse me. What's another one you see a lot? And also, would you agree that RP and RDP is something that people need to know how it works? IT professionals, that is, yeah.
Oh, yes, of course.
All right. So that's what we're looking at. Reset credentials. Yep. So here's the split tunnel example. VPN, everything's going in. Goes through the VPN gateway, goes through the router, hits the enterprise network. See all these firewalls in there? Private facing router, public facing router, VPN. Now, the proper word for the VPN that handles all of these connections that they don't teach you on the new course, and I don't know why, you might see it, it's called a VPN concentrator. A VPN concentrator handles multiple connections from virtual private networks. It's basically like a VPN switch. Okay? So just put that in your Rolodex. You might see it, you might not.
Okay.
Right? So next you'll have, so it's making a tunnel. The minute we said he goes out to the internet, the client's general browsing traffic continues to use the client's machine's internet connection. This is what happens. So LAN traffic, local area network traffic goes. The minute you do something outside of what you need for work, it uses your client resources. And then you're outside the tunnel. Full? Yep, I've captured everything. And if you need to go to the internet, I'll just redirect you to the internet. On the internal network's internet. On the internal, you're already in. I'm gonna allow you to hit the internet through work. All right. Good stuff. Or you can have a clientless VPN, allows access to network resources via the web browser. So you're basically just going in through a web portal, no matter what computer you're working at. That's like, we have web portals set up for it. If a lane needs to get in, there's one, all y'all have done this. They have the Air Force portal for airmen. That's a clientless VPN you can get into. Army, you might have one where no matter what computer you sit in, the hotel, you might have these are specific VPN portals to get to secure information. You still put in your credentials, but when they say clientless, meaning you don't need you don't need this laptop to get onto it. Like, I didn't configure just one laptop that you have to carry around forever to get onto this port, okay? You can log on at any machine as long as you know the web address. You can get in through the web portal. And it'll bring up an RDP pop-up, and then you have to put in your credentials from there. Well, you're talking about anonymous.
Okay.
Yeah, so the anonymous hookup, only if you allow it. If you don't want to allow it on a regular portal that you're trying to get into for a company, you want them to put in their credentials.
Okay.
But yes, you're along the same lines, Lane. Yes, you're correct. You can. The benefits, you have to use HTML5 and above because it supports WebSockets. Simple access across any device you use, be it portable or whatever. And it's a low-cost solution, so you don't have to buy all these computers and people have to drag them around, and now it's a security risk if their computer gets stolen or whatever, right? They can get in through their phone or anywhere. Let's see, use cases, remote desktop using RDP. Yep, Microsoft RDP. Got that. Again, we talked about, here's some things that you get for site to site. Advanced encryption reduces need for individual, and then it's scalable for site to site. Branch office here, head office over here, so it's pretty much site to site. That's what it is. Okay. All right, we got some questions. Which of the following provides origin authenticity through source authentication, data integrity, through hash and confidentiality, and it protects the IP packets? Yep, you're right. IP6. 2, in a client-to-site VPN configuration, what type of setup allows remote users to access corporate resources through a web browser? I see what y'all did there. Y'all left it 1. Instead of typing 1 again, you left it 1. Because it's 1. Y'all super smart. I got what y'all did. See? I'm the ITOG. I've seen it from every angle of the IT streets.
Yeah.
Word for word. New model, right? Yeah. Only when I'm weighing in. Yeah. All right. Are there any questions from Big Sugar? For Big Sugar, any? None? This is my alter ego. No? All right. Tell you what, sounds like a break to me. What y'all think?
Yeah, sounds good.
All right,
Yeah.
let's take 10. See you back in 10 minutes.
But fiber does provide us with a way to not only transmit large amounts of data, we can do it over distances that are much longer than we can with copper connectivity. And since we can put so much data over a single pair of fiber, it's a perfect connectivity over long distances for your wide area networks. So inside of a metropolitan area or connecting multiple metropolitan areas to each other, it's very common to see a sonnet ring or some type of multi-wavelength fiber connection being used to transmit data from one place to another. It used to be that fiber was exclusive to these very large wide area networks or inside of a large corporate core. But these days, fiber can come directly to our home, and it's not unusual to see a conversion outside of our home to convert from the fiber on the street into the copper that we use inside of our house. One of the most common copper connections for internet connectivity is the cable that you would commonly associate with a cable television. We're also able to run data over that connection, so it's not unusual to plug that into a cable modem and be able to access the network through the Ethernet connectivity that you would normally have inside of your home. This cable provided by the cable company has a lot of different frequencies running on it simultaneously. We refer to that type of technology as broadband. We can run different frequencies with different traffic types all at the same time over the same wire. This allows us to run many different frequencies using different services over the same copper wire, and it makes for a very efficient way to provide voice, video, and data for an entire home. The standard used for sending data over these networks is referred to as DOCSIS. This is the Data Over Cable Service Interface Specification. There are different DOCSIS versions that provide different levels of service and different speeds of connectivity. On many of these cable networks, you'll find internet connectivity speeds will range between 50 megabits per second all the way up to 1 gigabit per second and even higher. This provides us with extensive data connectivity to the internet, and since we are bringing this in from the cable company, we can also have television and voice communication over that same wire. Many homes also have telephone service that's provided by your local phone carrier. That phone company can also add digital data onto that same connection that's used for voice communication. We refer to this as DSL, or digital subscriber line. You'll sometimes also hear this referred to as an asymmetric digital subscriber line, or ADSL. The reason we refer to this as asymmetric is that the download speed is often much faster than the upload speed. For example, it's not unusual to find DSL connections that may have a 200 megabit per second downstream speed, but a 20 megabit per second upstream speed. Not only do we have this difference in speed, but there's also differences depending on how far away we might be from the central office. The farther away you are from the central office, the slower these speeds will be. And DSL tends to require that you're about 10,000 feet or closer to a central office. Our cellular networks also provide us with internet connectivity. This technology uses the same infrastructure as the one we use for our mobile phones, where we're separating a geography into smaller cells and connecting them together with antennas. Some folks might use the mobile phone as a jumping off point, where they will connect their device to the mobile phone, and the mobile phone then provides connectivity to the internet. This one-to-one connection is often referred to as tethering. If you have a phone that provides internet access for multiple people simultaneously, then you're using your phone as a mobile hotspot. You may want to check with your mobile carrier and see if you can get internet connectivity through tethering or a mobile hotspot. They might also be able to tell you if there's an additional cost for that service. In some areas, it might be difficult to get a copper cable from your cable company or even a phone line from your local telephone company. In those situations, you might want to use a wireless connection to an internet service provider or a WISP. This is perfect for remote locations where you wouldn't normally have a connection from any other type of internet provider. This is also very simple to set up because all you really need is an antenna and you're now connected to the WISP network. On the wireless network itself, you may be using a number of different technologies. It might be a meshed 802.11 network, which is the same kind of 802.11 network that we use in our homes and businesses. This might be a 5G home internet connection where we're using a traditional mobile phone provider as our internet service provider. And we could even be using some other type of proprietary wireless connection. To be able to access the wireless internet service provider's network, we need an antenna outside, and that usually will give us speeds that range anywhere from 10 to 1,000 megabits per second.
Welcome back to the strongest connection.
With most options, I've been waiting for something special, but it's been buffering. But Underline, our connection is strong and ultra fast. This is gonna last.
Underline, local gigabit internet that loves you back.
All right, we ready?
Hi guys, roll again.
It's okay to look at each other, right?
Here we go.
I learned about crypto for a body of work. I've been focusing on crypto gaming.
I was making YouTube videos.
I wanted to work on something that's a little more purpose-driven.
Having a child is what really put us in the mindset of starting to want to invest more.
So crypto became my bridge to connect with people.
Talk to me about blockchain.
Explain blockchain.
I actually didn't know much about crypto.
And I started really digging in, researching, and trying to figure out what is blockchain, what is crypto, how it all works.
It is simply just a record, a public ledger of value.
You can interact directly on the blockchain, exchange items of value much more easily.
Less fees, more transparency.
It is sustainable, it is equitable, and it's fast.
It's having flexibility and feeling comfort and secure, and I think crypto makes us feel that way.
Blockchain has given me a new medium. Crypto is the future.
This technology really can't be used for good.
Let's go.
We're good?
If you're plugging into an Ethernet connection or using a local 802.11 wireless network, then you are communicating over a local area network or a LAN. We usually refer to a LAN as a group of networks that are close to our location. So this might be on the floor of a building or in a group of buildings that make up this particular local area network. One of the common characteristics of a LAN is that we usually get our fastest speeds by a local area network. If we're connecting to networks that are farther away, then we're probably not on a local area network anymore, and therefore we're not getting those same high throughputs. If you're connecting to a location that's in another city, another state, another country, or anywhere around the world, then you're communicating over a wide area network or a WAN. Because of the challenges associated with communicating over such long distances, wide area networks tend to be a bit slower than communicating over a LAN. There also might be many different technologies used to be able to communicate over this wide area network. For example, you might be communicating using point-to-point serial connections, or it might be an MPLS network or multi-protocol label switching network. And some wide area networks may use communication facilities here on Earth. We refer to these as terrestrial networks, or we might use satellites to communicate across the WAN. Those would be non-terrestrial networks. We've also created specialized networks for devices and components that are close to us as individuals. We refer to these as a PAN, or Personal Area Network. If you're communicating with Bluetooth, infrared, or near-field communication, you're probably communicating over a PAN. We might be using a personal area network inside of our vehicle to have audio output from our phone, be able to communicate hands-free, or it may be integrating with the media services that are already on your existing mobile device. Many of the wireless headsets that we use these days are communicating using Bluetooth. That certainly would be a personal area network protocol. And some of the health-related technologies we use also use a personal area network. So if you're gathering health details on your smartphone or you're communicating directly to your workout devices, then you're probably using a personal area network. We've talked about a local area network, and we've talked about a wide area network, but there is a network that sits in the middle of those two. That would be a metropolitan area network, or a MAN. This is a network that tends to be in a single geographical area, such as a city. If we have a lot of remote locations around the same city, we can usually connect to those using a metropolitan area network. Traditionally, these metropolitan area networks have been proprietary, but increasingly we've seen these standardize on Ethernet, specifically Metro Ethernet, which describes a type of Ethernet connectivity in our local city. And you might also find that your local government has put their own fiber into the ground. Since they do have right-of-way, they're able to put anything they like inside of the pipe. They can create their own metropolitan area network using their own fiber. Many organizations will have a repository of storage that they refer to as a SAN, or Storage Area Network. This is usually a high-speed connectivity because we're often transferring large amounts of data into and out of that SAN. To the devices accessing the SAN, this looks and feels like a local storage device. So you can even take a very large file and change a very small bit of data within that file very, very efficiently. We refer to this as block level access. Because we're moving so much data in and out of the SAN, we're usually putting these on their own isolated network connected to the rest of the network over very high-speed connections. And in our homes and businesses, we often will install wireless networks that are 802.11
All right, getting everybody back in class. Okay,
or wireless LAN. These allow you
gotta
to
ask y'all a
move
question
around
as
your
a
local area and still have access to all of the
I know y'all
resources
wanted
you
this
need over your mobile
information
devices, your
about
laptops, or
Matrix.
anything else that's using this wireless
Can I
network.
have your permission
And
to
if you're
use my
working in
private
multiple
email
buildings
to
or a
send
larger
it
campus
to you?
area, you can add additional access points to
If that's
expand
okay,
the reach
drop
of your
an emoji or
wireless
something.
local area
But I
network.
have to ask you because it's your private records, okay? I have to ask you. Yep. Thank you very much. Thanks for giving me, allowing me to do that. So I'll grab your email. I'm uploading it now, and then I'll get the link together and send it out to you. You'll see it come from like a JPC Group LLC. That's my email. You'll see it come from there from Gmail.
Tie together some loose ends, or
Thanks, y'all.
build up your security stack. You fit Sola to your needs. It's simple, quick, and free. Get security done with Sola.
Organic and dairy-free?
Woo!
Here we go.
At Sprouts, our shelves are filled with new, exciting, and delicious discoveries. This is that Sprouts feeling.
We were just working on assignments until lunch, so try to get that. Do that final. Get that final in if you need to.
A cable that has no connector on it, and you'll be asked to add the appropriate connector to the end of that cable. This might be a coax cable, it could be twisted pair, or it might be fiber. For copper connections, we would commonly use a tool like this one, which is a cable crimper. This is a specialized tool that allows us to pinch the end of a connector permanently onto that particular cable. For example, it's common to use a crimper when you're connecting the RJ45 connector onto a twisted pair cable. For twisted pair wires, the connector itself pushes through the insulation around the wires to connect directly to the copper that's inside. For example, here's an RJ45 connector before it has been crimped onto the cable. You can see that the copper connectors are sticking up just a little bit, and notice they are very pointy at the ends. It's that pointy end that presses through the insulation and makes its connection with the copper inside. Here's what that same connector looks like after crimping. You can see it's been pushed into the connector and it is going into the wire inside of that RJ45 connector. Notice that it also pushes in a cable stay farther down the cable so that it won't easily be pulled out of that RJ45 connector. If you're planning to crimp your own RJ45 cables, you'll obviously need a very good crimper. You'll need a set of electrician's scissors or cable snips, and you may need a good wire stripper to remove any of that excess cover from the outside of the cable. At first, when you try to do this yourself, it may take quite a bit of time as you're trying to determine the best process to use to get all of the wires in the right order and get them properly pushed into the connector. But once you do this a few times, you'll find the process is relatively straightforward, and that means that you can create your own custom length cables with your own crimper and your own RJ45 connectors. Instead of dealing with wires, why don't we connect to the network over a wireless connection? Obviously, wireless does have the advantage of not dealing with any wires, but there are also a number of issues and challenges with managing a wireless network as well. One of the ways that you can analyze the health of your wireless network is with a Wi-Fi analyzer. This can provide you with information on the frequencies or channels that are currently in use on your network and the networks around you. You can see the signal strength that you're getting from your local access point. You can see any interference that may be occurring across this network, and you can see all of the wireless devices that are communicating to your access point. If you want to get more detail about what specifically might be using the frequencies around you, you might want to use something like this, a spectrum analyzer. This is able to look at the entire spectrum and show you not only the 802.11 network that's in use, but any other frequencies in use by other devices in the area. Here's an example of the output on a simple Wi-Fi analyzer that's looking at my wireless network. If you're far away from the access point, you may find that the noise on this network is very comparable to the amount of data. This means that we probably are not going to have the best throughput on this wireless network. As we get closer to the access point, you'll find that the signal strength gets much stronger and you're able to visually see that difference in the Wi-Fi analyzer. One challenge we have on very large networks is being able to find the two ends of a cable, especially if you're dealing with hundreds and hundreds of wires on the floor of a building. One of the ways that you can track down the ends of these wires is by using a tone generator. This is really two different devices. One is the tone generator itself that you plug into the wire and it puts an analog sound onto the wire itself. We obviously can't hear that sound with our own ears, so we need some type of inductive probe to be able to find that sound even though we're not physically touching the copper inside of the cable. This means if you have hundreds or thousands of cables inside of a closet, you can use these tools to be able to easily find the end of any one of those wires. We would first connect our tone generator to the wire itself.
People can go crazy trying to stop a cyber attack. Acronis, take the headache out of IT security.
Don't compromise quality insurance for savings or your time for this ad. Hit that skip button. Or don't, and watch me skip.
You in there? Yes. Yes.
We are farmers. Bum, 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 bum.
This can be through a modular RJ45 connection. This might be a coax connector, or you might be plugging directly into the punch-down block. You would then use your inductive probe to move from wire to wire until you find the wire that makes some noise. Let's try finding the wire in my studio and see if we can find the one that's connected to our tone generator. Here's a tone generator I use on my studio network. Let's power it on. And when this is powered on, we can then plug it into one of the cables that I have inside of my studio. This is one of many that are connected to my desk, but now a signal is being put onto this wire that we're able to listen to using our inductive probe. So here's 4 wires that I have coming into my studio, but only one of these is connected to our tone generator. In order to hear this, we need an inductive probe. We don't have to touch the copper inside of the cable. We only have to put the inductive probe somewhere along the outside of the cable. And when we run across the cable that has the tone generator, we'll start to hear the noise, we'll see the lights flashing, and we know that we found the end of the cable connected to that tone generator. if you are running a lot of cables in your environment, you're probably terminating some of them onto a punch-down block. This is a punch-down block, very similar to what you might find on the back wall of a data center. We might be bringing in hundreds or thousands of cables and terminating them on these punch-down blocks to make the process of cross-connecting those cables much easier. This will individually connect all of these wires into the punch-down block and fasten them so they won't be easily pulled out. These tools also trim the wire once you punch them into the block, making for a very clean installation. Here's an example of a number of wires that are punched down into a punch-down block. You can see this is a twisted pair wire, and you can see there are a lot of wires that you would have punched into one of these blocks. That's why we tend to have these blocks numbered, so that we're able to reference where this wire is and where the other end of this wire happens to go. You can also tell the person who punched these down did a very good job of maintaining these twists all the way into the punch-down block. Obviously, it's these twists that help us prevent any type of interference, so maintaining those twists all the way into the punch-down block makes for a stronger network signal. And of course, it's often good to document where this cable is going so that we know what number it's punched down into and we know where the other end of the cable is. That way, if we need to complete this connection into a switch or some other device, we can easily find the cable that we're looking for. If you're working a lot with cables, you're punching down wires into a block, or you're attaching your own connectors, then you probably want to use a cable tester to make sure everything has been wired properly on that cable. If this is a patch cable, we want pin 1 to connect to pin 1, we want pin 2 to connect to pin 2, pin 3 to pin 3, and so on. A cable tester is perfect for checking that continuity between all the pins and ensuring that we really did connect the right pins on both sides of the cable. This can also help us find any pins we might have missed, or if we happen to accidentally cross a cable, we'll see that in our cable tester. Cable testers are usually simple continuity tests. They're not providing any type of quality signal testing, but they do provide us with a quick way to know if we're wiring things the proper way. The tone generator and inductive probe I used earlier also double as a cable tester. I have the tone generator set into cable testing mode, and it's flashing to tell me that it doesn't see any wires because I don't have anything currently connected to that device. I'm going to plug in a cable into one end of this cable tester, and we'll plug in the other end of this cable into the other end of this cable tester. What we're hoping to see is a continuity test from pins 1, 2, 3, 4, 5, 6, 7, and 8, and you can see it cycle through each one of those wires. If these wires were not connected, then we would not see a light for that particular pin, and if it was connected to a different pin, we would see the lights jump around as it went through its test. It's a relatively simple test, but it can tell us very quickly if we were able to put the wires in the right order when we put on the connector. One challenge you often run into is that some equipment may show that there's a number of errors on a particular link, but you don't know if the errors are being caused by a bad cable or if the problem is within the hardware itself. This is where we would use a loopback plug. Loopback plugs are very useful for testing the physical interface on a device. There are different loopback plugs for serial connections, RJ45 connections, or even fiber connections. These are not crossover cables. They are a cable that effectively loops back into itself. To use these, we would plug one into the interface on a device, and then we would put that interface into a diagnostic mode. That diagnostic mode sends information out of the interface, and then it looks to see if any of that information is being looped back into the receive part of that interface. If everything is working properly, then the information we receive should match the information that we're sending. If we see any difference between the information sent and the information received, then it's very possible that we have a problem with that physical interface. And eventually you may be tasked with gathering packets directly from the network, and there are a number of different ways to gather those details. One way is to use a physical tap. We break a connection and put this physical tap in the middle of the network link. Obviously, this is not something you can commonly do during production hours on a production network, but if you know that that particular connection will be used often for packet gathering purposes, you may want to install a tap there permanently. Many fiber taps tend to be passive taps, which means they don't require any power. Other taps may require a power source, especially if you're dealing with a copper tap. If you're not able to disrupt the network communication by installing a tap, you might want to use functionality that may be built into your enterprise switch. This is referring to a port mirror. Sometimes you'll hear this referred to as a port redirection or a SPAN. It stands for a switched port analyzer. With this port mirror function, you would plug in your network analyzer to one interface, and you would tell the switch to take everything from another interface and copy those frames into this protocol analyzer port. This allows you to get a copy of all of the network traffic without having to put a physical tap in the middle. You're effectively using the capabilities of your switch as your physical tap. Here's a copper coax tap. You can see on one side is the network connection, on the other side is the equipment connection. Normally these would connect from receive to transmit and transmit to receive. But with the tap in the middle, we would take one of those connections and put it through the tap. Then we take the other direction and also put it through the tap. Now that we've tapped that data, we can connect a monitor or a protocol analyzer and be able to get a copy of everything sent over those particular links.
Hey, Colorado Springs, it's me, your internet. I've been trying to keep up with you, but your ISP keeps holding me back. I'm not just glitching. I'm exhausted, but with Ting Fiber, I'm quicker than a downhill run, smoother than a craft brew. Now you can share the big moments, stream every game, call grandma without the awkward freeze frame, all at once. Colorado Springs, you deserve that kind of connection. Fast, reliable internet for people who make things happen.
What's the secret to peak health? Going micro with Noom! Micro habits, micro wins, even microdose GLP-1s.
Micro? I can do micro.
With Noom, we all can!
I'm doing it. I'm going micro.
I can do micro.
It's micro season, baby! Micro changes, big results. Get started at Noom.com. Do not micro poop on my shoulder.
Many of the monitors that we use today are LCD monitors. That stands for liquid crystal display. This is a display that has liquid crystals that a light is shown through from the back. It passes through a color filter and then finally to our eyes. This combination of light, filters, and color is how we're able to see information on these displays. Prior to LCD technology, we were mostly using large glass display tubes to be able to show information. So these LCDs provide us with some significant advantages. One of the advantages is that these displays are relatively light. We can put them almost anywhere. We can hang them on a wall. They can be part of a portable system, and we can effectively take this display anywhere. These also use relatively low power, so they're perfect for our mobile devices that run on battery power, and they are relatively inexpensive. The low cost of these displays means we can use them for practically anything where we might need some type of visual feedback. Because we're shining a light through polarization filters and color filters, it's somewhat difficult to get a true black color from a liquid crystal display. These displays also require that backlight for us to be able to see this information through those polarizing filters and color filters. Without that light, you have a very dim screen that is very difficult to read. That's why the backlight is so important. On older LCDs, you may see fluorescent lights being used for the backlight, but most modern LCDs will use LED lights or light-emitting diodes to produce that light. These lights can also be somewhat difficult to replace. On larger LCDs, you may be able to replace a portion of the backlight, but on smaller, less expensive systems, you may require a complete replacement of the display. There are also different technologies that we use with liquid crystal displays. One of these is a TN version of an LCD. The TN stands for Twisted Pneumatic. This was one of the very first types of LCDs that was introduced, and it provides very fast response time. So it's perfect for things like gaming or very fast-moving information on the screen. Unfortunately, if you move off-center from that display, you'll start to notice that the color will shift as you move farther and farther off-angle. So if you have a lot of people that need to see that display, a twisted pneumatic LCD may not be the best choice. A newer style of LCD is the IPS or in-plane switching LCD. This provides very good color representation. So if you're doing any type of graphics or video type editing, this might be a great display for you. But these can be a bit more expensive than the twisted pneumatic version of the LCD, so you may be paying a little bit more of a premium to be able to provide that excellent color representation. And somewhat in the middle between a twisted pneumatic and an in-plane switching LCD is the VA, or vertical alignment LCD. This also has very good color representation, although its response time is not quite as good as a twisted pneumatic display. And depending on the device that you're purchasing or using, there may be only one style of LCD available for that particular platform. So if you have the option to choose between different types of LCD, you might want to see what options are available and choose the one that's right for your purposes. As you can imagine, having a backlight in the display adds to the cost, the power draw, and the overall size of the display itself. But what if you could get rid of the backlight altogether? One style of display that has no backlight is an OLED, or an organic light emitting diode. This type of display contains an organic compound that, when you add power to that compound, creates and emits light. This means that you can have a high quality, high definition display without any backlights in the display at all. This means your display can be much thinner and much lighter because there's no backlight component behind the screen. And you may already be using an OLED display in some of your mobile devices. It's very common to find OLED on mobile phones, watches, tablets, and other mobile devices. And of course, you could choose to get much larger displays in different styles, including one that might be OLED. And because there's no backlight, you can get very good color representation on an OLED display. So if you're someone who is working with graphics, images, or video, you might want to consider an OLED display. The industry is constantly battling to find the best price point for OLEDs versus LCD. And one of the innovations on the LCD side is to create a backlight which provides a much better color representation. One of the ways that they've done this is to create a mini LED backlight. This is the same backlight that you would have in a traditional LCD, but the size of the LEDs, or the light emitting diodes, is much smaller on a mini LED display. These displays also provide control of each individual light in the backlight. So the display can make the decision on what section of the screen should be lit and what the intensity of that light should be. This means if the image on the screen was a darker image or completely black, the screen itself could turn off those LEDs to be able to make that black as deep and dark as possible. This means that the less expensive LEDs can come much closer to the color representation that you might find in a traditional OLED display. And if you were to remove the screen and look at the backlight on these displays, you would see there is a big difference between the conventional LED and the mini LED. You can see that the mini LED provides a much more granular control of the backlights, and you can get a much more nuanced view of the display because you have many more lights to choose from. On our watches, our phones, our tablets, and some laptop computers, we have the ability to touch the screen to provide input. This uses a digitizer to tell where we might be touching the screen, and it converts that touch into a series of coordinates. This means we can get rid of keyboards completely and simply use our screen as the input. But of course, you will still find laptops and other mobile devices that give you the option to include a physical keyboard as well.
This is the new Dell AI PC with Intel inside. It helps save you time because it does all your busy work for you. So you can get...
This gives you different options for input. We can use a mouse, a digitizer, or we can use the keyboard that's built into the system. This means that we could use the right type of input for the task that we have at hand. Some tasks may require a keyboard, but sometimes touching the screen would be a much easier way to provide that input. Many of these digitizers can not only recognize a finger touching the screen, but it could also use a stylus to be able to provide that input. A stylus is very similar to using a pen or pencil, except you can touch the screen and have any of those touches converted into a digital form using this digitizer. This is a very common input type for things like a tablet, but you might also find these digitizers used quite a bit on laptops or even desktop computers. As you are now aware, if you have a liquid crystal display, then you also have a backlight. And those backlights could be a fluorescent lamp or the newer LED type lamps. One of the challenges with the backlight is we need to provide power. That power for an LED uses the built-in direct current or DC power that we use to power our laptop. But if we have an older style liquid crystal display with the fluorescent lamps, those style of backlight require AC or alternating current. Since our laptops are using direct current, we need to invert that current so that it is now alternating current and can be used by our fluorescent backlights. One of the ways you can tell if the backlight is working or not is you can turn on the device and then look at the screen very closely. It often helps to have a flashlight that you can shine directly at the screen because that light will reflect from the back of the display itself. If you can make out text or graphics on the screen, but it's very faint, then your problem might be with your backlight. This means that we would need to replace the backlight itself, or in the case of a fluorescent backlight, we might need to replace the inverters that are built into this device. These are very common on laptop computers, and you may find that these inverters are in the bezel of the display itself. You can check with the manufacturer of that laptop to see what style of backlight is in use, and if it is a fluorescent light, you can also check to see where those inverters might be and what the process might be to swap those out for a new one.
Welcome back to the strongest connection.
With most options, I've been waiting for something special, but it's been buffering. But underline, our connection is strong and ultra fast. This is gonna last.
Underline, local gigabit internet that loves you back.
Hey, I'm Dylan. And I'm Mike. And we're The Ride Guys. We're here at Universal Studios Hollywood to take you on Despicable Me, Minion Mayhem. So if you're ready, we're ready. Let's ride. Shaboom! Coming for the crowd, it's a shutdown. Coming for the crowd, it's a shutdown. All right, so let's get right to your questions. Hey there.
Oh,
Yeah.
sorry. Are there doorbells that you can ring and hear different minions reply?
Yes. What kind of ride is this? It's a motion simulation-based experience with practical effects. What's the ride story? Well, Groove has just come up with another diabolical plan to take over the world. Research. What kind of effects does this ride have? This wasn't in the script.
In this attraction, you'll experience mist. Like wind. More like wind. And
Don't you dare.
fine. I'm sorry.
Is there a minimum height requirement? There is. You'll need to be at least 40 inches to qualify for minion training on these motion simulation vehicles.
However, if your little thrill seeker isn't quite 40 inches but still loves the minions, this ride has stationary seating, making it the perfect attraction for everyone, regardless of height or thrill level.
Can I use Universal Express? You sure can.
Is this Gru's ride? Yes and no. You're definitely going to see Gru inside, but this is a celebration of Margot, Edith, and Agnes's adoption day.
And Edith has been put in charge of training you to be a minion.
Did I hear there's a minion dance party? You did, and there is.
Can my family ride together?
Yes, the minion transformation pod holds up to 8 people. Enough room for all the minions to be.
Anything else before we ride? This again.
Do it.
Cactus don't talk.
Cactuses do talk.
Cactus don't talk.
Cactus can't sing.
It's time to load into our minion transformation pod.
Caution, laughter seems to be a common side effect throughout this experiment. Told you.
Do it! Make me a minion!
Oh! Do you feel any different?
I feel yellow and blobbish. Yeah, I like this.
Yeah.
Oh! Here we go!
Okay.
Look, there it is.
Oh,
See?
no more cactus.
It would have been fine. You were caught scared for no reason. Oh! 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 Laser beams.
Laser beams. We got this.
We are good at avoiding laser beams.
Yeah. Ooh!
Uh-oh.
Bro!
Help us out!
He needs help for himself.
Everybody work together!
you for watching our journey through Despicable Me Minion Mayhem. And as always, remember to like and subscribe.
And comment down below and let us know what you'd like to see next on Ride Guys.
Oh, when you're here at Universal Studios Hollywood, you gotta check out Super Silly Funland.
Oh yeah, real talk, parents. Super Silly Funland is amazing. It's based on the Seaside theme park from the film. So there's carnival games, silly swirly fun ride, and even a wet and dry play area.
So what you're saying is it's silly and fun.
Exactly.
Oh, and we can't forget about Minion Cafe. Who doesn't love delicious Minion-themed treats?
As you can see, there's plenty of Minion fun here at Universal Studios Hollywood, including
a dance party. Dylan, wanna go dance with some Minions?
after we ride again.
Let's ride! Shaboom!
Coming for the crown, it's a shutdown.
Knock, knock.
Who's there?
Interrupting mist.
Interrupting this. Who?
If you've been in the market for a display, you'll notice that the technical specifications vary widely between different displays. There are different options, different specifications, and a number of different settings that differentiate one display from another. We also have to consider how this display might be used. Are we going to use it for gaming? Will it be used for watching video presentations? Will this simply be a display that's hanging on the wall in a lobby, or will we use this display for presentations? Once we know how a display will be used, we can then reference the technical specifications for that display to find exactly the right display for that particular use. One technical specification we may want to pay attention to is the pixel density. This tells us how many pixels are contained within 1 inch of that display area. If you're in a different part of the world, this might be the number of pixels per centimeter. This allows us to put a physical number on the clarity of this particular display. If you have a higher pixel density, the display will look much more crisp and clear than a lower pixel density. You also have to think about how this image will be used. Is this an image that will always be displayed on a screen, or will we need to print this image out onto a printer? If so, we may want to look at the printer specifications and determine if the DPI, or dots per inch, on the printer can properly represent the image that we're seeing on the screen. You can start to see the differences in pixel density when you start comparing how many pixels you can fit into a 1 inch by 1 inch area. If it's 1 pixel per inch, then obviously we have a single pixel in that square inch area. If it's 2 pixels per inch, you can see that it is 2 pixels across and 2 pixels down. 4 pixels per inch are 4 in each direction, and 8 pixels per inch are obviously 8 in each direction. You can start to see how an image on an 8 ppi display would be very different than the image displayed on a 1 pixel per inch display. If you wanted to calculate this, you could take the number of pixels and you could divide that by the number of inches. Obviously, if you are in a different part of the world, then that might not be the same measurements, but for the United States, we will use inches in this particular example. So let's take, for example, a 27-inch 4K display. This means the size of the display is 27 inches if you measure on the diagonal. If we were to measure the width of the 27-inch display, it is approximately 24 inches wide. And since we know this is a 4K display, there's a total of 3,840 pixels on that horizontal display. If we then do the math of dividing 3840 by 24, we get a total of 160 pixels per inch. Let's take exactly the same resolution of 4K display, and now let's make the total size of the display a 65-inch display. This means that we still have 3,840 horizontal pixels, but the width of this television is much larger at 57 inches. If we then divide 3840 by 57, we have a total of 67 pixels per inch. So although the image itself may be at exactly the same resolution on a 27-inch display and a 65-inch display, you can see that the pixels per inch are very different between those two displays. When we look at a display, we're not looking at a single image. We're looking at a series of images that are constantly being refreshed on our screen every second. And you'll notice that a number of specifications for these displays describe just how many times they can refresh this screen in a 1 second period. This is referred to very generically as the hertz that are supported by this display. Hertz is the generic term for the number of cycles per second. Sometimes you'll hear people refer to this as the number of frames per second, or FPS. And you could have configured the display so that the number of hertz does equal the number of frames per second. But there's some display configurations that may only update a portion of the display on every cycle per second. But let's say for this discussion that we have configured this display for vertical sync, or VSync, which means the hertz happens to equal the same number of frames per second. Now we have to think about what we will be viewing on this particular display. If this is a display that will be showing movies in the United States, then we expect that to show 24 frames per second. If you're watching a television show or you're looking at a video online, you're probably viewing that at 30 frames per second. And if you're watching something at a very high speed, maybe a sporting event or you're gaming on your system, then you would expect to have something that can support 60 frames per second or even higher. To be able to visually see the difference between a low and high number of frames per second, I put these circles on the screen, and I've arranged these circles to drop at exactly the same rates. However, they will only be updated with the number of frames per second shown at the top. So it might be 1 frame per second, 15 frames per second, or even 30 frames per second. Let's start these going to see what the difference might be. And if you're watching this on a display that is able to give you at least 30 frames per second, then you'll see there was an obvious difference between the 1 frame per second and the 30 frames per second. Let's see it again. We'll watch the 1, which is very choppy, and that's very different than the 30 frames per second that's moving at a very smooth rate all the way down the screen. As we mentioned earlier, if you're working with content that moves very quickly on the screen, this might be video games or sporting events, then we need a refresh rate that's able to keep up with that speed on the screen. Otherwise, the information being displayed on the screen will look like it is stuttering as it's moving across the screen. But the display is only one part of the overall equation. We need to be sure that the video card or video subsystem can support the refresh rates that we need. And we also need to be sure that the connection type that we're using is also able to support those same refresh rates. For example, if you're using HDMI, the 2.1 version of HDMI supports a 4K resolution at a total of 144 Hz maximum. If you're using DisplayPort 2.1 supports dual 4K displays, and both of them can run at a maximum of 144 Hz. That's why it's important, if you purchase a display that can support 144 Hz, you want to be sure that your adapter card and the type of connection between the two can also support that refresh rate. We talked earlier about a 4K display and the type of resolution that you can expect with that style of display. That resolution number is referring to the number of pixels on the horizontal and vertical of this display. For example, a 4K display is 3,840 pixels wide and 2,160 pixels high. The larger number of pixels will give us a display that looks much sharper. So if you're looking at an image on a 4K screen, that will look much sharper than the image that's on the same sized HD display.
People can get crazy trying to stop a cyber attack. Acronis take the headache out of IT security.
We can start whenever you're ready.
Ready?
Yeah.
And on today's market, there are certainly standards for different resolutions that you will commonly find, but there are some models of displays that deviate from these particular standard resolutions and might have their own set of resolutions. This aspect ratio of 16:9 is very common across these different standards, but of course, different monitors and displays provide different aspect ratios, and you need to get the one that's appropriate for your particular use. If you're watching this video on a 4K display, then you'll be able to see the difference here between an HD display and a 4K display. You can see that HD is a width of 1,920 pixels and a height of 1,080 pixels. And 4K is obviously much larger at 3,840 pixels wide by 2,160 pixels high. If we were to look at both of these displays of the same size, you would see that the 4K display does look much sharper than the display you would get on an HD display. Our human eye is able to view a vast range of colors, but the displays we use don't have the same capability. Our human eye can view a much wider range of color than a display can. We refer to this range of available colors that can be seen or can be displayed as a color gamut. This might be a very important consideration when you're trying to decide on what type of display you'd like to use. If you're working a lot with graphics or some type of images, you might want a display that provides the largest and widest color gamut possible. One way that this is measured is using this CIE 1931 color space. This color image that's in the background is the color image that our human eye can view. And on top of that, we represent a number of different standards that are also applied to the displays that we use. For example, the sRGB standard, this stands for the standard red, green, blue, is represented on this screen with this blue triangle. A display that says it is sRGB compatible is one that can display this range of colors. We have a similar set of standards we can apply from Adobe with the Adobe RGB, and the International Telecommunications Union, or ITU, also has a number of standards that you can use when trying to compare the capabilities of one display with the capabilities of another. You'll often find this color gamut breakdown in the technical specifications of the monitor. So I went online and found a couple of monitors that were very similar to each other, although a different size, and you'll notice there is a color gamut option within the technical specs. This particular display presents a 100% Rec 709 and 100% sRGB and a 98% DCI P3. You don't have to know the details of those specifications, but you can look at the percentage to see how closely it meets those standards. We can also start comparing those across different displays. For example, the display here on the top can support 100% of the sRGB standard. If we were to purchase the display just underneath, you can see that its color gamut comes close, but it still is only 95% of the sRGB standard. If you were trying to choose between one display and the other, you would need to understand how these displays might be used. If this was a display that's only going to be used for some web surfing and providing emails, you might be able to get away with a 95% sRGB. But if this device is being used for graphics or video editing, you might want to use a display that better fits that particular color gamut standard. Both of these displays are LCD displays that have IPS technology. In fact, the IPS here even uses different forms of IPS to get a much better level of blacks, which is probably why they get a much larger number of the sRGB standard. One way that you could get the best possible color gamut would be to use an OLED display because they tend to have the best color representation. And you'll often find that an OLED provides a much better compatibility to these standards than any of the traditional liquid crystal displays.
I would describe Underline as fast, affordable, and local. Incredibly fast, very reliable, zero lag.
That's kind of fast.
Consistent, fast, simple. No-brainer.
So, I told the girl, I said, well, do me a favor, put the money in the bag.
Excuse me. You on your phone?
Yeah, oh man, I play this game, Royal Kingdom. Love this game.
You're playing Royal Kingdom?
Yeah.
At my show.
I'm so sorry.
You do not have to apologize.
Like, I love this game. I play Royal Kingdom, and let's be clear, I'm playing the game uninterrupted, people. That's right, no ads talking about buy this now. I hate ads, bro, I hate
I'll
ads.
tell you what else you hate, chewing your food, sir. The best part is I don't need Wi-Fi.
I don't need it. I need it. I'm not searching for a signal while I'm trying to get to a new level. What level you on?
At the moment?
Yeah.
Right, 120.
We didn't say how many movies you did this year. We said what level you are, right?
I'm not here to play games. I'm not. Unless that game is Royal Kingdom. All right, let's get back to the show. Yeah.
often focus on the capabilities of our new laptop or our desktop computer, and when we connect these to the network, we naturally assume that everything will connect and work as expected. It's able to do that because we were able to put in the proper cables to be able to send that information across the network. These cables or fiber optics are the foundation of everything we send across this network. If you have bad cabling, then your applications are not going to work as expected. You have to plan and install the correct cabling for the type of network that you plan to use. Even our wireless networks have cable at some point. We may communicate wirelessly to the access point. That access point has to be connected to the rest of the network over those network cables. A huge number of the cables that we use on our wired Ethernet networks are twisted pair copper cables. We refer to these as twisted pair because the individual wires inside of this cable are twisted together into these pairs. You can see the blue pair is twisted together, the green pair, the orange pair, and the brown pair. Each one of those wire pairs contains equal and opposite signals, so the information being sent over one part of that pair may be transmit plus, the other wire in that pair is transmit minus. The reason that these wires are twisted inside of this cable is that one side of that pair is constantly moving away from any interference or noise that may be in the environment around it. When that signal is received on the other side, that receiver is able to determine what the real signal should be and what the interference might be based on the differences in that signal that it's receiving on both of those wires. And if you look closely at the cable that you're using, you'll notice that each of those wire pairs is twisted at a different rate. The receiving side can compare all four of those wire pairs and see the differences in that interference across all of those pairs at the same time. And since there are differences in the twist rate, the receiving device can easily see where the interference might be and where the good signal might be inside of that cable. Different twisted pair cables may be constructed differently. There's a set of standards associated with these cables that determines the minimum capabilities for that particular twisted pair cable. Sometimes people refer to a cable as having a particular speed. In reality, of course, the cable doesn't have a speed at all. The cable is just a bunch of copper that's sitting there on the desk. The signals that you send over the cable, however, certainly do have a speed, and that speed is determined by the signal encoding that's being sent over those individual wires. To be able to send those signals across the wire, we need to be using a minimum category of cable for the type of signal that we're transmitting. The minimum category of cable that should be used for a particular Ethernet standard is documented in the IEEE 802.3 standard document. Those IEEE documents tell us the minimum category of cable that is supported for a particular IEEE Ethernet standard. For example, if you're using gigabit Ethernet on your network, then you're probably using the 1000 base T standard that IEEE has created. And they've put into their standards document that if you plan to run 1000 base T as your Ethernet standard, you need to use a minimum of category 5 cable.
I was always trying to find a song that fit my feeling. Hey, I'm Alex Warren, and I'm on the Bose C.25 mixtape. I chose this venue today because with an orchestral version of Eternity, I wanted a big grand open spot in my hometown of Nashville. I wanted to make sure that we could do this in a place that fit the setting of the song. I love performing this song, it's so new for me, but on top of it, it's just great to be surrounded by a bunch of musicians. Writing Eternity was an emotional experience. I've written so many songs about grief, but this one was different. Every time I try to write a record about something very personal and very intimate like that, I try my best to be able to make it where everyone can relate to it. When I try to write ballads, I really look at like Adele, Ed Sheeran, and John Legend. Those artists help me get through tough times, and I feel like now it's almost as if I'm doing the same for people in a different generation. I'm the biggest critic of my own self, and so constantly trying to write things that are true to me, but also figure out what myself is, you know? I think it's important to listen to music in different formats, whether it's a different speaker or cassette, or vinyl, because you hear different things that you didn't hear the first time. I've probably overplayed Noah Kahan's album. I got this huge gym kick, and I would listen to Noah Kahan's entire discography every single time I was lifting weights, to the point now where I know everything word for word, bar for bar. So I feel like as if it's a worn out record in my brain. Whether I got broken up with a girl in middle school, or whether I got bad news about something, or I got bullied at the park at 11 years old, I was always trying to find a song that fit my feeling. When I lost my dad, I felt like I wasn't really able to find anything that was authentically, trying to convey that message. I wanted to create, I wanted to fill the hole.
This is a hot flash. This is a not flash. This is a hot flash. This is not. If you have hot flashes and night sweats due to menopause, ask about Mioza, the #1 prescribed hormone treatment. Moderate severe vasomotor symptoms due to menopause, so you can have fewer hot flashes. And
if you look at the outside of the cable, you'll see printed on the cable itself what category of cable this has been tested to. So if you're using 1000 base T, you need to make sure you're using a minimum of category 5. The category 5 standard has been deprecated, so if you're buying new cable, you'll probably find category 5E. There were additional tests that were added to the qualification for category 5 cable, and those additional tests mean that we need to label it with a slightly different name of category 5E. The E is for enhanced. So if you have an older installation of wiring and it's category 5, you can run 1000 base T over that category 5 cable to a distance of 100 meters. If you're installing new category 5 cable, you're probably installing category 5E, and obviously it can also support 1000 base T to a distance of 100 meters. If you're running 10 gigabit speeds, then you may be running 10G base T, which is 10 gigabit Ethernet over unshielded twisted pair cable, and you would need a minimum of category 6 cable. If you're using category 6 cable that is unshielded, it can run for a distance of 55 meters, and if this category 6 cable is shielded, it can run for a maximum of 100 meters. And if you're using category 6A, the A stands for augmented, then you can run that same 10G base T network to a distance of 100 meters. If you're ever wondering what category of cable you should be using, you should always refer back to the IEEE standards. So if you're running a 10G base T network, you should look at the IEEE standards for that. It will tell you the minimum category of cable that is supported for that specific Ethernet type. But of course, twisted pair cable is not the only type of copper cable you might find. Another common copper type is the coaxial cable. Coaxial meaning two or more forms sharing a common axis. Coaxial. This is an interconductor. This is where all of the signal goes on that wire conductor that's in the middle. And there's an outer shield that's commonly associated with this to protect the signals that are running on that internal wire conductor. You often see coax being used for a number of different purposes, but for networking, we commonly see this associated with cable modems or digital cable. Anytime you're running a high-speed internet over those cable infrastructures, you're probably using a coaxial cable. In our discussion of cable categories, we talked about unshielded cable and shielded cable, and the type of cable you would use would be dependent on the standards that you're using and how far you need that cable to go. Unshielded twisted pair we refer to as UTP. This is a cable that has no shielding at all, so there's no shielding around the outside of all four pair, and there's no shielding around each pair of cable either. Another style of twisted pair you might find is the shielded twisted pair, where a shield inside of the cable itself is used to help protect against interference. This shield can be around all four pair, so you can see here we have a shielded twisted pair where the shield is along the outside, but it could be that you're shielding each individual pair of wires within that wire sheath as well. If you look on the outside of the wire, it often will tell you what type of cable and what type of shielding is being used inside of the cable sheath. If you see abbreviations that say U, it's probably unshielded. An abbreviation of S refers to a braided shielding, and an abbreviation of F is referring to a foil shielding. If you see this printed on the outside of the cable, it will usually have that abbreviation specifying the shielding used for the overall cable. There'll be a slash, there'll be the abbreviation of what shielding is used for the individual pairs, and that ends with TP to specify that it is twisted pair. So if you're using a braided shielding around the entire cable, and then you're using foil around each individual pair, then the abbreviation on the outside of the cable should show S/FTP. If you have a cable like this one that has foil around the outside of the cables, and then no shielding for the individual pairs, then that is an F/UTP. Here's a cable where we can see the inside of the cable and the writing on the outside of the cable. You can see this is a category 7 cable, and it has some text that says S/FTP. This means that all of the wires inside have a shield around them, and there's foil on each pair of the cable. And if we look at this cable, we can see the shield around the outside, and we can see that each individual pair of wires does indeed have foil around.
How's everybody doing?
Of those
Y'all
pairs.
good? Need anything?
If you work for an organization that has multiple buildings next to each other, or you work on a campus of buildings, then you may run individual wires between one building and another. Some organizations will run this wire overhead, but it might be much simpler and perhaps protect the cable better if you were able to put it underground. There are specially made Ethernet cables that are direct burial STP cables. They're designed to be installed in the ground itself. These are usually waterproofed. They may have a gel inside the cable to help repel the water so that you can put it in the ground and not even have to use a conduit. These are usually shielded twisted pair cables, not only to help against interference, we can also use that to help ground the cable. This also adds a bit of strength, especially if we're putting this cable in the ground without a conduit. Structurally, this looks very similar to a shielded Ethernet cable that you would use on the inside of the network. You have 4 different pairs of wires. We might also have a shield around all 4 of those pairs to help protect against interference. And because this is going outside, usually in a place where water might be, we often will put a waterproof gel on the inside of that to help protect the wires even more. There's also usually a wire that runs the entire length of the cable that's often used as an electrical ground. You'll sometimes hear this referred to as a drain wire.
People can go crazy trying to stop a cyber attack. Acronis take the headache out of IT security.
Can you keep a secret? I'm an angel. See the wings? Did I switch artist life?
You can't sleep here.
With Jeff's life.
Switch back, or this angel man will send you to hell forever. Smite him!
That's actually not my department.
Why did you do this?
I tried to show him that wealth wouldn't solve all his problems.
And now look at you.
It seems to have solved most of his problems.
You have to get Arch to go back. And until you do, I have to take your wings.
I'm fired?
You're human.
All I know when I'm done chewing.
Oh, you've never eaten anything before.
I think you'll just go. Just eat the hamburger.
There you go. You're a big boy, huh?
Yeah, I'm a big boy.
We have to get jobs, Gabriel.
Pizza was yummy. 5 stars.
Nice!
They tipped you $1.15.
Yes!
Don't you see how superficial a life of wealth and success ultimately is?
No.
You're smoking cigarettes now?
That's no bueno.
No fucking shit, it's no bueno. It's mooey, 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 no bueno, Gabriel.
The internet is amazing, Jeff. It's so useful and also distracting at the same time. I want to help you find jobs, but I also...
If you're in a commercial building and you look at the ceiling, you're probably not looking at the bottom of the roof. You're probably looking at the top of a drop ceiling, and there's additional things above that ceiling that you can't see. Above that drop ceiling might be some ductwork that is able to feed air into the rest of the building, and another set of ductwork that's able to take a return air supply and send it back to the air conditioning system. When the airspace above that drop ceiling is not circulating, then we refer to this as not having a plenum. In many commercial environments, there's often an air supply that is providing fresh air through a set of ductwork, but the return air is simply going into the large open airspace above the drop ceiling. In this case, we refer to that open area as plenum space. One of the concerns that we have and that we always have to plan for is one of fire. In these plenum environments where you have all of this open space above the drop ceiling, makes it very easy for fire, smoke, and toxic fumes to be able to move freely from one part of the building to another. This means if you're putting network cables above that drop ceiling, we have to use a cable type that has been specifically built for a plenum. If you were to move those drop ceiling tiles out of the way, you'd probably see something like this, where there's a number of different cables and connections. Some of them are electrical, some of them are for the fire system, and others might be for the network runs from one part of the floor to another. A typical Ethernet cable that is not something designed for the plenum has a cable jacket that's commonly made of polyvinyl chloride, or PVC. If you're putting cables above the drop ceiling, then you're probably using a plenum-rated cable. This has been specifically designed to be a fire-rated type of cable jacket. That means that it is a fluorinated ethylene polymer, FEP, or a low-smoke polyvinyl chloride, or low-smoke PVC. These are functionally the same as any other type of Ethernet cable, but they may be a little more difficult to work with because that type of cable jacket may not be as flexible as the other types of cables. And although we don't like to think about bad things happening inside of our building, we do have to plan for the worst case scenario. And if you're designing a network where you're putting these cables above a drop ceiling, you may want to make sure that you're using a plenum rated cable.
This is a team feeling zen. And these are the Dell PowerEdge servers that make them feel that way. They take care of themselves. So the team can spend less time stressing and more time.
As you can imagine, the standardization for Ethernet wiring is one that extends well past the borders of any country. There's an international standard managed by the ISO IEC 11801 cabling standards document that defines the different classes of networking standards. In the US, there's the Telecommunications Industry Association, or TIA. This is a standards-based organization that has created a standard for the installation of cables in a commercial building. You can find this in the ANSI/TIA 568 standard. Inside of that standards document is the definition of what wires go on what pins with which connectors when you're using an Ethernet network. We refer to the standardization of the pins and the colors as the T568A color scheme and the T568B color scheme. We need this set of standards so that we can walk into any building or look at any Ethernet cable and see a consistent coloring of wires no matter where we go. This not only helps with the process of the initial cabling installation, but it also helps when troubleshooting that cable. These two standards of the T568A and T568B are both used on the same RJ45 type connection, but you can see that the colors used in each of these standards is slightly different from each other. In the US, and probably in most places, you'll find that the T568B standard is what is commonly used. It would be unusual for an organization to start with one standard and then change over to a different standard in the middle of their installation. Normally, organizations will be very consistent with their wiring standards, and once an organization starts using a particular standard, that's the one they normally will stay with. You also want to be careful about mixing and matching these. On a gigabit network, you would never put a T568A wiring scheme on one end of a cable and the T568B colors on the other end of the cable. You may even find references on the internet that tell you that this is a crossover cable with Ethernet, but if you actually go through and look at the pinouts, you'll see that that's not actually the case. You would never want to mix 568A with 568B. Understanding the color schemes is not only important for the A+ exam, it's also important for any network that you walk into where you'll need to perform some type of crimping or cable management. This is something where the T568A and T568B will certainly be used, but fortunately there are a number of similarities between these two. You can see on the T568A, pin 1 starts with white and green, pin 2 is green, then it moves to white and orange, blue, white and blue, orange, white and brown, and brown. Now if you compare that to the T568B, There are similarities. For example, you can see that the blue colors on pins 4 and 5 and the brown colors on pins 7 and 8 are exactly the same between them. That means you only have to memorize the differences between pins 1 and 2 and pins 3 and 6. You should be able to pick up any Ethernet cable, look at the cable, and be able to determine which color scheme was used for that particular cable. For example, we have an Ethernet cable here. We flipped it over and you can see that it's white and orange, it's white and green and blue, it's white and blue and green, and it's white and brown and brown. And if we were to take our T568B color scheme and overlay it on the top of that cable, you can see that it matches perfectly. That means that this cable was crimped with the T568B color standard. This is something that is very easy to get wrong if you're crimping your own cables. These little wires can be difficult to manage, and they're even more difficult when you slide them into the RJ45 connector just prior to crimping them down. It's often useful to put the wires into the RJ45 before crimping, and then to look at the wires just like we did in the previous slide to see if they were matching up exactly to where they should be. And if they're not, we can pull the cable out, readjust, put it back in, and when we get it right, we can crimp those down. Sometimes you'll run into a jack like this one where you're punching down the cables and they've already told you what colors you should be using for each of these different connections. You can see that the A colors are along the top and the B colors are along the bottom. You'll also notice that this jack does not follow the same color scheme as the T568A or T568B. That's because they put the color scheme here to make it easier for you to install. Inside the internals of this jack, it will be putting the correct pins in the correct place on the RJ45 connector itself. Here's another example with a different keystone jack. You can see that there are 4 wires to go on this side of the jack and 4 wires on the other side of the jack. This jack shows us if you're using T568A, you would put a green, a white and green, a blue, and a white and blue into those 4 areas, and you would punch them down. If you're using 568B, you would use orange, and blue and white and blue. And on the other side of the jack are the other 4 wires, and you would put them in with the same color scheme that's specified for either T568A or T568B.
At Capital One, we start with applied research, leveraging our data to build.
If you walk into a data center, you'll find a great deal of equipment there that runs using optical fiber. Instead of using copper with electrical signals to transmit information from point A to point B, we send light through a fiber to transmit that same information. This means we don't have to worry about the interference that you might get from other equipment or other radio frequency devices. This does make it a bit more difficult to monitor or put a tap into the connection. You do need specialized equipment if you're planning to use a fiber optic network. But unlike copper signals, which tend to degrade over a short period, in some cases you can extend fiber optics many kilometers without needing to regenerate that signal. And if you're working in an environment with a lot of industrial equipment, or you're having to deal with a lot of interference, you can install fiber optic connections and not worry about any of those radio frequency interference sources. One challenge with fiber optics is that there are many different types of fiber and many different types of connectors. And in this course, we'll look at the differences between all of these and help you understand where the right fiber is used in the right situation. Here's a nice cross-section of a fiber optic cable. You can see on one side we are sending a light through the fiber. In this case, the light is being generated with an LED. In some cases, we use a laser to be able to transmit that light. This moves through the fiber optics on the core of that fiber. We refer to this as a high reflective index core, and it is surrounded with a low reflective index cladding to help protect it. Because of the differences in the reflective index, the light bounces back and forth through the fiber until it reaches the other side. This fiber, though, is very thin and very fragile, so to help protect the core and the cladding, we surround it all with a buffer coating. Here's an image of the end of a fiber optic connector. You can see the square-shaped connector along the outside. In the center is this white colored ferrule. This is a ceramic ferrule that helps protect the fiber, which is on the very inside of that ferrule. If you look very closely, you'll see a discoloration. That discoloration is the fiber optic that's in the inside that is well protected because it's coated inside of that ferrule. That black dot on the screen represents where the fiber is inside of that ferrule. I'll remove the black dot, and now we can see the discoloration. That's your fiber optic cable inside of that connector. You'll generally run into two different types of fiber optic cables. One of them is a multi-mode fiber. This is commonly used inside of a building or any type of short-range communication. The distance on multi-mode fiber tends to vary, but it can usually go to about 2 kilometers in length. Because of these short distances that it needs to go, we can use a relatively inexpensive light source, and that's why we commonly will see LED used as the light source on a multi-mode fiber. We refer to this as multi-mode fiber because the fiber itself is relatively large. It has different modes that the light can take as it moves through the fiber. Each time the light is going through, it may use a different path to get from one side of the fiber to the other. This is very different than single-mode fiber. Single-mode fiber is designed for long-range communication, and some Ethernet standards can go 100 kilometers through single-mode fiber without any need to regenerate that signal. Because it is going such an extended distance, we often will use lasers to be able to make sure that the light can make it all the way through that fiber connection. And unlike multi-mode fiber, this single-mode fiber goes through the fiber in a single mode. You will notice that the core of the fiber is much narrower than the multi-mode fiber. This is very common when working with single-mode fiber because you have a single path through the entire single-mode connection.
Now's the time for a great deal on the new Honda from the Kelley Blue Book Best Value brand.
If you've connected any type of peripheral device to your computer, then you've probably used a USB cable. USB stands for Universal Serial Bus, and it's become the standard connection type for our keyboards, our mice, and almost any other device that we would directly connect to our computer. One of the first versions of USB was USB version 1.1. It had two different speeds that it operated at. One was what they called low speed at 1.5 megabits per second, and another at full speed, or 12 megabits per second. We generally saw 3 meters in length as the cable types for low speed and 5 meters in length for full speed. USB 2.0 was a significant improvement to the throughputs of USB, and it had a maximum of 480 megabits per second, again over a cable that was approximately 5 meters in length. And USB 3.0 is a standard they call super speed. It operates at 5 gigabits per second over approximately a 3-meter cable. We say approximately with these cable types because the USB specification does not specify an exact cable length, but generally speaking, these cable distances are about the maximum you can get and still maintain that level of throughput. There have been some updates to USB 3.0, including USB 3.1, which has a maximum of 10 gigabits per second, and USB 3.2, which has a maximum of 20 gigabits per second. The cables and connectors used for USB are relatively common, and you've probably seen one of these types of cables before. For USB 1.1 and USB 2.0, we used these cable types. Many of us are familiar with the standard A plug. It is a plug type that we continue to use today. If you're plugging in a peripheral, such as a printer or an external device, you may be connecting with a standard B plug, which is a bit more of a square type connector. And then if you're connecting a mobile device, it's probably using one of these smaller connector types, such as a mini B plug and the micro B plug. For USB 3.0, the connectors were changed just a bit, although the standard A plug has the same form factor as the previous version. The standard B plug was updated just a bit. You can see it is a little bit taller than the previous version, and the micro B plug for USB 3.0 is a very different form factor than the micro B plug we used for USB 1.1 or USB 2.0. As you can see, we've used a lot of different connector types for USB through the years, And we realized that we needed to standardize on one single format. We also needed a connector type where you didn't have to plug it in any particular orientation. The connector type we created is called USB-C, and this cable is one that can effectively replace all of those other USB connector types. This USB-C connector is a description of the physical interface that you would connect to a particular device. It does not describe the type of signal going over that particular connector, and there could be many different kinds of signal that you're putting through a cable that is ultimately connected with a USB-C connector. Side by side, we can see that the USB-C plug is very similar in size to the micro B plug, and you can see it next to the standard A plug so that you can get an idea of what the differences in size might be. Before we had the universal serial bus, we had simply a serial cable. Serial cables had many different styles, connectors, and formats, but two of the most popular were the DB9 and the DB25. The standard size of DB9 refers to the size of the connector. The 25 is referring to the number of pins. So the B-size connector is this longer size, and technically this smaller connector is an E-size connector. This would be a DE9, but since we were already using the term DB for the 25 pin, we kept the DB name and refer to it as the DB9 connector. But if you're ever purchasing an older serial cable, you might see it referred to as both DB9 and DE9. These types of connections send signals using a standard type called RS-232. It stands for Recommended Standard 232, and it's been a standard for sending serial information over these wires since 1969. Remember that we were using these types of serial connections well before there was USB, even before there were standards that were in place for mice and keyboards. So back in the day, if you were connecting a modem, a keyboard, a mouse, or some other peripheral, you may be connecting it using one of these standard serial cables and serial interfaces. If you're using one of these DB9 connectors these days, then you're probably connecting to legacy equipment such as an older switch or an older router. This allows you to connect to the serial or console port on those devices to be able to configure them. Many of us don't even have a DB9 type connector on the back of our computer any longer, and we've had to convert between the newer USB-C connection to something like the older DB9 connection. If you were to look at one of those older switches or routers, you would see there was a console port. This particular console interface is an RJ45 connection, but it's not sending Ethernet through that particular cable connection. This is instead sending serial information. You might also find console interfaces that are DB9 connectors, and some of the newer switches or routers may simply have a standard USB connection. The reason we need one of these serial cables and we need to use the console connection is that this is one of the best ways to connect to this device when no other method is available. If there's problems connecting to a device through one of the existing interfaces that are on that switch, router, or firewall, you can always connect to the console connection through a serial interface. And if you're connecting to the console using this serial interface, you're probably put at a command prompt and you're typing in commands at the keyboard to be able to configure that device. And since most of our modern devices don't have DB9 connectors, but they do have USB connections, then we usually will carry around some type of adapter cable that will convert between the USB connection to a DB9, and even from there we can convert to the RJ45, just so we're able to connect to one of these console connections. Another method of connecting to a peripheral is using a standard known as Thunderbolt. Thunderbolt is a high-speed serial connection that has data and power on the same cable. This makes it very easy to power a peripheral device through a single cable that's running both the connection for data and the connection for power. The early versions of Thunderbolt chose to use a standard interface that was already available on many systems. This is a mini DisplayPort connector, and it was used with Thunderbolt 1 to provide 2 channels of throughput at 10 gigabits per second per channel.
All right, I just sent the link out, so y'all should start seeing the link show up, so y'all can start downloading. Man, that was a lot of work to get that up.
Still use the DisplayPort connector. If you're connecting to a modern
So there
device
you
to
go.
Thunderbolt, then you're probably not using the older style mini DisplayPort connector. Instead, we're using that newer standardized connector, the USB-C. This is a good example of how this USB-C plug can be
1983 Miller,
and for Thunderbolt
you have blocked my message, so your settings for your email, they don't like me.
Supports a maximum cable length of 3 meters if you're using a copper cable, but it also supports optical connectivity up to 60 meters in length. And Thunderbolt allows you to daisy chain devices from one to the other, so you don't have to have all of the devices directly connected to the computer.
No, it's me. You'll see my picture
Monitor,
on the email.
Connect to
Acquired information.
And have that second monitor connect to an external storage device.
That was my PI company name.
It knows what devices are connected in that chain, and it knows exactly what device to be able to send and receive information from. The newer Thunderbolt 4 standard still provides 40 gigabits of aggregated throughput, but it improves its video output to support dual 4K displays. This also increases bandwidth to the PCI Express bus, allowing much more data to be transferred from the motherboard to these peripheral devices.
When you're watching the other football but don't want to ask your friends, what's offsides? And how can I sound like I know?
If you're connecting a computer to a screen, or really any type of consumer electronics to a video display device,
I don't know why I'm blocking you, but I will get to my setting and figure it out. No problem.
Or maybe somebody on that list, if y'all see 1988, put your email in the thing for me, Charles. Somebody forward it to him.
One of the most common connector types that you'll
We'll
find
pick one person. Who got it?
and televisions.
I haven't received it yet.
Okay, Kevin or Aaliyah, can you forward it to Charles? Okay, Aaliyah says she'll forward it. Maybe that'll solve it.
DisplayPort, but it also has an HDMI connection right here at the bottom. You can see that it's almost in the shape of a rectangle, but the bottom corners are indented in just a bit, which means that an HDMI cable would be the only thing that would fit into that interface. On that picture of the display adapter, we saw that one of those interfaces was a DisplayPort interface. DisplayPort is a video format that is also able to send audio and video over the same connection, and it was one of the first display type connections that sent it in a packetized form, very similar to how you might send information over an Ethernet network. This also has some compatibility with both HDMI and DVI. You can use a passive adapter to convert between DisplayPort to HDMI or DisplayPort to DVI. On some devices, you may find that the DisplayPort interface is the smaller style, known as the mini DisplayPort, but on desktop computers and video interface cards, you'll probably find the full-size DisplayPort connector. Notice that the DisplayPort connector has small little locks along the top of the connector, and when you plug it into the interface, it tends to lock in place. This means that connector will not accidentally pull out of that connector, and usually there's a button along the top or the sides of the connector that allow you to unlock the connection so you can pull it out of the interface. If you are trying to disconnect the cable connection from a computer and you notice that it's not coming out of that connection, then it probably is a DisplayPort interface and you'll need to press down on that button before removing it from the computer. Here's another video card with many different types of video outputs, not just DVI and HDMI, but a number of different DisplayPort connections. You'll notice that DisplayPort and HDMI are similar to each other, at least in size, but they are very different in their form factor. You'll notice the DisplayPort is a bit of a rectangle with one of the corners that's a little bit slanted. That means that you can't accidentally plug in HDMI to DisplayPort or vice versa. If you're working with some older systems, you may run into a DVI interface. That stands for Digital Visual Interface. One of the challenges with DVI is that it's a single connector type with multiple types of connections. So you can see there's a DVI-A, a DVI-D single link, DVI-D dual link, and so on. As the name implies, a single link and a dual link video connection are able to send different amounts of traffic, effectively doubling on the dual link connection. A single link can transmit information at approximately 3.7 gigabits per second, which is able to support a traditional HD connection, which is 1920 by 1200 in resolution. We saw with HDMI and DisplayPort that we were able to send both audio and video through the same connection. If you're plugging into a DVI connection, you are only sending video signals through that connector. You might also run into some other variations of DVI, such as the DVI-A that's able to send analog signals. This is a standard connector that is able to coexist or be backwards compatible with VGA. We'll look at VGA connectors in just a moment. DVI-D connectors are sending digital information, and if you run into a DVI-I connection, that is a DVI integrated connection, it can send both digital and analog signals in the same connector. If you are working with DVI, make sure you look at the connector that's on your computer and the connector that you're using for your cable to make sure you're using the proper connection for both of those devices. And depending on the video card that you're using, you might have an option as to which DVI connector you might use. So it's important to know that there are differences and you'll need to make the right decision over which interface would be the best one to use for your purposes. Legacy equipment tends to use a video standard known as VGA. This is the Video Graphics Array Standard. VGA uses this standard connector we refer to as a DB15 connector. There are 15 pins inside of the connector, and the connector itself is shaped like the letter D. The size of this connector is an E shape. Technically speaking, this is called a DE15, but you'll also see it commonly written as DB15. You'll also notice that VGA connectors tend to have a very standard blue color associated with them. That's because there are a series of standardized colors that were rolled out as part of a PC system design guide. VGA, very similar to DVI, only sends video signals through this link. We don't send any audio over these VGA connectors. And because this is an analog signal, we tend to start seeing a degrading of signal once we get past 5 or 10 meters of total cable length. Here's the back of a motherboard that supports a number of different video types. There is HDMI plugged into a connector. We can see there's VGA on this motherboard. This motherboard also supports a DVI connection. Although we tend to see a number of different video standards, fortunately the connector types are very different between all three. So it should be very easy to differentiate between VGA, DVI, and HDMI. These days, we're also sending a lot of video signals over a USB-C connector. USB-C is a connector type, and there could be a number of different signals going across that particular cable. For example, USB could be sending power or serial data over that connection, but we could also put Thunderbolt data, DisplayPort, HDMI, and a type of connections for mobile devices called a Mobile High Definition Link, or MHL. This means some devices are able to send many different types of signals over that same USB connection, and all we need is to provide the right cable and the right connection.
Customize and save with Liberty Mutual! Ciao! It's Italy, baby! Where's my line?
If you're connecting a hard drive inside of a desktop computer, then you're probably using a standard interface known as SATA. This is a serial AT attachment, and there have been a number of different versions of SATA through the years. There was a SATA revision 1.0 that supported 1.5 gigabits per second. Version 2.0 doubled the speed to 3 gigabits per second. Version 3.0 doubled the speed again to 6 gigabits per second. With SATA revision 3.2, the speeds increased to 16 gigabits per second. And there's an external version of SATA known as eSATA. It's very similar in functionality to the internal version of SATA, and it supports connecting an external drive over a cable that's approximately 2 meters in length. The SATA standard supports 2 physical connections on the back of these storage drives. One that is 15 pins, the longer connector, is used for power, and the smaller connector, which is 7 pins, is used for data. This particular drive not only supports the SATA power connection, but it also supports the older style Molex power connector. With SATA, there's a direct connection between the drive itself and the motherboard connector. It's a one-to-one relationship. So the one cable that you're plugging in for power has a single cable that's plugging into your power source or your power supply. The other cable used for data is a single cable that's running from the storage drive to the data connector on the motherboard. SATA doesn't support any type of daisy chaining or multiple drives on a single cable, so this makes it very easy to understand. If there are 8 SATA interfaces on a motherboard, it can support 8 total drives. The SATA connectors are very easy to pick out on a motherboard, such as this one. You can see the SATA connectors are here closer to the bottom of this motherboard. If we zoom up a bit, you can see this motherboard supports both SATA 2 and SATA 3 standard connectors, and it looks like there's a total of 6 connectors on this motherboard. Here's another motherboard with a slightly different alignment of SATA connections, and this motherboard appears to support 4 different SATA data connections. As I mentioned before, it's a one-to-one relationship between the connector on the motherboard and the connector on the storage drive. You can see we have a blue, orange, and black cable coming from the SATA connections on this motherboard, and they're corresponding to the blue, orange, and black data connectors on these drives. This is obviously only half of the connections that we'll need for these drives to operate. They'll need power, so we need to plug in the SATA power connectors on each of these drives. It's relatively straightforward to connect a SATA drive. You obviously have the data connection and the power connection. To be able to connect the drive to the data line, we simply plug in the data cable, and now we have a connectivity between this drive and the motherboard. As I mentioned earlier, there are not only standards for internal SATA connections, but there's also a standard for an external SATA connection. And these are different types of connectors. The signal sent across the wire is effectively the same between the internal and external drive, but the connector itself is slightly different between the two. It's difficult to put these side by side because obviously the SATA standard is generally on the inside of the computer, and the eSATA standard is almost always on the outside of the computer. But you can see the SATA connection has that very distinctive L shape associated with it.
All right, so right there with you, Kevin says IPv6 addressing.
It has a completely different style, and you obviously can't plug an eSATA into
Hold on one
a SATA
second,
connection
let me switch
and
my monitor
vice
back.
versa. If you're using an eSATA, you will need an eSATA cable, and if you're plugging it internally to a SATA drive, you will need a SATA cable. So if you're looking at the back of your computer and you see a couple of connectors that you may not immediately recognize, have a closer look. Those might be eSATA connections.
So are you wondering how it's used to configure networks or just IPv6 in general?
Kind of both, but mostly like the general. Like, you know how you broke down how IPv4 works and like how like the binary numbers make each like digit like that part I don't get.
Gotcha. Okay. So we know that
Here we go. Third time today.
IPv6 is 128-bit address, right?
Our shelves are filled with new,
So
exciting,
when you're looking at
delicious discoveries.
the address, you have to see, let's say an example. Let's see, IPv6 address.
In your IT career, you will have many
How many
where you need a certain type of cable, but you don't have that
hextets,
exact cable in your tool.
as they call them,
However, there may
are in
be
an
ways to put
IPv6
multiple devices,
address.
cables, and adapters together to create the type of interface you need. Sometimes these connections are electrically compatible with each other, and you simply need a cable that has one type of connector on one side and another type of connector on the other. But occasionally you'll need to convert from one format to another, so there may be some additional processing that occurs or power that's required to facilitate that process.
I'm going to share my
Most of
screen
these
with you.
adapters and converters are designed for temporary use, although sometimes they do.
So how you look at this is,
connection. When we were moving from DVI
in your different groups,
HDMI, we tended to use a lot of
and maybe I should take a snippet of this. Hold on one second.
or DVI to HDMI.
Y'all know me, I'm all about the snippets.
The digital version of DVI.
Snippets get stitches.
Which is also a digital standard, are electrically
Gotcha.
compatible
Listen.
with each other. So you could connect one end of the cable other end of the cable to HDMI, and you'd be able to send that video signal from one
All right,
device
so I'm
to the
about
other
to.
without any type of signal conversion. The DVI to HDMI.
Oh, okay, Michael, can you take a can you take a screenshot and share that with people?
Of course, but it does
Because
provide
mine is acting
from
funky. You got it already?
to the other. Another useful backwards compatibility.
Okay, so Mike's gonna take a screenshot and share it with you.
The analog version of
So this is what we're looking at. So you have group 1, group 2, group 4, 6, 7, and 8. So it's divided by 8. What's 128 divided by 8?
You might just need a simple adapter and change from the VGA 15-pin connector to the larger DVI connection. If you're moving from the analog VGA connection to a digital
My calculator challenge, folks. I'm gonna do help you out. 16.
But in a pinch, these types of converters can
128 divided by 8. So you got 16.
change between one video standard.
There you go. Mike's got it in there.
If you have a
So what's going on in each one?
you might notice is that those laptops are getting thinner and thinner.
You pretty much have 16, the 16 bit that is in each one of these groups.
But in many cases, we
You know what I'm saying?
wired connectivity.
All right, you follow me? You there now? Okay, now watch this.
Some type of adapter or converter that can change.
We're gonna walk it up the line. We're gonna walk it up the line.
If you don't want to rely on wireless
So we need to understand
wired connectivity to directly connect to a device or to perform network troubleshooting, then having one of these converters in your bag can be very useful. Another challenge you might run into
that each one of your
laptops no longer have the
how they come up with that is
connectors. For that reason, we
you have the ASCII table that could be used.
from USB-C to USB-A.
All right, that's the standard code from what you have. This is what the computers use to actually read information. Do you see in the middle where it has hex? And each column has the hexadecimal? All right. So it uses the hex and a number to create hexadecimal characters. Now, you can only use A through F, 0 through 9. Those characters are used to build your hexadecimal characters in each one of those areas. Can we do it with a whiteboard? Yep, we can do it with a whiteboard.
Like your period.
I can do it after lunch, actually. So this is kind of like a preview. So what you're seeing is
This is a team feeling zen.
those hexadecimal characters in each one of these groupings are being built right here. You can only use A through F and 0 through 9. So for this one, they're using a numerica 2. If we have to go over here and look at our decimal character,
This is a 6-position connector with 2 conductors inside.
let's do this.
Written as 6P.
Let's look up our hexadecimal table.
With 4 wires or 4
Makes it better.
inside, which technically makes it an RJ14, but generally speaking, we call them all RJ11 connectors. This is the type of connector that you will commonly use if you're plugging into an analog telephone connection, or more recently, a DSL or digital subscriber line connection. So if your internet connection uses these telephone cables to bring in that digital signal with DSL,
There you go.
you're using an RJ11 connector.
That looks a little bit
The larger
less
version
noisy.
of this modular connector is an RJ45. That stands for registered.
I'm gonna drop this in the chat for you.
45. This is an
Doink.
8-position connector with 8.
So if you're looking at your hexadecimal table, you could use this to do your conversions for your IPv6 addresses, knowing what's in each grouping.
It is very commonly used for Ethernet networks, but RJ45 connectors can be used for serial connections and many other connection types.
All right. So if we look at our hexadecimal,
in the size of an RJ11 versus an RJ45. They're next to each other here on the back of this DSL.
here's your equivalent that's going into 2001. Your hex is 0, but when it comes out to binary, this is what they're saying. 0, 0, 0, 0, 0, 0. 2 for the hexadecimal The binary is 0000100, and then that goes. So you're putting all of that together in one grouping, one long line for hexadecimal. Does that make sense?
Is it still using like the table that we use?
Copper connection is an F.
Oh, you're talking about the IPv4 table?
Television connection.
Yeah, like 128, 192.
It is not.
Obviously, your
All right, Mr. T.
coming in
It is not.
cable provider or
It is, but it isn't. Because your binary equivalent is longer, it refers to the ASCII or hexadecimal table to do it, to convert it. Does that make sense? It's not as simple in each one using 128, 64, 32, right, to build the table. But remember, those parameters in that table go 0 to 255 bits. In this whole address, you're using 128 bits. 128 positions. So, to answer your question, yes it is, but no it is not. Does that make sense? Because it's going from 0 to 128. Where you're using IPv4, you're using everything from 128 through 255. Does that make sense?
You may have large walls of punch-down blocks that are used to terminate those wires.
No, you will. The only thing you need to convert for the exam is the example we see here on the screen. Remember we were talking about you have to shorten the address? The rule is when shortening an address, you can drop the preceding zeros, only the preceding zeros, right? So it can go 2001, drop that, it'll become DF8, 0F2. This now becomes a semicolon because you took 8 zeros and put them together. So it's semicolon, semicolon. You can drop the 0 there, so it'll be 6 echo, echo. And in group 7, you can just use a 0 if you wanted to.
Here's a similar punch-down block. In this case, the wires are run on the outside, and the
Hold on a
wires
second.
themselves are individually punched down to the individual connectors on the punch-down block. Some of the most common copper connectors you'll run into are USB, or Universal Serial Bus. If you're running USB version 1.1 or 2.0, then you'll probably see a standard A plug very similar to this one. The standard B plug is a more square plug that's used for peripherals. And if you're using a mobile device, you're probably using a mini B plug.
All right, so you can drop the preceding zeros. So that's the only thing, Leah, that you see on the exam as far as very in-depth on the address. Shortening an address and then writing out the binary equivalent to the address. You might see that. Or converting it back, putting the zeros back.
Creates additional cables and additional confusion. So instead, we have encapsulated.
So you are less likely
into one single type of
going to see a lot of
USB-C is the physical connector type, which means we can
questions about IPv6. Now, to further that,
for example, you could run USB connections over this, Thunderbolt, HDMI, and many other types of signals.
Well, remember, you can drop. Oh yeah. So with a preceding 0,
you may find that there is a 4-pin power connector.
If there was a preceding 0 in that third group,
inside of that computer.
00F2, yes, you would drop the 1, 0. Yes, correct.
Technically speaking,
all right.
The connector itself was created by a company named the Molex Connector Company. So to call this a Molex connector is only one of many different.
Now, IPv6 common addresses.
Connector company. You also see this connector referred to as an amp mate in lock. This is a connector that provides power for fans, storage drives.
These are the ones you would need to know. You need to know these. You'll get caught on the exam with these prefixes. All right. So for the loopback address, not link local, the loopback address for testing, for self-testing. And don't worry, grab these out of the chat.
Your security concerns starts with a prompt.
Put them on a table or something.
If you look at one of these older power supplies, you'll see that
loopback address is ::1
for that power supply.
For IPv6.
You can see other connectors such as the main motherboard power.
The local link for the data link layer for local communication on a network starts
Many
with
of our newer mobile devices use USB connections to
FE80.
be able to connect to power and data sources. But if you're using an older
FE80.
device from Apple, you may
Okay.
be using a Lightning connector. Lightning is
Now,
Apple's
remember we were
proprietary
talking
connector,
about
so you'll only
that
see this used with other Apple
unspecified
products,
address?
and it's usually associated with iPhones, iPads, and other similar
The
devices.
same thing we have the same address that is in IPv4. It's the default 0000 address. It's the same thing in
And
IPv6.
they wanted a connector that could be inserted either way and still operate.
Okay?
Although the industry is moving.
The next one you'll see,
as a standard,
if it is a unicast
Lightning connections.
address,
If you're a
you'll
system
see it
administrator or a network
look like
troubleshooter,
this. Now, there's
you need
unicast in
a
IPv4 as well.
connection to connect to
And
several
multicast. The
switches,
multicast
routers,
address in
firewalls, and other
IPv4 starts with
devices.
224.
Connectors commonly transmit serial
And
communication.
IPv6,
Standard for that
you'll see it start with
communication,
2000
stands for recommended
colon
standard
colon.
232, and it's been around in the industry since about 1969. These days, we commonly use USB as
You
our
might get a multicast address for IPv6, and generally, this is what you're gonna see. It starts with FF0.
Probably using DB9. These days, we still keep these in our bags because there are a number of switches, routers, and other infrastructure devices.
Okay.
That use this
Now,
type of connector as their console port. If you need to be
here's the rules for shortening.
Devices and configure them, add a command
It's right there. Omit leading zeros, and you can collapse 0 blocks that are inconsecutive. We've done that. All right. If I could tell you anything you need to know for the exam, those are the ones you need to specifically know for the exam for IPv6. 128-bit address, link local testing address, colon 1. I don't know if I'm even saying that right. Somebody correct me if I'm doing it wrong. I'm saying it wrong. Link local address, FE80. Know that. Default address, zeros all the way across. Broadcast address, all you gotta remember, all you're gonna see is F's. Remember? It's just F. Broadcast address for IPv6. Just remember this. F's. All right? So they can speak to every network interface that is using IPv6. That's how it's going to talk to those interfaces. Just F's, okay?
Function on the side where you would push it in and then slightly turn it to lock it in place. Another more modern
and that's about what you need to know now. And I'm gonna let y'all go to lunch.
You might
It's 2
also
minutes.
see this referred to as a square connector or a standard connector. This style of connector also locks in place, but instead of using a bayonet, you push it in and it locks. You would need to slightly pull on the outside of the connector.
You need to know how it's broken down.
Removed from that interface. This is a popular style of connector, and it's used across many different devices, patch panels, and other components within the data center. This style of connector can be used with individual fibers, or you can combine them together as one single unit with a pair of fiber inside. This makes it very easy to connect and disconnect both the send and receive side from a connection all at the same time. There's always a need to fit more connections into a smaller amount of space. In order to do this with fiber, you can use a lucid connector or an LC connector. This is a much smaller, more compact connection.
Right there.
This one holds in place with a clip that's on the top of the connector. You might also see this connection type referred to as a local connector or a little connector.
This is what you need to know if they ask you on the exam.
Both sides are connected together so that you can easily connect and disconnect a pair of fibers simultaneously. And here's all three of the connectors.
I don't want to cloud up the right here. What makes up an IPv6 address? The first 64 bits are the global unicast address. Okay, so the first 48 bits pretty much belong to the manufacturer of the, or the, not the manufacturer, but the first part of the network ID, Okay. Next 16 bits is the subnet. And then the last 64 bits is basically the IP address. Okay. It says interface ID, but it's the IP address. That's how it's built. So the first 64 bits belong to the network. The last 64 bits belong to the interface. That's how the addresses are created. Okay? So basically, first 48 bits belong to the organization. The 16 bits that follow belong to the subnet. Last 64 belong to the item. Whatever that end item is that can use IPv6, it belongs to the endpoint. Okay? That's a quick of what you're going to be asked for IPv6 on the exam. Okay, so scan that quick material, or at least once a day. You don't need to go crazy, but just to be able to identify. Oh, okay, that's a link local address. Oh, that's a loopback address. Oh, that's a. And if you can do that, you're fine. Other than that, you ain't gonna see no other IPv6 questions.
You often hear the term memory.
Now, Leah, I know it was a long way around, but did I answer your question?
We're running out of memory. When we're talking about memory, we are
so that's what you got.
Random access memory, or RAM. This is the most common type of memory that you will find inside of our computers. But of course, it's not the only type of memory you might run into.
We do targeted learning here.
We're not referring to the long-term storage you might have in your computer.
Now, after the exam, if you want to read up more on IPv6, go ahead. But store what you need to store so it doesn't take up room for anything else.
Yeah.
RAM is temporary high-speed storage that we use when we are executing applications and performing calculations in our computer. The only way your computer can work with data is if that data has been loaded into the RAM of your computer. So it's very common to load applications and data from
everybody, we are at lunchtime.
Process that
so if you want to clock out, you're welcome. I'll see you in about an hour.
Back onto your hard drive or your SSD. We've seen a number of changes to memory technology through the years, and every few years we tend to update and make enhancements to the memory that we're using inside of our computers. The speed of your memory is often associated with the overall performance of your computer. If you have faster memory, then you tend to have a faster computer. But a single stick of memory is not generally compatible with every computer you might find. Every motherboard is slightly different in what it expects from your system memory. So if you're ever performing a memory upgrade or you're moving memory from one system to another, be sure to check the documentation of your system to make sure that the memory you're installing is compatible with that motherboard. Instead of having individual memory chips that we would install or remove from a motherboard, we have a single memory module. We refer to this as a DIMM, or dual inline memory module. The reason we refer to this as dual inline memory module is that one side of this module has a series of electrical contacts. If we turn this module over, there are also another set of electrical contacts on the other side. And the contacts you see on this side of the memory module are different than the contacts you see on the other side of the memory module. Since there are two separate lines of contacts, we refer to this as a dual inline memory module. You might also see that information that is written or read from memory is done in 64-bit blocks. We refer to this as the data width of memory. So if you ever perform any calculations on how much information you're reading or writing from memory, you'll notice those calculations use a 64-bit data width. Since we are putting all of these individual chips on a single memory module, it makes it very easy to install and remove from a motherboard. You can install and remove the entire DIMM at one time by simply pushing it into the slot. To remove this module, you would pull back the locks that are on the side of the module and simply pull the module directly out of the motherboard. If you're working on a laptop or another mobile device, then you're probably not using a full-size DIMM. In order to shrink things down to that smaller size required for a portable device, we use a smaller version of a DIMM referred to as a SO-DIMM. This is a small outline dual inline memory module, and it's about half the size of a normal DIMM. If you need to add or upgrade memory in a laptop, you're probably going to install a SO-DIMM. The process for installing memory into a laptop is very similar to the process you would use for a desktop computer, although you'll notice very often those memory modules in a laptop are installed horizontally to save room. You would slide the memory module in, push it down, and it will lock in place with the locks on the side of the memory module. Here you can see the difference in size between a DIMM, which is the longer module on the top, and a SO-DIMM. You can see that the smaller size of the SO-DIMM does make it a better choice for mobile and laptop devices. On the DIMM are installed individual memory chips. Those chips are dynamic random access memory. We refer to this as random access memory because you can access any data on any of these memory chips at any time instantaneously. We don't have to fast forward or rewind through the memory like you might have to do with a magnetic tape. We can instead reference exactly the data we need by simply referring to its address in this memory chip. The type of dynamic random access memory that we use in our computers is a version that is synchronous, or SDRAM. Synchronous dynamic random access memory is one that is synchronized to a common clock inside of your computer. That common clock keeps data moving inside your computer at a very standard rate. And since the CPU and memory inside of your computer is running at such a high rate of speed, having this common clock allows many of the components inside of your computer to keep track of a standard rate of data that may be transferred back and forth. There's another interesting technology that memory uses to be able to transfer data at higher rates of speed. An older style of memory used a single data rate to be able to transfer information from memory into CPU and then back again. And it used the clock rate to be able to manage this transfer of data. One single clock cycle would result in one bit of data being transferred. The next clock cycle would be the next bit of data, and the next clock cycle would have a third bit of data. In order to improve on that data transfer, we introduced a new type of memory technology known as double data rate.
Organic and dairy-free? Woo! Woo!
Here we go.
Third time today.
At Sprouts, our shelves are filled with new, exciting, and delicious discoveries. This is that Sprouts feeling.
Not all oral care is created equal. The Colgate Total Active Prevention System is engineered to be 15 times more effective at fighting the root cause of oral health problems. It's our best science ever to prevent problems before they start. Be dentist ready with Colgate Total.
This DDR memory can transfer information at the top and the bottom of the clock cycle, effectively doubling how much information can be transferred from memory to CPU and back again. So going up on one clock cycle would be one data transfer. Going down on that clock cycle would be another data transfer. And you can see that we have effectively doubled the amount of information we can transfer over exactly the same amount of time. The memory that you use inside of your computer is double data rate memory. You'll see it often represented as DDR. And there will be a number next to the DDR to designate the version of DDR that's installed. For example, your computer may have DDR3 memory inside of it. This is a memory module that was upgraded from the older DDR2, and although it could increase the total capacity that we can have on a single memory module, it was not backwards compatible with the older DDR2. So if you were upgrading to a motherboard that supported DDR3 memory, you would not be able to move over your older DDR2 memory. You might also find that your computer supports a faster type of memory known as DDR4. DDR4 also increased speeds over the older DDR3 technologies, and because this is a newer style and technology of memory, it is not backwards compatible with earlier versions of DDR. With DDR5, we improved on DDR4 by increasing the speed of the data transfers between the memory module and the CPU on the motherboard, and this is one that also is not backwards compatible with that older memory. And if we were to come out with a new version of memory with new types of technologies, it's very likely that the newer technologies would also not be backwards compatible. Fortunately, we built in engineering into these memory modules that would prevent it from being installed into the wrong motherboard. If you look closely at the memory modules themselves, there are small keys or holes at the bottom of the memory module that correlate to a key that's on the motherboard itself. This means that a DDR2 module can only fit into a motherboard specifically designed to fit that particular key space. If you were installing DDR4 memory on a DDR3 motherboard, you would see that those memory modules would not fit because the key is in the wrong location.
This weekend's really big deal. $125 17 styles to fit everyone.
Yes, JCPenney.
This is LinkedIn Recruiter, a hiring tool that helps you hire smarter and faster with over 1 billion global professionals.
These profiles are verified so we know who exactly we are hiring.
Hire smarter and faster with LinkedIn Recruiter today.
The memory modules that we use inside of our computers can be different depending on what that system is used for. If it's for a desktop computer at home, it might have standard memory inside of it. But if we're using this inside of a server, we might need memory that has some additional capabilities. So if you're running a web server, database server, or any other important service, you might want to use one of these memory types. The first memory type you might want to consider is parity memory. This is memory that includes an extra parity bit with each byte that is stored in the memory. This will not always detect errors that may have occurred in that memory, and it's not able to correct every error, but it can tell you that a memory error has occurred. This often requires the system halting and requires a full reboot, but at least you were informed where the problem was occurring. Well, if you were able to recognize an error with the memory, then it might be possible to correct that error. If you were running ECC memory, you would be able to provide that correction. ECC is Error Correction Code. It not only determines that a memory error has occurred, it can correct that error and the system will continue to run normally. Physically, the memory modules that you would use for standard memory, parity memory, or ECC memory are all about the same size. They look very similar, and you have to look at the details of those memory specifications to even know there's a difference between those different memory types. So how are these memory types able to recognize that an error has occurred? It's able to do it because it's saving some extra information in that memory called a parity bit. It's able to look at an entire byte of data, a byte being, of course, 8 bits in length, and it adds effectively a 9th bit to that particular byte. In most systems, the parity bit that we use is referred to as even parity because the bit that we're going to add will make all of these bits add up to an even number. Let's give it a shot and see if we can calculate the parity bits for these 3 bytes. We'll start with the first byte across the top, which is 1110011. We'll add up all of the ones in this particular byte. It would be 1, 2, 3, 4, 5, 6. This means that we already have an even number for this particular byte, which means our parity bit would not add any additional bits. We would instead add the parity bit as a 0. Let's try another one. We have 0, 0, 0, 0. 0010. If we count up the number of ones, we have 1, which means it's an odd number. So to make this even parity, we need to make our parity bit a 1. And now all of the ones on that line add up to an even number. Now let's do a third byte. This one is 1001 1000. If we count the number of ones, there is 1, 2, 3 ones. So that is an odd number. To make this even parity, our parity bit then needs to be 1. And now we have parity that we've calculated for all 3 of these bytes on our system. When we're writing this information into memory, we would write it with not only the 8 bits of the byte, but we would include the parity bit in that storage as well. When we retrieve this information from memory, we evaluate this byte, we perform our own parity check, and then we compare that parity bit to the one that was stored in memory. If those parity bits are identical, then we can assume that that particular byte is intact and there's no errors. And if those parity bits are different, then we know some type of error has occurred either with the process of writing that information to memory or reading that information from the memory module. So let's perform our own parity checks. Here's information that has already been stored in memory. Let's retrieve this from memory and see if it matches what we would expect. Let's look at the first byte, which is 00000111. We know that if we count those up, that is odd number, which means the parity bit should be a 1, and in this case, the parity bit that we pulled from memory is a 1, so that particular memory is valid. Let's go with the next byte, which is 00000010. We see that this is an odd number, so to make this even parity, our parity value would need to be a 1. But the parity value in this case is a 0, which means some type of error has occurred with that byte. And lastly, we have 0110, 0100. If we count the number of ones, we have 3, which means we need to add 1 more to the parity bit. Indeed, that is already a 1, which means that particular byte does not have an error.
Modular Rewards introduces the industry's most expansive global rewards marketplace, featuring millions of unique products and experiences, all delivered seamlessly through a single powerful solution. With maximum choice and unmatched flexibility, it is designed to create personalized, dynamic experiences for any audience. This is Modular Rewards. Schedule your demo today.
Native deodorant sprays unclean, which means no little clouds are survived.
If you were to examine the amount of data that's moving around your computer, you would find an enormous amount of data being transferred between the memory and the CPU. This is what we refer to as the memory bandwidth, and it is an important measurement to determine just how fast your computer is able to operate. We often refer to this data transfer rate in megatransfers, or MT per second. This refers to million transfers per second. If you were to look at a memory module, one that you were either purchasing online or at a store, it might say that it is a 32 gigabyte DDR5 memory module or a 1 by 32 gigabyte, and it also might tell you that this module supports 5,600 billion transfers per second. This is why the memory bandwidth that's on a particular motherboard is such an important statistic. If we want to increase the speed of a system, we would generally need to increase that data rate between the CPU and the memory. One of the challenges we have with constantly increasing these speeds is that eventually we hit a maximum of what is humanly possible. So if you're moving information from memory into a CPU and then back to memory again, you may find that you're able to max out the total amount of throughput available over that particular pathway. One of the challenges with this is that the CPU has quite a bit of idle time while it's waiting for this transfer to occur from memory to CPU and then back again. While that's going on, we could be performing other calculations, but the problem is that the bandwidth between these two is not enough to support the overall speed of the CPU. In order to increase these throughputs, we might add an additional channel between the CPU and the memory. This allows the CPU to communicate to multiple memory modules simultaneously, thereby increasing the overall throughput of your system. If you were to look at your computer, it may support multi-channel memory, which could potentially double the total throughput between your memory and your CPU. If you check your motherboard documentation, you may see the motherboard supports dual channel memory, triple channel memory, or even quad channel memory. This means that you could add 2, 3, or 4 separate memory modules inside of your computer and increase the total throughput of that memory bandwidth by that total amount. If you are planning to implement multi-channel memory, it's very useful to have memory combinations that match each other. So the modules that you would install for dual channel, triple channel, or quad channel should all be the same type of memory, ideally even the same make and model. The motherboard manufacturers have tried to make this a little bit easier for us by coloring the different slots in the memory modules. So on your motherboard, there might be 2 different colors of slots. This particular motherboard supports dual channel memory, and there are 2 separate dual channel configurations. one that is colored with the black memory slots, and one that is colored with the red memory slots. So on this motherboard, if you wanted to install this into a dual channel configuration, you would add memory modules into the slots that had the same color. This is one of the reasons you might often find your systems being shipped with two 16 gig memory modules rather than one single 32 gig memory module. Even though the total amount of memory is exactly the same in those two systems, having two separate memory modules provides additional throughput between your CPU and your memory.
If you have a small business, you could be wasting money on your mobile plan, paying for stuff you don't need. Introducing My Biz Plan from Verizon Business. Choose exactly what you want, pay only for what you need. My Biz Plan from Verizon Business.
This is not normal. But who wants to be normal? When you can be part of something special.
The memory in our system is volatile. That means when we power off our computer, all of the information in memory disappears. To be able to retrieve that information later, we need some type of device that's able to maintain that data even when your system has no power. Fortunately, there are many different ways to accomplish this. We could have a hard drive, a solid-state drive, a flash drive, a memory card, an optical drive, and other storage devices as well. One of the most popular forms of storage is a hard drive. This is a magnetic device that has rapidly spinning platters that are inside, and all of your data is being stored onto those platters. This is a random access method of storage, so we can store information anywhere on that drive and access that information immediately by simply accessing the address where that information is stored. If we were to look inside of this hard drive, we would see there were a lot of different moving parts. For example, there are platters inside that are spinning around thousands of times in a minute. You have a moving arm that is able to take a small head that reads and writes information from these spinning platters. And there are also other mechanical components that are then moving the arm back and forth. Because these are mechanical, any one of these components could potentially fail at any time. You obviously don't want to remove the top of your hard drive because this is an area that needs to remain dust-free. Inside your drive, though, are components that are very similar across all hard drives. One of these is the spinning platter, and that is where all of your data is being stored. We also have a spindle in the middle that is spinning the drive at different speeds. We'll look at those in a moment. We also have an actuator that is able to move an arm that has at the end of it a read-write head that is actually performing the reading and writing of that information to the platters that are rapidly spinning just underneath it. Different hard drives spin at different rates, and if you look at the specification for a drive, you'll see that it probably rotates at 5,400 revolutions per minute, 7,200 revolutions per minute, 10,000 revolutions per minute, or 15,000 revolutions per minute. The reason there are differences in these revolutions is that the arm is in one place. We have to wait for the platter to spin around to be able to read the data that needs to move underneath that read-write head. The faster that spindle rotates, the lower the latency will be, which means we'll be able to read or write information faster if we're on a 15,000 RPM drive versus a 5,400 RPM drive. From the side view, you can see that often there's more than one platter. This drive has multiple platters where information is being stored. And if we were able to look underneath, we would see that there is an actuator arm and a drive head, not only on the top of the platter, but also on the bottom of the platter. There are also different sizes of drives. Inside of a desktop computer, we don't have to worry too much about the size of a storage drive because we have so much room to be able to store that inside of that unit. But if you have a laptop or other mobile device, having a smaller storage device is going to save you that much weight and that much space in that mobile device. If you're working on a desktop, you may be using a 3.5-inch drive. You can see the size of that is listed here, and the 3.5 inches refers to the width of the drive. There's also 2.5-inch drives. These are common to see inside of mobile devices and laptops. And on modern computers, you may be using an SSD that doesn't use a 3.5 or 2.5 inch, instead is a much smaller 22 millimeters in width. Many of us have upgraded our hard drives to SSDs, or solid state drives. These contain non-volatile memory inside, which means there are no moving parts, thus a solid state device. A significant benefit of having solid state drives is its raw speed. Solid state drives are many times faster in reading and writing information than a traditional hard drive, so by simply replacing a hard drive for an SSD, you can greatly improve the overall throughput of a system.
With King Soopers same-day pickup and delivery, it's easy to shop the same in-store prices and have your groceries brought right to you. So you never compromise on what matters most. King Soopers, fresh for everyone.
And if we remove the top of an SSD, you would see that we don't have any moving components inside. In fact, most of the components that we're able to see offhand are simply the memory modules where your information is being stored. When we moved from hard drives to SSDs, we immediately saw an improvement in performance, but we also saw that we were hitting the maximum limit of what a traditional SATA connection would provide. We needed some way to increase the throughput of these SSDs, and one of the ways we did this is to connect the SSD directly to the PCI Express bus of our computer. One of the most common ways to do this is to use an adapter card where we can install the SSD on the card itself and plug it directly into the PCI Express bus on our motherboards. This meant that the motherboard was providing the power and giving us the throughput that we now can get from a PCI Express bus, which is much faster than the bus that we had connected to a traditional SATA drive. Instead of limiting ourselves to the 6 gigabits per second that you would commonly see with a SATA connection, plugging into the PCI Express bus allowed us to get speeds of around 64 gigabits per second per lane. This greatly improved performance, and we were able to take advantage of the full throughput available to that SSD. But of course, not every device has a PCI Express bus that you can connect to. Laptops, for example, don't allow us the room to be able to install a full-size adapter card. If we were to look at the SATA technology that we're currently using for hard drives, it uses a standard called AHCI. This is the Advanced Host Controller Interface. This is the standard used to move data from the drive into memory and back again. If you were to look at SATA revision 3, it provided throughput for the SATA connection up to 6 gigabits per second. But as we've already seen, that value is much too low to be able to provide the total throughput that we could get from an SSD. To be able to increase the speeds of these throughputs, we created a new method of communication referred to as NVMe. This is the non-volatile memory express. It has very low latency and can support higher throughputs because it is directly connecting to the PCI Express bus, even if that bus is one that's inside of a laptop. A very common interface into this PCI Express bus on a laptop or desktop computer is made through a new interface referred to as the M.2 interface. And if you are using NVMe on this M.2 interface, you now have a theoretical transfer speed of approximately 20 gigabits per second, which is obviously much better than the 6 gigabits that we had from the SATA connection. But in some cases, we are still using these hard drives inside of a desktop, and we still need a way to improve throughput to the information that's on those hard drives. To increase this throughput, we've added a new method of communication referred to as Serial Attached SCSI, or SAS. Serial Attached SCSI is a serialized version of the SCSI technology that we've been using for many years. So now we can take advantage of the SCSI protocol to be able to control and manage the data that's on these drives. And by upgrading the communications path to be a serial connection, we can now reach speeds of approximately 22.5 gigabits per second. And this is obviously much faster than the 6 gigabits per second that you would commonly get from SATA. And we expect that future versions of Serial Attached SCSI will even provide faster throughputs than what we're seeing today. Here's the interface on a Serial Attached SCSI drive. There are two different connections on this drive, one that's used for data and one that's used for power. And if you look at this drive, it looks very similar to the configuration you might see on a SATA drive. In fact, this is very similar with the data on the left side and the power on the right side. If we were to put a SATA drive right on top of this drive, you can see that indeed they are very similar to each other in their form factor. However, you will notice that the SATA drive and the SAS drive are slightly different in the connectors that are used. This is to prevent you from accidentally plugging a SATA drive into a SAS drive configuration and vice versa. So if you have large storage arrays of spinning hard drives, you may want to focus on using SAS arrays with SAS drives to get the highest throughput possible for that hard drive technology. As our storage technologies continue to shrink and our interfaces to those technologies needed to become even faster, we considered a number of different interfaces to be able to connect these systems to our desktop, laptops, and other devices. We were obviously already using SATA as a standard, and this is a representation of a 2.5-inch SATA drive, and we created two other types of interface technologies, one called mSATA and the other referred to as M.2. mSATA refers to mini SATA. We took the connections that were on our existing SATA drives and moved them into a form factor that was slightly smaller with our mini SATA. mSATA was a great stopgap between the traditional SATA drive connectivity and the eventual M.2 interface that we began to use. And we found quickly that instead of using mSATA, many manufacturers were including M.2 connectivity on their motherboards and mobile devices. mSATA did solve a number of problems, especially size on a system board and connectivity to a higher speed bus. The M.2 interface has become a very popular interface for most of our storage devices, especially SSDs. There's no additional cables that you need for data or power, and that M.2 drive plugs in directly to the M.2 interface on your system board. And since we are directly connecting to the bus of your system, we can take advantage of PCI Express speeds to increase the total throughput to the storage devices connected to an M.2 interface. Different M.2 interfaces will support different types of connectivity, and the way that we differentiate between these capabilities are with small keys that are associated with the drive connection itself. If you look at the end of the drive, there will be a small spacer at the bottom that is called either the B key, the M key, and some M.2 drives will support both a B and an M key.
Always Flexstone stays dry and fresh. See what foam can do for you.
Other M.2 interfaces may support the much faster NVMe interface, so it's important to know what type of interface is available on the system you're connecting to. Some M.2 interfaces will use these keys to designate what type of throughputs are available. So you might want to check with your system board or motherboard documentation to see if it supports an M key, a B key, or both. Here's a closer look at an M.2 drive that supports both the M key and it supports the B key. This means that this hardware can plug into any device that does have availability for either M-type connectivity or B-type connectivity. This also makes for a very fast installation or removal. You simply slide it into the interface slot and fasten it down to the system board. Flash drives are a very handy way to store information into a very small form factor. They consist of EEPROM memory, that's electrically erasable, programmable, read-only memory. This memory is non-volatile, so you can remove it from your system and the power source, and all of the information stored on that flash drive will continue to be available. EEPROM is a technology that allows a certain number of writes, but at a certain point, it will stop writing that information to the drive. You may still be able to read the information from that drive, but you won't be able to write anything new to that drive going forward. We don't really consider flash drives to be very good archival or backup media for a number of different reasons. Not only is the EEPROM limited as to the number of writes, but it is a very small storage device and it's very easy to lose these. This is one of the reasons we always recommend that if you're storing information on a flash drive, that you also have a backup stored in another location as well. USB flash drives you'll find being used almost everywhere, but there are other types of flash drives as well. One of the original and now relatively large types of flash storage is the compact flash, or CF. SD cards for secure digital are often used in mobile devices, and if you get into very small devices, you may find mini SD or micro SD being used. And if you have an older digital camera, you might find that it uses flash drives in the XD picture card format. We don't tend to see optical drives used very much in our production systems these days, but there is a lot of information that we've stored through the years onto this optical drive format. Optical drives are using small bumps that are written onto the drive itself with a laser beam. This is storage that is microscopic in size, and we're able to store a great deal of information on a single optical drive. Because of this method of writing information and reading information using a laser, these tend to be relatively slow when you compare them to a hard drive or to an SSD. But since optical drives take up very little room and store quite a bit of information, they were a very good choice for archiving data for later. You may find optical drives using the formats of CD-ROM, DVD-ROM, or Blu-ray. And there's often either a built-in optical drive reader or something that can be plugged in externally to be able to read these drives. If you have some older optical drive archives and you need to be able to read this, you might want to grab an external optical drive reader and plug it into your system using a USB connection.
You've got a big day, and you need to smell fresh. That's why the all-new Unstoppables gives your clothes a 24-hour non-stop freshness. So no matter how long the day goes, you can't stop this power, this love, this pose, this strut, this look, this talk. Unstoppables Fresh. Smell unstoppable. They say an apple a day keeps the doctor away. But flu vaccines can help too. From apples to immunizations, check it all off your list at Walmart. Get your flu shot where you already shop. Who knew? Walmart.
We rely on our hard drives, SSDs, and other devices to store large amounts of information, and often this information is very important. We don't want to lose the data that we're storing on these drives. But of course, these hard drives are physical devices that are constantly moving. The platters are spinning, the actuator arms are moving, and if any one of those components is to fail, everything on that drive will be inaccessible. Fortunately, there are ways that you could combine multiple drives together to create redundancy. So if you do lose a drive, you can be assured that all of your data will still remain available. And as we go through this video where we talk about drive redundancy, please keep in mind that this RAID configuration we're going to speak of is not a method of backup. If you do have an array that is using RAID to be able to provide this redundancy, please keep in mind that you also need to maintain a completely separate backup process. RAID is an acronym that stands for Redundant Array of Independent Disks. You might also see this referred to as a redundant array of inexpensive disks. There are many different ways to implement RAID, and we'll look at some of the more popular ones in this video. Some of these methods provide a way to keep your data redundant even if you lose a drive. But there are some RAID methods where redundancy is not available, so we do need to know the difference between one and the other. In this video, we'll step through RAID 0. You might also hear this referred to as striping. RAID 1, which is mirroring. RAID 5, which is striping with a single parity drive. We'll also look at RAID 6, which is striping with 2 parity drives. And we'll also look at nested RAID, which are 2 RAIDs combined together, specifically RAID 1 and RAID 0. Sometimes you'll see this written as RAID 10, and it refers to a stripe of mirrors. Let's start with RAID 0, which we refer to as striping. RAID 0 has at least 2 physical drives, and we'll take the information we're saving to these drives and split it across both of these storage devices. For example, if you have a single file, you can break that file up into 8 different parts, and you would store a part of that file onto each of these drives. For example, you might see one drive with block 1A, another drive with block 2A, back to the first drive with block 3A, and so on. RAID 0 is well known for its speed. Because you're writing a little bit of information to multiple drives, you're effectively able to do this faster than writing all of that information to a single drive. The problem, of course, is that if you do lose one of these physical drives, you now have lost access to your data because half of what was there normally is no longer available. For that reason, we often think of RAID 0 as having zero redundancy. RAID 1 is mirroring, and as the name implies, mirroring means that we're going to have copies of information across multiple drives. For RAID 1, we need at least 2 drives. We have those 2 here on the screen, and you can see that anything that we have on disk 0 also has an exact duplicate of that information on disk 1. This means that we need effectively twice as much storage space to be able to store exactly the same information. Having that mirror of duplicate information means that we are going to use a lot of storage space to be able to maintain that redundancy. But one good thing about mirroring is that if you do lose a physical drive, the other physical drive containing an exact duplicate of all of that data continues to be available. Obviously, we will want to replace that drive as soon as possible and recreate the mirror, but while we're in that process, all of our data continues to be available and we can continue to work normally. In our video on memory, we talked about how parity can be used to identify errors or to correct errors. We take that same idea and move it into RAID to be able to provide redundancy if we lose a physical drive. One of the ways we can do this with parity is using RAID 5 or striping with parity. The striping that we're doing in RAID 5 is identical to the striping that we were doing with RAID 0. Take a file, cut it into small pieces, and distribute those pieces across multiple physical drives. However, the last drive, we're not going to take a piece of the actual file, we're going to take the parity of the information that we just stored. This means in a RAID 5 array of 4 physical drives, 3 of those drives would have data, and the 4th drive will contain parity data. You'll also notice the parity is distributed across physical drives to make the recovery process more efficient. You also get efficiency in how much data you're storing and how you're storing it. Since you're just storing parity data on a separate drive, you're not having to duplicate all of the data on the system. That means that you'll have more drive space to be able to store your data instead of having to make copies of your data. If you do lose a physical drive with RAID 5, you can take the data that still exists, combine that with parity, and you're able to recreate the data that's no longer there. You're able to effectively, in real time, still maintain all of the data as if it was still physically located on that drive. This parity calculation does require a bit of CPU overhead, so there may be times when using RAID 5 in a recovery mode where there is a bit of a performance hit. RAID 6 is very similar to RAID 5, except we're adding another storage drive and adding an additional parity block. This means if we lose a single drive, we're effectively running the same way as RAID 5. If we lose 2 drives, then we can recreate the lost data using our existing parity data. This means with RAID 6, we can lose a total of 2 physical drives and still remain up and running, although it's a great mistake. This means that we can lose 2 physical drives in a RAID 6 array and still have access to all of our data. Of course, this does mean that we need a separate physical drive to store that additional parity data, and because we're adding additional parity data, we unfortunately are not adding additional capacity when we add that extra drive and create a RAID 6 array. RAID 10, or what we call RAID 1 plus 0, is combining RAID 0 with RAID 1. RAID 0 obviously is striping, just like we can see here. We have 3 physical drives. We've taken a single file, we've split that file up into 12 different blocks, and we put 1 block on each of these drives. Because this is RAID 0, we have 0 redundancy, so if we were to lose any of these drives, all of our data would no longer be accessible. With RAID 1 plus 0, we need to add that RAID 1 functionality, or mirroring. So we'll continue to keep our stripe, but we will mirror each striped set of drives. This means that we have separate individual drives that have a copy of the striped information. This requires at least 4 drives, but it also means that we could lose multiple drives and still be up and running. For example, in this scenario, we could lose one of the drives from the first mirror, one of the drives from the second mirror, and one of the drives from the third mirror, and we would still be up and running because we would still contain 3 separate drives from each individual stripe.
When you're watching the other football but don't want to ask your friends, what's offsides? And how can I sound like I know a lot about the game? You can just ask Google all of that at once. Oh, so that's it.
If you were to look around at the different computing platforms that we use, we have our larger desktop computers, but you might also have a much smaller computer, perhaps one that you would use in a small office or one that you would use next to your television. Both of these have the same type of components inside. There's CPU, memory, storage, network connections, and other components that are very similar between these two platforms. But obviously, these platforms are very different in their total footprint. The desktop computer is much larger, and the computer next to our media center or that we use at work is a much smaller system. Obviously, the motherboard in this much smaller system is not going to be the same form factor. So it is useful to make some differentiations between one type of motherboard and another. Physical size is certainly something to consider when you're looking at different motherboards. We also have to look at the overall layout of the components that are on the motherboard itself. Larger motherboards tend to have more flexibility and can have a larger number of components than a smaller motherboard. We also have to think about power. Fortunately, most motherboards have a standard power connection, but not all motherboards have exactly the same power connection. We have to think about airflow. All of these systems do get warm, and we need to make sure that whatever cooling system we use is able to keep up with the heat that's being generated by this motherboard. Fortunately, we don't have to memorize or know about every possible motherboard that was ever created. We look at Wikipedia, there are over 40 different motherboard types. Fortunately, for your A+ certification, you only need to focus on understanding 3 of those 40. If you were to look at the objectives, they state, Section 3.5 says, given a scenario, install and configure motherboards, central processing units, CPUs, and add-on cards. This is one where we need to focus on what the exam objectives themselves are expecting us to know. We need to know which motherboard we would choose for any particular scenario. So if you're putting a motherboard in a media center, you might need one type of motherboard, which is very different than a motherboard you might use on a desktop computer to perform video editing. For the purposes of the A+ exam, we need to understand the nuances between the ATX motherboard, the micro ATX motherboard, and the ITX motherboard. Here's a one-page summary of all 3 of those motherboard types. The standard ATX is one that is the largest on this particular screen, and we'll talk more about why that tends to be a much larger motherboard type. In the middle is the micro ATX, which is very similar in its layout to the standard ATX, albeit a bit smaller. And then on the smaller side is the mini ITX, which is the smallest of these 3. The ATX form factor stands for Advanced Technology Extended. It's a standard that's been around for a very long time, since 1995. There have been a number of changes to the ATX standard over the years, but the current version of ATX is very similar to the one that was released back then. The main power on the ATX motherboard has changed a bit over time. Early versions of the ATX standard had a 20-pin connector for the main system board power. More modern versions have a 24-pin connector. This is an ATX motherboard from Gigabyte. It's the GA-P67A UD3PB3. You can see that this motherboard is rather large. It has a number of expansion slots on it. This one has 4 separate memory slots for adding additional memory, and you can see the CPU is in the middle of the motherboard. Make a note of these relative sizes between the CPU, the memory slots, and the expansion card slots, because we'll want to compare them when looking at other motherboard types. The micro ATX is very similar in layout to the ATX motherboard, but it is slightly smaller than that ATX standard. This also has a lot of similarities to ATX. For example, the mounting points on this motherboard are at exactly the same points as the mounting points on a full-size ATX motherboard. This also has the same power connectors as the full-size ATX motherboard. And this is another popular form factor, primarily because it does follow the same standards as ATX, but it does fit into a much smaller form factor. This micro ATX motherboard is the MSI H81M P.33. You can see that this has a similar layout to the full-size ATX, but this does have a limited number of resources. For example, this micro ATX motherboard only has a single expansion slot, and it only has 2 memory slots available. Obviously, the ATX motherboard is much larger, and we're able to fit more components onto the larger motherboard. When we shrink these down into the micro ATX size, we have to make decisions about what components we're going to keep on this motherboard and what components are not going to make the cut. And if you're looking for a very small sized motherboard, you might want to consider an ITX motherboard. This ITX motherboard you see on the screen is a mini ITX, which is one of the smallest versions of the ITX format. You can see that the mini ITX motherboard is a relatively small board, but they did keep the same mounting screw points as a traditional ATX motherboard. That means we could take the case that was designed for an ATX motherboard and install a mini ITX motherboard inside of that case. This very small form factor makes a perfect size if you need to fit it into a very tight area. So if you need a streaming media device that's next to your television, or you just need a single computer that handles one single task, this might be the right motherboard for you.
Get another toothpaste that does not whiten. Girl, this one works.
Basic toothpaste stops at the top. Crest goes deeper to dissolve the bonds that hold stains to teeth. For whiter teeth in one day. Crest.
Brock's candy corn really gives me that fall feeling.
If you were to look at a motherboard, it almost seems like a small city that's seen from the air. There are a lot of different areas of the motherboard, and it seems like there is some type of connectivity between all of these different components. That connectivity is what we refer to as a computer bus. This bus is a pathway that connects the different components of your motherboard to each other. For example, there's a bus between your memory slots and your CPU. There's also a bus that connects all of your expansion slots. These different buses allow us to connect all of these very diverse components of the motherboard to each other so that they work as one single unit. These buses also allow us to increase the functionality of our motherboard. For example, the buses that connect all of the different expansion slots together allow us to put additional cards onto our motherboard, thereby increasing the functionality of that system. If you were to look closely at your motherboard, you can see the individual buses or pathways that are used to move information from one part of the motherboard to another. And if you're curious, you could trace one end of a bus connection all the way around the motherboard to where it connects on the other side. On older motherboards, you may find that one of the buses available is a PCI bus. This stands for Peripheral Component Interconnect. This is one that was created in 1994 and has 2 different sizes, a 32-bit bus and a 64-bit PCI bus. This older style bus sends data over a parallel communication. You may find that your newer motherboard no longer has a PCI bus and instead uses PCI Express, which has a serial form of communication. We mentioned that there are 2 sizes to the PCI bus. There's the 32-bit and the 64-bit. The 32-bit PCI bus is shown here, and you can see there are 32 separate connections between the different devices. This means when you want to send 32 bits, that 1 bit at a time is sent across this 32-bit bus all simultaneously. Hopefully all 32 of those bits will appear at the same time on the other side. A 64-bit bus is exactly the same form of communication, but instead of sending 32 bits across 32 separate lines, you send 64 bits over 64 separate lines in this PCI bus. This is an example of a 32-bit PCI bus and a 64-bit PCI bus. This is where you would plug in your expansion cards, and if you look closely at the motherboard, you can see all of these small traces that are connecting these different bus connections together. You'll notice on these slots that there are small tabs or keys that are in the middle of this connector. Those are to designate different power settings for the adapter cards that you're plugging in. For example, your expansion cards will have these small slots that are in the connector, and that's what's sliding into those adapter card slots on the motherboard. A 64-bit expansion card has additional connectors on the bottom, and it has a separate keyway that designates that this is a 64-bit expansion card. Installing an adapter card onto a motherboard simply requires that you push the card directly into that slot. So if you have a PCI slot, you would simply put the adapter card right on top of the slot so that all of those individual keyways are properly aligned, and then you would push the card down very carefully onto the motherboard. Be very careful not to give too much pressure, or you might end up breaking components on that motherboard. Once it's pushed in, you can see that it fits relatively snugly. This one should probably be pushed in just a little bit further so that you can no longer see any of those copper connections. But once it's in place, it's commonly screwed down onto the computer case so that it can't accidentally be removed from that slot. PCI Express, or PCIe, is a newer type of bus, and this is probably the bus type you'll find on the most recent computers. PCI Express communicates over a serial connection. This is very different than the parallel pathways we saw with PCI, because with PCI Express and a serial connection, we're simply sending one bit at a time over the same pathway. You'll often hear us refer to these PCI Express pathways as lanes of communication. So if you're looking at a motherboard and there is an interface labeled PCIe X1, it's referring to the number of lanes available for that particular interface. The X1 is pronounced by 1. X2 would be by 2, by 4, by 8, and so on. So when we're looking at that PCIe X1, this is really a PCI Express interface with a by 1 connection. Since the pathways that we use to communicate for PCI Express are serial, we don't have to have those wide 32-bit or 64-bit pathways. We can simply have one pathway going one direction and one pathway going the other direction. This would be referred to as a PCI Express by 1 lane, where you have a single lane going one way and a single lane going the other. That means if you wanted a PCI Express by 4 lanes, you would have 4 of those, and you would effectively be quadrupling the amount of throughput that you could have compared to a PCI by 1. Here's a motherboard that has both PCI interfaces and PCI Express on the same motherboard. You'll notice that they look very similar to each other, but if you look closer, you'll notice that the keyway for PCI is further back away from the edge of the motherboard, and for PCI Express, that keyway is closer to the edge of the motherboard. You'll also notice that the size of the slots may be different depending on the bus type. For example, this is the shortest PCI interface. This is a 32-bit interface, and this is the shortest PCI Express interface, which is the by 1 interface. This means if we only need the throughput provided by a PCI by 1 interface, we can use that smaller connection and save that room on our motherboard. The PCI Express interface cards look very similar to the PCI interface cards. But if you look closer, you'll notice you have that keyway that's closer to the edge of the motherboard. Many of these PCI Express adapter cards also have a small hook on the back of the interface cards that fit into a connector that's on the motherboard. This fastens the card down not only at the keyway that's connected to the chassis of the computer case, but it also connects it to the motherboard itself. When you're removing a PCI Express card from the motherboard, you want to be sure that you're not only removing the screw that's connecting it to the case of the computer, but you also unlatch that connector that's holding it in on the other side.
When you want to compare brewing methods to make a good cup of coffee at home, you just
just ask Google to compare them all for you. French press? Oui, oui, monsieur. Ooh, a little strong.
If you look closely at your motherboard, you'll see a number of different components for CPU and memory, but you'll also see a relatively large connector, and that's used for the main power for your motherboard. This is the connector that provides 3.3 volt, 5 volt, and 12 volt DC power to your motherboard and the components connected to your motherboard. If you're working with an older motherboard, this may be a 20-pin connector, but newer motherboards use 24 pins to provide the power that it needs. If you have a motherboard with 20 pins, but you have a connector with 24 pins, you can often simply use that same 24-pin connector, even though 4 pins may be missing from the connector that's on your motherboard. Some of the cables from your power supply may even be modular, so you can pull off 4 of those connectors and simply use the 20 that are left. Here's the 24-pin connector on the motherboard. You'll notice that the individual pins on the connector have different shapes. This keying ensures that you can only plug the main power connector in one single way to that connection. And if you're to look at the connector coming from the power supply, you will see that it has the same type of keying mechanism on the connector. To plug this into the motherboard, you simply line up those keys in the proper order and push the connector all the way into the motherboard. Normally, this connector will have a lip or locking mechanism so that when you connect this to the motherboard, it can only be removed if you unlock it with the latch. Normally, that connector to the motherboard provides all the power we need.
Little bit of extra seasoning that goes on top of it. All right, so here we go.
Requires additional power than what the motherboard.
All right, summarizing cloud concepts.
Very common if you're plugging in a graphics
If we're looking at
card
our exam objectives, this is what we're getting into. We're back in really pretty much domain 1. What we want to do is compare and contrast network appliances, applications, and functions. I say that all the time. And if y'all can compare and contrast different appliances, items, terms, that's the biggest thing about the exam, right? And I think a couple of you have pointed that out during our breakouts that we say, yeah, you know, you're right. So if you know one little bit of difference between one and the other, that's what's going to help you during all of these exams. Looking at connectivity options that you may have, we're going to get back into looking at transmission media and transceivers, transmit and receive, right? Some topologies, architectures, and then looking at what we can do for modern network environments. At the end of the lesson, this is what we'll be able to do. Explain data center and storage network architecture, summarize some cloud concepts, the use of software, coding. Oh, here we go with coding again. We did coding in what, 1202? Well, we didn't do coding. We talked about
Briefly talked about it, but didn't actually do it. Yeah.
And these different environments. Data centers. We saw the video of, was it CNBC? Right? We saw the documentary about data centers popping up around the United States, high real estate, right? Can anybody remember anything about the reason why these data centers need to go up? You remember anything about that video?
No, I can look it up.
Another connector type you would find.
I think there was a couple of things. I know we talked about a lot of the energy, usually the taxpayers in the community. They have to pick up the slack on some areas, right? Sheer mass of the data center being processed, with AI. They try to put them by rivers, things that can naturally create electricity, all those different things. So with that, with data center network design, here's some components. You have the virtualization piece. They want agile and scalable networks. Agile model, scalable networks. Easy to convert, easy to grow. You have to have overlay networks to secure, right, everything, and flexible server-to-server traffic. Let me explain overlay networks. That's like me walking inside of your home, and your router is already designed to do DHCP, give out addresses, things of that nature. You already have the basic network design. But if I want your network to communicate with other networks and or forward traffic and things like that, I would just simply come in, take what you have, and make sure that there's another way to do things that's on top of that.
That might be on your motherboard.
Like DHCP relay or bridging another network to assist your network for the transmission of data. Or put more IP security protocols on that, right? So I'm just adding. So that's the overlay networks that we'll see. And then we want to make sure we have high availability. Everybody who wants to get that information is going to be able to get it. Network, power, climate, all is environmental. And then you got to understand your traffic flow. North, south, east, west, as it comes in and out. Spine and leaf topology. You have two layered of the network topology optimized for data center traffic flow. And here's your structure. The spine, it's like a spine in what you got in your nervous system in your back. The spine comes in, that's the backbone. Has all your key distribution switches, all your things that need to help move that data and make it available in different areas. The spine switches interconnected networks, that's all they are, with leaf switches. So then you got your leaf layer includes the access switches. So let's look at it this way. The spine layer is north and south. Y'all got me? Then at certain layers of the spine, then you'll have the leaf where you branch it off. It's like looking at a 60-story building. Right? There you go, Kevo. You got it. At the main distribution frame at the bottom of the spine, brings everything up. That's the spine of the whole building. On each floor, they leaf off to give people access. All right, so that's what we're looking at.
Different motherboard that has an Intel socket.
You'll see this, the spinal leaf, they're judicial. Switches. Those are your rack mounted. Now you're getting to the actual servers in which everything's being stored at for accessibility. Now the cool thing about the switches is, what they don't show you is, a lot of people think that it's just a lot of hard drives in here. These rack mounted servers, tons of them. They are. Some of them are called blades. Have you ever seen a blade, a server blade? It seems kind of weird though, right? Sometimes the rack mounted switches, they look a little different. Let me see if I can bring up something for you.
You simply place the CPU on.
Are you talking about like circuit cards?
Close the cover and lock it down with a.
They look like cards. They're thin. They have SSDs on the inside, but it's a big blade.
It's like
you can hang it and then it swings and locks in.
The ones I'm used to is like when you pull them in, it's like the top and the bottom. You kind of like lock them in, but it's like it has a memory. Okay.
Exactly. Yeah. Server blades.
Physical CPUs that can be installed.
That's what they look like. You can put them in sideways or this way, right? But usually they put them in sideways because you can just drop a whole bunch of them and link them all together. So this is what you'll see, a blade system right there.
Server motherboards also generally support multiple expansion slots,
just like that.
So that you can customize the server for any particular use.
Micro blades and micro cloud blades. They're pretty cool. Remember, all of this stuff, they're all computers. Everything that we're looking at. See? Blades. They have 2 CPUs inside, 32-bit DIMM, 4 drives, redundancy. These ain't nothing but mini computers slid inside of a rack system. Okay. They're using fiber, bringing in and out, straight tip connector. So that's what it looks like. Let me drop this in the chat for you so you can kind of peruse it. You never know if your organization needs it or not. You need to work with it. There you go. Just so you know what that looks like. Then you have the benefits of the spine and leaf. This is what we got. You have predictable latency. Basically, you're gonna have single hop from any server to the backbone, and you want the less hops, the better, right? If we're using I'm thinking about how to answer this question so you understand it. You might see it on the exam.
Everybody says so. This is a
If I was gonna do ping, right, Elaine? If I was gonna do ping, let's say 8888. What part of that response tells me how many hops it took? I know, right? I told you.
Yeah.
Oh, you said that he's still listening. No problem, Mike. So what tells me in that response?
So it
on the right path. You're on the right path.
It would
so
be,
when it comes back to you, it says this part for the first part, then it tells you the second part. What's the last part say? 3 initials. 2 of them are the same. 2 letters. 2 letters are the same. And then there's one last one. You'll see it. Toward the end of the alphabet. There's 2 letters that are the same. I got everybody pinging now. Look at y'all. Y'all know my plot. Yep, time to live. Yep. The time to live. So when it's pinging, I'm trying to go out there and get information. 4 packets sent out, 4 packets brought back. Here's 32 bits. Usually if you do a ping and it comes back and you only get 3, one of those pings went to the routing table. Just letting you know.
Okay. Oh.
Okay. Just to build the route. But that's a good start. Now let's ante up what we already know. Okay, here we go. There's one routing protocol where it's limited to 15 hops. What type of routing protocol is that? 15 is it. It takes 15 hops.
You may notice that the information you're seeing on
Get to somewhere, it died.
15 is the maximum.
Ultimately loads. What you're seeing on the screen is the BIOS, the basic
asking you this. There you go, Rip.
of your computer.
That's the first one was Dylan. Rip is for IPv4.
Of your system, and some people refer to this as the system BIOS or ROM BIOS, which is referring to read-only memory.
It has the same beginning. Rip.
Don't generally use read-only memory to store the BIOS software. Instead, it's usually stored on your motherboard in flash memory.
6. RIP v6. RIP version 6.
RIP version 6.
Excuse me, RIP version 2. I'm sorry, I'm thinking about something else. RIP version 2 is for IPv6. Okay. So you have RIP version 2. RIP was built for IPv4. Of course, 6 is RIP version 2 is backwards compatible, but it was built more for classless. So when you IT experts want to build your own IP pools, yeah, it supports that. Okay. All right. So back to the spine and leaf, predictable latency, single hop from any server in the backbones, ensure consistency. It has load balancing, or you want load balancing and failover, because when you have multiple paths between the leaf, which goes back into the spine, you have to make sure you distribute the load. If any of your core switches or distribution switches become overwhelmed, right, you're not really doing what you need to do. Loop free, you want to make sure you have Spanish free protocol, fast FTP, BPDU guard, scalability, right? So you want to make sure you have room to scale, you have stuff to scale very quickly. That's why a lot of companies have a hybrid situation where if they have stuff that's on-prem, they want to control a lot of their data, but they don't want to invest in a lot of equipment. They'll connect it to a cloud concept, like infrastructure as a service, right? Yeah. And they'll scale that way. So now they have a hybrid, right? And then high-speed connectivity. You got that. It's not uncommon that you'll see storage area networks. Total network consolidated or dedicated to block level storage. When it goes to storage, everything's written in blocks. RAID's written in blocks, right?
BIOS.
the whole goal of this is you want to separate your storage of everything from a regular network. That network's gonna be locked down, like really locked down. You'll use RAID to do that. Tape libraries. They can call SAN fabric switches and directors that connect servers. Okay, so it's a fabric situation where, just like a web, that theoretical web exists in the IT spectrum, where different computers and or servers are connected, and they are all sharing information. So they've created their own sort of fabric, if you will.
The settings that you'll find within the
Man, I sounded smart when I said that. They've created their fabric, if you will. I should use that word more. Okay, here we go. Next, this is what it looks like.
You can see different devices that may be connected to your computer, especially
If you see fibre on the exam, it's fiber. Okay, that's the fancy way to say it. It's fibre.
Features, especially those related to virtualization.
Let's get to the benefits of a SAN. High availability.
And so much more.
You can scale
Some of
quickly.
these settings are critical to ensure that your system will
Minimal latency,
perform reliably.
and you get maximized
So these are
throughput.
not settings that you want to change or
And these are the
modify.
areas in which you can use it. Business continuity, cloud storage, and database management.
If you're planning to make any updates,
You're gonna start seeing this new word. Charles is the SpongeBob with the eye. I should get an eye class. Sometimes I sound super smart. And then Charles reminds me I'm not that smart. Listen. But look at this. Let me introduce you to a new word, because you're gonna start seeing it within a week.
Tell me how to fish. Feeling a little nostalgic right now, that's all.
That's why in the rare event of a network outage, you'll automatically get a bill.
During this
Artifact.
video, we're going to look at a number of different settings
Artifact.
inside of our system BIOS. If you'd like to look at your own BIOS,
It's an
you can launch
object.
it when the system starts up.
That object could be
Usually there
anything.
is a function key or special
So
key
if
for
I'm storing an
system
artifact
as your
in the
system is
cloud,
booting. And if your system
well, that's the
is
object. So what am I storing? A
it will
picture.
launch the BIOS
You're gonna start hearing this stuff. A lot of this stuff starts changing names, right?
Or it might be a combination of keystrokes.
But
I
it's the
think there's
same
somebody out there with
thing.
a money mill. They do this. So an artifact, the object turns into an artifact. Okay, just know that.
Yeah. Okay.
When you start storing artifacts in the cloud, all of your pictures and things like that,
Hyper-V for this, or you can use third-party hypervisors such as VMware
that's what they're
Workstation.
referring to.
If you're running Mac OS, you could run
With fiber and fiber
If you'd like
channels.
to download either of those, you can go directly to the VMware website, or you can use our link at
Discover that. Here's some components though that you need to know. Ooh, I got something in the chat. When they didn't come out with a new version of a book, they just changed a couple. Yeah, you're right. That's all they do. Change a couple of words, move something around, and then they got a brand new book, charge you $80 for it. Same thing here, certifications. So with the components for the fiber, you just need a server and a host bus adapter. Okay. The target paths, you can point it for storage and the different ports, and then for fiber switches, high data transfer. That's what you're getting out of all of this. We know fiber is better. You get better performance, better flexibility, speed, and quality of service. I mean, come on now. My important question, if you see it on the exam, is what is it immune to? What's fiber immune to?
This is because they use a feature known as fast
Fire? No.
This means that your system
Ooh,
only
two other things other than that, Leah. Yep.
when you turn it back on.
Less.
I think you're thinking about plenum.
Yeah.
For yeah.
For the fire. Yeah. It's less.
process, so there's no
EMI, yep.
press the keys
And
to
crosstalk.
the BIOS
Yep,
configuration.
you got it.
If you'd like to tell Windows to shut down completely so that you can then start this BIOS configuration, you can hold down.
All right, let's keep this train rolling
Restart.
with
or
scalability.
Settings, updated security.
As you
recovery,
grow, you
advanced
can,
storage,
like I said, you can invest more money on prem or have people then pay people large salaries to look after what you just purchased and having an upkeep, or you can just go to the cloud.
None of these options
All
are
right.
available to you.
The cool thing about it is you have horizontal scaling and vertical scaling. Meaning for horizontal, if you need those other computers, VMs, storage area networks, right? Servers, it goes this way.
Does need to make a BIOS change on a
Horizontal pieces are those things you need to build.
at least 3
Okay, we're looking at now routers, switches, load balancers, IDS, IPS, firewall. You understand what I'm saying? Those are things that are a part of the network that need to be there to help disperse the traffic. Those are core devices. The other things like VMs and stuff like that, I mean, they're not really needed for the network to run. They're just an appliance put on the network to use. So it gives you a lot of flexibility.
It's also a good idea to have an understanding of exactly
the elasticity in the cloud. There's something in the cloud where if me and Kevin got an ice cream business, we do great in the summer, the spring and summer. But then we start taking online orders. So now we can just like ship stuff like super fast. Well, we know in the winter time, we don't have that much business coming in. Right? So we gotta switch over to fruitcakes. Right? Fruitcakes to get work. But we still don't sell a lot. People are waiting for us to bring us something. So when the orders start coming in, we have what they call rapid elasticity. Kevin has permission to go in there and hit that button because he's the finance guy. And no matter what happens, if we blow up Q8 this way, and we need more, and then our sales decrease, the cloud environment will adjust automatically. I have to ask this question. What dictates us being able to do that? What dictates us not even paying attention? We'll allow it. Something must be coming in for us to be able to be accommodating to this idea of rapid elasticity anytime we need it in the cloud. What is it? I got your brains thinking. I always get y'all after lunch. Just so
Rapid elasticity.
Yep, it's synchronization. It is autonomous synchronization.
I'm using an emulated BIOS to demonstrate some of these capabilities. So if you see a number of unusual settings, such as an invalid serial number or a MAC address of all X's, you'll know why. Let's look at the configuration on this particular system. We'll go to the option in our menu called Startup. And in our
Still didn't catch that yet? Brian, I'm gonna do it to the drum. Can you see it? Okay. You see it in your
Dynamic.
when the system starts up. You can see there are a number of different drives inside of this virtual system. There's a number of SATA drives.
Yes, there you go. It's more expensive. When Kevin hit that button to say, James, we ain't worrying about this. We got enough money coming in. The dollar bills, y'all. Kevin's like, we can afford it. We did this last year, the year before that. Every time we do rapid elasticity, we might have to pay like $50K, but we're bringing in $500. You get what I'm saying?
Yeah.
So he's like, we're not even worried about it. We're not missing a customer. Right? So that's what we do. For the cloud development models, just as a reminder, you have public cloud, hosted private cloud, public cloud, hosted private cloud, or private cloud and hybrid. Here's where the confusion comes in. We know what public is. Everybody's using it. They give us free access for storage at Google and all that. Right? Yeah, we're not paying for nothing. We're using it. That's public. The private, exclusively used by one organization, but hosted by a third party. GoDaddy, 1&1, whatever. Here's the private cloud, owned and operated by the organization. That's what you need to know, because they'll throw that curveball at you, maybe with one question. And of course, hybrid, we know what that is. Hosted private cloud is more expensive. The private cloud is best for purposes requiring strict access and control, and that's why you need to know it, because they may ask you a question talking about what's better between those two. What's better security for a company? Hosted private cloud, or what has better security?
Private cloud. Yeah.
Correct.
PC.
Better security on that one. All right. If cost is not a factor, and we want to host. It's more expensive, but we don't care. Now, this says it's more secure, but look at the keyword down here, greater control, privacy, and security. Let's not get confused, people.
Yeah.
That's right. All right. As a reminder, infrastructure as a service, it's hardware. That's all I want you to think about. I know several of you have expressed to me, man, I can't remember each one. Infrastructure, hardware. That's all you need to think about. SaaS, software as a service, suites. Microsoft, QGAL, right? Salesforce. And platform, these are your developers.
So cloud
If
service model.
infrastructure as a service got together with software as a service and had a baby, it'd be platform as a service. It's both of those put together. The developer needs the infrastructure, the hardware, and they need a suite of software that will help them to create something. So therefore, it's platform. They got somewhere to put it. Advantages of cloud service models, scalability and flexibility. These are the key things you need to know for the exam. Scalability and flexibility, cost, speed and efficiency, and access. They will have this listed somewhere, those 4 items. Like what's the advantage of using the cloud? Yep.
Yeah, I think
So
I've
if I need to point that out, that's what you would see.
Yeah, I've gotten a couple of them like that.
Scalability and flexibility, cost effective, speed and efficiency, accessibility and collaboration.
And we need some way to get that heat out of your system and bring
Oh, now this is what we talked about like last week.
CDN?
Content delivery, CDNs. Who uses CDNs? Who remembers this? Hopefully I get this right because I didn't quiz y'all and win yet today, so hopefully I'll win on this one.
Yeah, content delivery.
I'm not doping you. I'm not doping y'all. I need to win this challenge.
Carbon solution for high
You're on the right
traffic
way,
website and apps.
Leah. Who uses content delivery networks? Meaning that you're correct. Everyone uses them, but what types of companies specifically make sure the content gets to you as quick as possible? If you darn it, Michael, I lost. Media streaming companies, but there are a lot of other companies that do it too. It's like everybody is providing some kind of content to you, right?
Yeah.
Facebook, social media, right? So you're right when she says everybody uses it at some level. But the ones that have super big server space, right? And they need to get that kind of content to you really fast without with the least interruption. We'll use UDP because we don't care if you get it or not, but we want the speed. We sacrifice the quality for the speed of getting it to you, right? So you can enjoy your stream. The benefits of this is these are distributed across multiple geographically dispersed data centers. Quick data access by placing the content closer to the consumer, so you don't have to go all the way to one place in the world to get it. And it lightens the load. It handles spikes pretty good. And believe it or not, in these bigger networks, you still have load balancers. If that network goes down, it's not really having good traffic going to it, a load balancer recognizes it and sends you somewhere else that's closer until they fix it. Okay. It's still on the backbone. CDN servers replicate content. Think of it being Napster. All these different nodes hold the same thing, right? Easily accessed by everybody, but it's just more efficient.
Find that the secure boot feature doesn't allow that operating system to run because it doesn't have a digital signature
for cloud networking.
In that case, you may need to disable secure.
We're bringing up virtual machines again. Virtual machines are cool. We talked about them this morning. fully fledged servers with emulated hardware, meaning it's in the cloud. It's infrastructure as a service, emulated hardware, right? It can run an OS and multiple apps.
Secure boot checks not only the operating system that you're running.
What's the difference between virtual machines and containers? A lot of people can't understand this concept. Who can't understand? Who remembers the difference? Let's go ahead, Mike. What you got? Oh, you don't understand it?
Oh.
Okay, check it out. All right. Well, thanks for saying you did. So VMs, if it's on your machine, it's a type 2.
For the manufacturer of your system, and it compares that.
You're correct. Yes. It's like pockets of data or OSs or applications. Correct. A VM, if I put it on one computer, like we did for Kali Linux, when we set it up, it asked us for one user. It shares the resources between the operating system. Okay. The other layer that comes up in the operating system is the binary and libraries, right? The translator. So it's basically allowing us, it's like VLAN tagging.
Yeah.
We're putting a VM on top of an OS. In order for the virtual machine to do what it needs to do, we need to kind of have an interpreter in the middle. That is the hypervisor. The hypervisor shares the binary library files, NEO, and allows it to go through back and forth. The virtual machine, for instance, does not have its own NIC card. It needs to rely on the computer that has a NIC card in it. So it walks through the binary and libraries, goes down to the OS, etc., and files and says, can we use your NIC card in order to connect? So they are in some way symbiotic relationship, NEO. Right? Now check this out. One person can only access the virtual machine at a time. One and one. Did I say one? But if I containerize, put several applications on a plane and allow a network connection, I simply can just put a icon there or something for you to access. Meaning, now I can monitor and have you access what you need to access by permission. Instead of being contained by one virtual machine, I can now put several applications in a row and manage you through what they call a permissions, like an Active Directory, to allow you to hop from Microsoft 365 to Kali Linux to Windows 10 VM to and such. So you can move freely because I've given you permissions to just hop from one to the other. You're not constrained in the matrix. Once you are done using that, then the resources are released back to the community of folks who needs it. So if Brian needs to download footage from his drone, from surveillance over my house, he can simply do that and allow you guys to see it. That's the difference between containers and VMs.
Yeah.
Containers have more spatial awareness. You can allow more people to access it at one time and segment those people just by permissions. That's it. VM, you're stuck with one user at a time using that machine. That's the easiest way to explain it.
Before the advent of flash,
that makes sense, Mike.
Most of these configurations were.
Now, I didn't follow the old trusted technical definition, but I'd rather explain it that way to make it easily digestible.
A battery that is on the motherboard. These days, those BIOS configurations.
There's your VMs. You can run multiple OSs on a single hardware platform. You can run them all next to each other, so to speak. But you gotta have you gotta make sure you have CPU, memory, all that stuff, NIC card capability to do that. So high resources. For virtual appliances pre-built, they sit up in the cloud. They're there to manage traffic and they're easily deployable. And then here we go with the containers. Shares the host system kernel, reducing overhead. Easy to scale, small footprint, designed to run a single application or service or performance inside that container, but you can let people opt to each container.
Yeah.
Elaine says containers are segmented into the network virtual machines. Like Cali runs a couple of operations, including its own kernel. So it's like us stacking.
And turn the computer on to reset the BIOS config.
So you got this whole image. Here's your whole VM image.
You can see it's just a couple of
and I'm gonna work smarter, not harder. I got a whole image that takes up a lot of resources and space. I'm gonna use smaller footprints of containers like these markers, stack up next to each other. Now I can fit more stuff. I don't have to have a 4 gig, get what I'm saying? A 4 gig image taking up everything. Now I can fit a lightweight 2 gig image, Microsoft 365, Salesforce, and then I'll just let all in that same space this took up. I got all of these. None of these know that each other exist. I just allow you to hop to each one you need.
Yeah.
Instead of just using this one clunky image and a whole bunch of other clunky images. You get what I'm saying? Yeah, so you're right. Mm-hmm. Good stuff. Good stuff. Let's get the stuff that you need to know about. So you have cloud gateways. Now you can have a cloud gateway the same way you have a on-prem gateway with a real router. Anything that exists down here exists up there. You have to make sure you patch it, manage it, administer it, hook it up the same way. You're still going to have an internet gateway, which is to that cloud instance. You're still going to have an IP address. You just point everything where you need to point. It's a configuration file. That's all it is. Find out what it is that's assigned to you from the ISP. And this is what you need to see right here. Let's get away from the slides. What else do we have? Transit gateway. You guys know about stuff. Y'all know about firewalls. Give me some new stuff y'all don't know. Okay. Okay, we'll get back to software-defined network because we didn't cover that. But let's back out of here real quick. If you want to go to Azure.
Started wearing makeup, stopped eating tuna. You staged the house. Don't blame me for checking out the Zillow.
Oh, hey.
You see what I see?
This is cool. I got my certain Azure. There's Azure right there. It's that color blue. Okay, Azure. So you got two ways you can use Azure. Azure is the cloud instance. Two ways you can do this. You can pay as you go, or you can get a free account, or you can do the Azure student account. But you need a My Computer Career email, and usually you don't have that. So they usually say get a free account. You can try Azure for free.
You have no idea how hard it is to be a single woman in her 30s, okay?
And you can test drive everything in the cloud.
Is it?
Let me go back to this page first.
I'm so sorry.
Okay. With the free account, you can use 20 of the most popular free services for 12 months. A whole year.
If you look closely at this image,
Free monthly amounts is granted to you. Full access to everything. And if you want to try out any paid services, you can use the $200 credit that they give you. Now, I like promoting free.
inside of the memory.
But I'm going to show this to you because AWS has the same thing. Google has the same thing. Microsoft has the same thing. They'll give you free access to the cloud services so you can see what they look like. Those services include
You can certainly use third-party software to be able to view these
Azure Container. You can spool up free virtual machines and connect them to your network.
BIOS configuration itself.
Data catalog, Azure SQL databases, AI intelligence. You can create your own AI models. I've used this for the whole year, and believe me, I did not get charged a dime because I stayed inside the free services. That's the key. Stay inside the free services. But it's for real, they don't charge you. Now, do they ask for a credit card or a bank card or a Cash App card? Sure. That's up to you if you want to do this, not just showing it to you. But you can spool up all of these servers to here. And with Microsoft Learn, if there's something you don't know about what you would like to use, they direct you to the free training and you take the class on how to spool it up and how to use it. You get a badge saying you finished it, and it goes into your Microsoft badge portal that you can put on your resume, saying that you know how to use these cloud services. What's up, Mike? No LinkedIn? You can put it on LinkedIn too. Yep, you can share your badge to LinkedIn. Yep, letting them know you've learned about Microsoft Azure services. And then depending on what you learn, they will say, hey, you took the free training, you learned how to do it, do you want the cert? Did I tell you about the... Alita's probably the only one that can still take advantage of this because she still has her cat card.
Me too.
If you have an
I still have my
active
cat card too.
duty common access card and you can still get to your active duty email, you set up a Microsoft Learn account. You add your government email as the first email and sign up. You get into your government email to verify that you've created an account. Step one. Then you go back into your account, you add an email, which will be your personal email. Okay? Hit update. Anytime you take a Microsoft Learn account, you have just been vetted by Microsoft, meaning you can get 50 to 75% off vouchers from Microsoft if you ever want to test. That's the deal the government made with active duty. Once you leave, they don't remove you. Your discount voucher will always be there. So depending on what you want to test for, it'll say, oh, Leah, you want to test for this? You say apply discount code. It'll say government. And it's either going to take off 50% or 75% off the face value of that voucher. Baby.
We have a lot of information
giving y'all the knowledge
from other people. And in some cases,
all right.
We want to be sure that the information
I've been adding badges from Sister. Yep. Just keep doing it too. And Credly. Now, Credly has it where you can turn some of those into college credits if you're ever ready to go to school, depending on how much you need. Credly is used by universities to turn that into college credits, whatever you learn for badging. So there is a method to the madness why you have to keep up with your badges. Okay. It may save you a class or two somewhere. Okay. So that's the key. Put the additional email in there, update, and now you're good to go. The additional email is good too, because if when you get out, Leah, now you can log in using that other email you added and make that your primary email.
This is very common to the doorknobs that we use.
But don't delete the government email. Leave it in there so you can get your discount codes.
Doesn't somehow allow you access through that door.
Always check Microsoft Learn too. Let's just walk through it.
That is unique that no one else
we got time.
And that's your key.
We're pretty much done with the lesson.
Although
okay.
we don't have a physical door key on our computer, we have digital keys that we use during this encryption and decryption process. And if we are encrypting
when you get in here,
we need to be sure that we have the correct key to be able to decrypt that information later.
No, when you use it,
now we have
there
a
we
problem
go.
Where
doink,
we have
doink.
Data that we've encrypted. We need to protect the key that we've encrypted it with.
Use my face.
Protect the key that you're using for all of these cryptographic functions. On your personal
Mobile
computer,
app.
one of the
Use
ways
password.
that we can help protect
I
this
don't remember
key
my
is by
password.
using
Give me
a
1 second.
Trusted Platform Module, or a
Oh,
TPM.
wrong.
This
That's not it.
TPM is a standardized piece of
I know it's
hardware
not it.
that is built for encryption. There are many different cryptographic functions built into this piece of hardware. And in this image, you can see that the TPM is a module that was installed onto the motherboard separately. Your motherboard may have the TPM built into the motherboard.
Oh, thank
itself.
goodness. I remember what it was. I got so many passwords so
So
much.
we can have random number
Nope,
generation
skip.
occur on this TPM. We can also generate cryptographic keys on this TPM.
Stay signed in?
This
Sure,
TPM
I'll stay
also
signed in.
includes persistent memory.
Okay, this is what we're looking at.
Burned-in keys that were created during the manufacture of the TPM. There's also part
All right.
of the TPM that handles
Here's some
so we can store keys
for those that are interested.
within the memory of the TPM.
These are all the certification and training tracks that you can take, career paths and free training. Okay, you can do Azure training, all of this good stuff.
Microsoft Ignite.
Let me take you to my profile.
That is secret to only your system, and it's unique to only your
I've got
system.
64
Nobody else has
badges.
the same key. For that reason, your encryption keys are
Wow.
now associated with your individual computer.
Okay, here's all
You can
mine.
use those keys to perform different functions.
Yeah.
For example, if you've been able
So they're all
to
sitting in
find
here
some other
under
type of
your
full disk
under
encryption
your
on
profile.
computer, you can use
Configuring
these
Azure
keys
Cloud,
to
everything.
provide the encryption
I got
necessary
my
to protect the
AI
data that you're storing
cert
on
and
that
my
device.
Azure Cloud
This also
through
means that
Microsoft.
you can't take the storage device out of your computer and then
And they
move
give
it
you
to another
trophies and good
computer to
stuff.
gain access
Here's
to
my
the data.
course plans, any
Still
challenges,
decrypt the data, and the decryption key is back on the original computer inside
credentials,
the TPM. Since this TPM contains this unique key, and it's tied to
certification. So here's my certs that I have through them. Now, applied skills. Here's, watch this.
We know that that TPM is
All show with a show of hands, who would like to get a free certification by a challenge exam doing it hands-on and pay no money?
Really is the device that we're
All right.
expecting. This TPM can also be used to
You want to look for Microsoft Learn Applied Skills. This is a legit cert. Because they know you need to immediately use this when you go to work.
And since the TPM is physically part
Here's
of
the
the
different
hardware
ones you can
of the
use,
system,
and you
it's
will,
not something
as
that
long as you do a
easily
challenge
copies
exam,
off
you will
of your
pass.
computer.
Like,
Looking
let's see
at
here.
that TPM that you
Here they are right down here.
at that
See the badges are different?
computer. The BIOS of your computer allows you
Okay.
to enable or disable different
I
features.
got a buddy doing this right now,
On
Active
this
Directory.
BIOS, you'll find it under security, and under security, if we scroll down, you'll see an option for TCG. This stands for Trusted
Validate your
Communication
skills and
Organization.
open doors to new possibilities for advancement. This is what you need to know to run an Active Directory.
And you're able to enable
Here's the learning path.
functionality.
Deploy and manage an Active Directory. Create the objects. Oop, what did I just say about objects? Artifacts.
Different parameters on how
Manage security in the Active Directory. And then once you get done, all you gotta do is complete the 2-hour assessment.
on a single device. But in many
Take the
of our
test.
centers, we might have hundreds or thousands.
Once you
of
take the
devices,
test,
and every single one of those
you will
devices
get
has some type of security
the cert.
associated with it. In these
It
types of
is
environments, we
a
need some
legit
type
free
of
cert.
large
So when you
scale
walk into
solution
off the
to
street,
manage
anywhere, you can say, nope, I know how to set
That
up an
solution
Active
is a
Directory.
hardware security
From
module
scratch.
called
Yeah.
HSM.
Yep.
Know how to add people and devices, permissions, all that stuff.
Of all of these keys across
So,
all of your systems. So if you wanted to have all of your web server keys
let me just
stored
drop
on
this.
one
This is what you need to
central
look for.
device, you would install an
Sign up
HSM
for it, take
and
it,
have that
boom.
device manage all of those keys. There are also
If you want to know more,
HSMs
they're all down here. The certs look like that. They have a star in the middle.
They could then be moved from one
If you want
computer
to challenge it and do
This is a
it.
type
So it's
of
hands-on.
HSM used for protecting cryptocurrency.
Using
Store
Copilot,
this information
Azure
and protect
Database,
on this
SQL,
global HSM.
Scene. This is the one you're going to need if you want to get, they call it Microsoft Sentinel. They teach you how to use Scene and you get a certification. If you plan on going into cybersecurity, get this one for free.
So for example, instead of your web server
If you have this on your resume when you graduate and you're trying to get in cybersecurity,
you can have that
there
entire
you go.
process take place in hardware on an HSM and offload that from any of your software-based services.
There you go. This is identity and access management, role-based access control. We've been talking about that. How to create it, the workspace, connect to services, how to detect threats, how to automate it.
Oh, when I'm taking the exams,
it is a whopping
the exams are every 2 to 3 weeks, depending on certification.
It's a 5-hour lesson.
So now there's
put in 5 hours, take the 2-hour exam, get a free skills. Now, have I done this yet? No, because I'm doing other certs.
I'm currently doing Net Plus, and that should be coming up in about
a cert to cert. I'm gonna go back and get this when I got time.
A week or
take
2
the
weeks.
2-hour assessment, and you are rocking. You have a full cert. Let me just share this with you.
But it's just a lot of learning.
There you go. In doing my CCC, I gotta wait. Yeah, do it when you do it, Charles. Do it when you want to do it, okay? All of this stuff that I'm giving y'all are just tools you can go back and look at. Some of y'all will take advantage of it now because you have your reason why. Some, you'll wait. Fit it in when you can get it in. You all have your own path, okay? I'm just giving you the tools.
For example, on this computer, the system type is a 64-bit operating system, and it is an ARM-based processor. And you may be wondering...
All right, 10 minutes of me talking, and then we'll be done. Y'all go to break. Okay, so with that, when you're setting up a network, too much to learn, you're right, it's a lot. You got to fit it in when you can. It's up to you.
A 32-bit and a 64-bit.
Kevin says, you know, as another form of studying too much. Yeah, another form of studying. So software
that is pretty good. So
these are networks that you can get into. So we talked about backbone, spine.
There's so many different outlets, like websites too, that
distribution switches
that I'm getting for the study material.
And I'm doing I did the ethical hacking.
It's just it's just so much studying, so much learning. So
70 hours. I did that.
Congrats to you on actually putting in the study time to get these certifications.
So software-defined networking. It simplifies network management by separating the control function and the forwarding functions.
Nice. CompTIA.
Now,
CompTIA gives you a lot of like
the control function is you logging in.
Study courses and like practice exams too.
Control plane management plane.
So mainly it's just you have to practice a lot because
you can do direct programming.
When it comes to the actual exams, they want you to do the exam in a particular way, like a CompTIA way.
If Brian was sitting on the beach in Tahiti,
but that's pretty good.
And he's on vacation.
The CompTIA, it's
he's got Wi-Fi.
The CompTIA is legit.
Look at the network through a management plane. The management plane is
awesome. That is even better. You're already in the field too. You're already in that career.
Troubleshooting the problem. Okay, but in order for
and with the given fact that you're already working in the field, that should give you a good edge on studying and working because you're actually doing the actual work.
Do you remember when East Charmer, when she pulled out the switch and she says, "I have to go to the server"?
For me, I'm a beginner, so it's taking a lot more study for me to actually get
the
it
image and image the switch. I remember that. Well, she probably have to go get another third-party software to download it in order for her to do.
Already being in the field, that is a huge plus.
So that's SDN.
That is a huge plus. I think once you start going through the study material, it should be a little bit easier for you.
Management. You can just simply take a look at it, log in, and find out what you need to do. So here's the use cases. For network virtualization, if you need to spool up any images, cloud computing, data center management, or if you have to manage Internet of Things. It's a plane that you just sign in on. It's an overlay network, virtual network built on top of an existing network. So the software-defined network, remember I said if you have it at home, I'm making sure it's more efficient. That's one of the things I could do. I could download this client's applications on your devices
This is why
Now I have a network on top of your network, meaning I can log in and manage it from a distance somewhere
and we're starting to
and
see
help
more
you
and more desktop
manage
and
that network.
laptop computers use ARM as the primary processor inside of their devices as well. We often refer to these processors from
You also can have a software-defined wide area network,
individual single
okay,
devices.
deploying
That single CPU
various other
package
things,
are
wireless
never
access
individual
points, and different other
processors
things that you
referred
need
to
to
as
do.
processor cores. You'll often see a processor referred to by the number of cores inside of that processor. It might be an 8-core or 16-core processor.
All right, you're going to see this on the exam too. Secure Access Service Edge. Secure Access Service Edge, cloud.
Specific to that core. This means multiple cores.
Anytime you hear sassy, don't get sassy with me.
Thereby increasing the overall efficiency of that computer processor.
Don't get sassy with me. Cloud. That's how you remember. That's how you remember cloud is associated with secure access service edge. You had a child named Cloud. You'd be like, don't get sassy with me, Cloud. Go back to your room. Okay? You are ensuring that only who needs to be in there can be in there. You're securing your cloud, your edge. Okay? You're ensuring that you have zero trust. You're using what they call a cloud access security broker. Basically, a cloud access security broker does this. Identity access management.
We have ways to extend the functionality of our computer by
to further drill down, as a company, you don't want to be responsible for that, for IAM. So basically, you're transferring the risk of identity and access management to a third party.
Do exactly what we needed to do.
You're basically saying, Jesus is saying, I ain't got time for that. I ain't got time to put people's names in here, social security numbers, PII. Anytime they log in, I got to make sure they can get on the network. No, I don't want to be the bouncer at the club. I'm going to pay somebody to be the bouncer at the club. You get what I'm saying? For them to get into the network. I'm transferring the risk to them. If something happens, I'll just sue them. Right? So that's what's happening. Transferring the risk.
Yeah.
The CASB now becomes the gatekeeper for the cloud, and they enforce policies and services. Yep, they are now the bouncer at Club Cloud.
These audio cards might also
y'all got that? The bouncer at Club Cloud. Y'all got that? Did y'all get? Okay. Moving on. In summary, that one didn't land. I'll work on my delivery. We talked about cloud strategies, differences between public, private, and hybrid, and the different platforms you see here. Infrastructure as a service, software as a service, platform as a service. DASS. DAAS.
Video editing or gaming.
What was that?
Want a discrete
what was DAAS?
This is a graphic
Y'all remember?
that is external to your
Direct.
What was DAAS?
This separate graphics card provides additional CPU power.
I think it was direct something.
Distribution as a service. Oh, desktop as a yes, you're desktop as a service. Yep. Okay, thanks for reminding me. Then we have cloud, private cloud data centers, what they're using it for virtualization. And Elaine says the VA is now doing this VIA ID. Yes, ID. Yep. You have to do that now. They're using, that's CASB. Perfect. I'm glad you brought that up. When you do ID me for government, that's CASB. That's a cloud access security program.
Yeah.
They're verifying your identity to get into the VA system. They transferred the risk to somebody else. Yep. Perfect scenario. Perfect example of what we have.
When you're dealing with video, there is a lot of.
Are there any
So
questions?
most of these capture cards will have very high throughputs, and they're usually connected directly
Cat,
to
remember
the PCI
Casby?
Express bus.
Remember your different
Here's an example
cloud.
of a
Yes,
capture card.
it
This
is a
one
lot.
supports video input
Mm-hmm.
through HDMI
Yeah.
and SDI.
Don't worry, we will
Video input, and it
go
connects
back and
directly to
revisit,
the PCI
especially Monday and
bus.
Tuesday. Well, y'all test Tuesday, so especially Monday.
Connect the networks wirelessly. There
We will
may be
revisit a lot of this stuff. We got the whole day to just bring up things and kind of sit on them for a quick second
Yeah.
and make sure we go back over.
Motherboard itself.
Did y'all get the, Charles, were you able to get the link?
If either of those happens to be the case, you may want
You
to
didn't
install
get it for real?
separate network interface card.
Is that with all your
You might
emails?
also want to install one of these NICs if you're installing a server.
Good reminder, Charles, the mastery class. Sign up for it because it's going over Network Plus. Even on your Google.
The process for installing a network interface card is exactly the same as any other adapter card. Once you find an open slot.
Okay, so for those, some of y'all have a mastery schedule, some of you do not. Yours will kick in, I think, October 1st. But if you want to contribute and still count as some type of mastery, you have to do something at least every 20-something days. Kevin, you didn't get it?
This multi-port card
Oh, you got it. Okay, great. So,
Every 21 days for the mastery.
yep, at least every 21 days. So you don't have to do it every weekend. You just have to at least get a video session in and get in there and do some work.
Yeah, there is assignments, so one weekly assignment. If you don't do those, you'll get a text or an email.
Yeah.
Yep. Some of y'all are waiting for the October 1st one to kick in for like video content. Okay. But until then, you attending the mastery on the weekend counts as a video.
Yeah.
Counts as a video assignment.
And of course, you could ask others
Okay.
who are using this
Yeah.
adapter what they've seen with this
All
hardware.
right.
Some hardware
Now,
requires you to
I'm gonna be
install
totally
the
transparent with you.
before you install the hardware.
Mastery is on your
And
own.
other adapter cards
My CC
require
has
you
nothing to do
install
with
the
that.
driver after you install the hardware.
If you choose to
Make sure you
continue
check the
it,
documentation for your adapter
go ahead.
card to see what the proper
The benefit
process
of it is
for
you get an
that
extra
hardware.
voucher out of it
In many cases, you'll find that the device driver
for
is
whatever you
installed
are. Okay?
automatically once
So
you install the hardware.
if you completed A plus, again,
With the documentation
you complete and
required
get the
for
certificate for mastery, completed the coursework, they give you a voucher, which is good for a year.
and make sure that you're using
If you do Sec Plus, complete it, they give you a Sec Plus voucher. You're already getting 3 in the class, but if you nail that one class in mastery, there's your 4th one, just in case you need it.
Sometimes this is done
You get what I'm saying?
Windows front end, and other times the
And it's just
manufacturer
kudos you
has
can put
their
on your
own
resume.
process for installing
But
the device driver. You can use Windows.
I would love for you to do it. It just reinforces the knowledge. But if you don't have room for it, you got to make that decision on what you want to
You'll be
do.
able to see the device driver details.
Does that make
and
sense?
the driver is working properly.
You'll never hear me ask, did you get your mastery stuff done?
Yeah.
So I'm going to leave it right there. I encourage it, but it's not for me to decide what you
If it feels like your phone.
All right, tell you what, let's go ahead and take a break. See you in 10 minutes.
All right.
Maybe it's time to change your phone.
All of the technology inside of our computers creates heat. One of the best ways to cool off the inside is to pull cool air through the system using fans. It's very common to pull cool air into one side of a case, have that cool air pass over the much warmer components inside, which of course heats up the air, and the hot air is expelled out the other side of the case. The layout of devices on the motherboard and the other components inside the case all contribute to how well the air can flow through this particular case. You want to be sure to make sure all of your wires and other components are out of the way and that you have a good airflow to pass from one side of the case to the other. There are many different types of cases, many different types of cooling systems, and all of these work together to provide you with an optimal form of cooling. If you look at the different adapter cards inside of your computer, you may find that the cards themselves have their own fans. This takes the cool air inside of your computer and directs it to a single point on this particular adapter card. It's very likely that the components of this particular kind of adapter card get very warm and need this additional cooling of an onboard fan. Of course, to support this onboard fan, we need enough room, so you may find these fans are only used on larger adapter cards. Very often you'll find these types of fans on high-end video cards or graphics cards. The fans that are installed onto the case of your computer come in very standard sizes. You'll often find 80mm, 120mm, or 200mm sized fans. These fans are often variable speed, so they'll run at slower speeds while your computer is cool, and then run faster and faster as your computer heats up. This means that as the fans go faster, the noise gets a bit louder, and you can't find different types of fans from different manufacturers that have different amounts of audio output. This is important, especially if you're in an environment like I am, where you want to be sure that everything is as quiet as possible. One of the best ways to avoid any fan noise is to avoid the fan completely. To be able to cool these systems, we use a fanless system, or what we call passive cooling. You'll often see passive cooling used in areas where you'd like the system to remain quiet. Things like a video server or a set-top box on top of your television are perfect places to have passive cooling. You often see this type of passive cooling used on purpose-built appliances and devices where the amount of heat can be easily managed. And this is very often used in conjunction with a heat sink to be able to take all of the heat from an individual component and spread that heat out over a much larger area. Heat sinks are critical for dissipating heat inside of your computer, and it's very possible you have many different types of heat sink in the system that you're using right now. These work by taking the heat that's on a component and spreading that heat across many individual fins, effectively increasing the surface area for cooling. As the air passes through these fins, it transfers the heat from the fins to the air and begins the cooling process all over again. If you're working inside of a computer that has a heat sink, be very careful about touching them. They get very hot, and it's very easy to burn yourself if the system has been running for any amount of time. You also want to make sure that you have the proper amount of thermal paste so that you have a good thermal connection between the very hot component and the heat sink itself. You might also hear thermal paste referred to as thermal grease or conductive grease. This is an adhesive you put on top of the hot component so that you can fasten the heatsink to the top. This also creates this thermal connection between the hot component and the heatsink. And since you're usually placing the heatsink directly on top of the component, it usually doesn't take much thermal paste to be able to make a good connection. Usually it's a pea-sized component, and that's all you'll need so that it flattens out and distributes itself evenly over the hot component. Another good form to create a thermal connection is to use a thermal pad. This is the pad that you see here that you would put right on top of the hot CPU or the hot component, and you would place a heatsink on top of the thermal pad. You would usually use a thermal pad when you were concerned about thermal paste perhaps leaking out and damaging other components. The thermal pad is not quite as effective as thermal paste, but it still makes a very good connection between the hot part of your computer and the heatsink. And like thermal paste, thermal pad is not reusable, so if you do remove it, you'll need to replace it with a new one when you put on the new heatsink. These are certainly less messy to install than thermal paste, and you would usually put the heatsink right on top of the thermal pad. And if this is a CPU, we might have a CPU on the bottom, we might have thermal paste or a thermal pad on top of the CPU. We would then put a heatsink on top of the thermal pad or thermal paste, and then on top of that, we might include a fan just to make sure we're getting plenty of cooling all the way down to the component. And if you need a larger fan, you might want to put it sideways so your CPU is still underneath. You would have a heatsink on top of that CPU, and then a much larger fan that blows air through that entire heatsink. Well, if your fans are making too much noise or they're not providing enough cooling, you might want to consider liquid cooling. This is the same type of cooling you might find in an automobile or in mainframe computers. Usually you would have liquid cooling on high-end systems, but we're finding that liquid cooling is perfect for things like a gaming computer you might have at home. You might also see this liquid cooling used when someone is overclocking their system to try to get as much performance out of their processor as possible. This liquid cooling system usually consists of the heat sink that sits on top of the processor. There are pipes that take the coolant over to a set of radiators that often have fans blowing through them. Once you place that transfer unit for the heat on top of your CPU, you can then have all of the liquid transfer between the CPU itself over to the radiator, have the air blow through to cool off the coolant, and then return the coolant back to the CPU.
If you're an IT or security professional, you've likely heard about secure enterprise browsers. And surprise, you may already have one at your fingertips. If you're an IT or security professional, you've likely heard about secure enterprise browsers. And surprise, you may already...
Before we get into this presentation on power, I want to give you a very strong warning to always disconnect from any power source if you're ever going to work on the inside of any computer. Not only is there a concern about electrocution from that direct power source, but there may be components within your computer that are storing power in capacitors. You have to be sure that you know exactly what you're touching inside of that computer, and you have to be knowledgeable enough to know how to discharge those capacitors before you work with that equipment. Another common mistake that I see people make is connecting themselves to the electrical system of the building. You never want to connect yourself or anyone to any part of a building's electrical system, even if it's the ground wire. The ground wire of a building could be energized at any time, so you want to be sure that you do not connect yourself to any part of that system. Our goal when working with this type of equipment that uses electricity is to always have a healthy respect for
Be right back. Have to make sure my patio furniture doesn't fly away. The winds are kicking up to 40 miles an hour, so I'll be right back. About to ring.
If you look inside of a desktop computer, you'll find a relatively large power supply. This power supply is providing your computer with DC power or direct current. That's because your motherboard and all of the components on your motherboard need DC power to operate. But the type of power that we get from our wall outlet is AC power or alternating current. That's why we need to convert from AC to the DC that your motherboard will use, and this power supply is the device that provides that conversion. These power supplies are designed to convert 120 volts of AC or 240 volts of AC to DC power, specifically separate DC voltages of 3.3 volts, 5 volts, and 12 volts. This is probably one of the most important components in your system because everything inside your computer relies on the power that's being provided by this power supply. You'll see many different terms associated with power inside of a computer. One of those terms is an ampere. You may see this abbreviated as an amp or abbreviated as a capital A. This describes the number of electrons that are moving past a single point in 1 second. Often we'll compare electricity flowing through a wire to water that is flowing through a hose. You can think of amps as that total amount of water flowing through the hose. So if you can increase the size of the diameter of that hose, you can increase the number of amps. Another term you'll see used is voltage. It's often abbreviated as volt or the capital letter V. You can think of this as the pressure of electricity on a particular wire, and in the case of a hose, it would be the pressure of water that's flowing through that hose. If you want to increase the amount of voltage, then you need to increase that pressure, very similar to increasing the amount of water that might pass through a hose. If you know the voltage and you know the number of amps, you can calculate the wattage. This is often described as a watt or a capital W. And we think of this as a measurement of real power use. This is a relatively easy calculation. We take the number of volts, we multiply that by the number of amps, and the resulting value is the total number of watts. So if you're working inside the United States,
if I lose you, possibly, it's lightning coming around everywhere, winds are up to 45 miles an hour, it's dark as heck, and it looks like the clouds are going to unleash. But if we do, just log back in. We might go into a waiting room or something, but
It is referring to current
I'll be back if it happens.
direction. You often see this shown as a wave or a curvy line to designate alternating current. So alternating current is what we use to get power from our power plants to the outlets that are in our homes and in our businesses. We often describe this alternating current as the number of volts and how much this is alternating in a single second, and that is referenced in hertz. In the United States and Canada, we have 110 to 120 volts of alternating current. You'll sometimes see this abbreviated as VAC for volts of AC, and that is running at a 60 hertz rate.
Thinking about going solar, but not sure whether it's worth it for your home? Well, before you get quotes, there are 3 things you need to know about going solar and one easy way to find them out. Number 1, you need to know how much solar you'll need to eliminate your electricity bill completely. 2, you need to know how much solar you can actually fit on your roof. And 3, you need to know what the ideal solar system will cost after federal, state, and utility incentives. In the past, to find out all
Jesus, sir, can you please, Kevin, switch hats? I like it. Can you log in for me, sir, for lunch?
Our unique
Sorry,
solar
what happened?
Can you clock into class?
Oh, yeah, sorry, I forgot.
for your home.
No problem.
It will tell you how much electricity your roof can generate, how many solar panels you can actually fit on your roof, how much you can reduce your monthly electricity bill with solar.
Alrighty, sir, just clock in.
On your utility pricing plan. And the magic number every homeowner wants to know: how long will it take for the system to pay for itself? No other solar calculator does all this. Now, if the payback on solar is better than other low-risk options like paying off your mortgage, then solar makes a lot of sense. The typical payback time for solar is under 10 years, making it a no-brainer given the historically low interest rates we have at the moment. So to find out if solar is worth it, test your home with America's most accurate solar calculator by clicking on the link below. Now, you may already know that solar is worth it, and just want to find out how much solar will cost after all the incentives. Well, the reason our estimates are so accurate is because we use the actual cost of installation from thousands of similar solar systems near you to hone our estimates. Using this data, we found the best solar deals being offered from reputable installers we vetted using over 28,000 verified reviews from actual customers. To get access to these deals, simply select how many installers you would like firm quotes from after the calculator finishes analyzing your home. If you're not ready to get quoted just yet, you can still get a detailed solar analysis, including cost estimates for your home to keep for you when you're ready. Stop paying full price for electricity and start taking advantage of the generous incentives available for solar by clicking on this video or the link below and getting a free, no obligation solar analysis for your home.
So I told the girl, I said, well, do me a favor, put the money in the bag. Excuse me.
Hertz is often abbreviated with an HZ. If you're in Europe, you're probably running 220 to 240 volts of alternating current, and it runs at a rate of 50 hertz. Our alternating current is the input to our power supply, and of course our power supply is outputting direct current, or DC. You'll often see DC shown with the graphic of a single line and multiple lines underneath. Direct current, as the name implies, is power that is moving in a single direction with a constant voltage. So the power source that we're connecting our computers to will be different depending on where you are in the world. As we mentioned, in the US and Canada, we'll see 120 volts of AC running at 60 hertz, and Europe is 230 volts at 50 hertz. That means that if we are moving a computer from one place to the other, we need to be sure that we are connecting a power supply that can use the type of input that is used in that country. If you were to look at the back of a relatively old power supply, you might even see a manual switch in the back where you tell the power supply what you're connecting to. and that switch is usually marked with 120 volts and 230 volts. If you're not sure what type of power is coming out of the outlet that you're connecting to, you might want to grab a multimeter and test that outlet to see what type of alternating current is on the other side. If you look at the back of your computer, you might notice that it doesn't have a switch to manually move between 120 volts and 230 volts. That's because most modern power supplies will recognize the type of power they're connecting to and will adjust accordingly to work properly regardless of where you happen to be in the world. If you do have one of these manual power supplies, you want to be very careful of how you're configuring that switch on the back. You don't want to take a power supply that is currently set for 120 volts and plug it into a 230 volt power source. If you plug in a power supply with those settings, then you'll probably quickly find the power supply will be overloaded and it will most likely be a spectacular failure. Here's a better view of this manual switch on the back of one of these older power supplies. If you are planning to connect this device for the first time, you may want to reference that setting to see what it's configured for on that power supply and make any change that you need before connecting it to the power source. Once the system is configured to the proper voltage and it's connected to the power source, you can leave that switch exactly where it is. So now that we've talked about the input to the power supply, let's talk a little bit about the output from the power supply. That is going to provide us with a number of different voltages in DC or direct current. You often see these DC values referenced as a positive value and a negative value. In reality, it's referring to the difference in potential based on where you happen to be. You can think of this as measuring the heights of your home from your front door. If you wanted to measure the second floor of your house, it would be approximately positive 10 feet above you. And if you were measuring the basement, it would be negative 10 feet. Both of those are 10 feet away, but obviously the distance is relative to where you happen to be standing. If you look at your power supply documentation, you'll see there are a number of different outputs that are available from the back of that power supply. One of those is probably a positive 12 volt. This is for PCI Express adapters, hard drives that you might install into a system, or anything else that needs that much voltage to be able to operate. You may find some motherboards that use plus 5 volts for components that are on the motherboard itself. Although many of our newer motherboards tend to use plus 3.3 volts. That 3.3 volt power is primarily used for the motherboard to power up the M.2 slots, the RAM that's on your system, and the other assorted components on the motherboard. And you might also find that your power supply provides plus 5 volts of SV power. This is the power provided to the motherboard when it's in a standby or sleeping state so that we can wake it up using signals across the network or by pushing a button on the front of the case. You may find some motherboards using negative 12 volt of DC power. This is often used for integrated local area network connections on the motherboard, and there may be some older PCI cards that use the negative 12 volts. And for older power supplies that are providing power for legacy motherboards, you might see them providing a negative 5 volts. This is for an older style of adapter card that's no longer used, and you may find that your power supply doesn't even provide an output for negative 5 volts. If you're not sure the type of output and how many amps are supported for each of these voltages, all of this is documented in your power supplies manual. You might also see those values right on the side of your power supply for easy reference. To get power to our motherboard, we have a main power connection that is a 24-pin connector on the motherboard itself, and it provides the motherboard with 3.3 volts, 5 volts, and 12 volts of DC power. This was originally a 20-pin connector, but most modern motherboards are using the full-size 24-pin connector to connect the power supply to the motherboard.
Check this out. I'm going to show you how I afforded this card. Okay, you ready? All right, $118.
If you do run into one of these older motherboards that only has a 20-pin connector on the motherboard, you can still use the 24-pin power connector from the power supply and simply not use those last 4 pins that are on the connector. Here's the 24-pin connector you'll find on a motherboard, and it is probably one of the larger connectors that you'll find on the motherboard itself. To be able to connect the power from the power supply, we simply take the 24-pin connector that is coming from the power supply and place it into those slots on the motherboard. This can only fit into this connector one way because this entire connection is keyed, which prevents us from plugging it in with the wrong orientation. If you're working with servers and other infrastructure devices, you may find that there are multiple power supplies on the back of the unit. These are designed to be redundant. Each power supply is designed to support the full 100% power required by the system, so if you lose one of those power supplies, the other power supply can continue to keep that system up and running. Very commonly, these two power supplies will run at 50% of the load, and if you lose one of those power supplies or it comes disconnected from the power source, the other power supply will take 100% of that load. These are also designed to be hot swappable. You can see there's a switch on top of this motherboard that allows you to slide it out of the chassis even when the system is up and running. This means that you can maintain 100% uptime, but be able to replace any of these power supplies if you run into a problem. Many less expensive power supplies will have fixed connections coming out of the power supply itself. This means we'll have a large grouping of cables that will be sitting inside of our computer case, whether we're plugging a device into those connections or not. Higher-end power supplies tend to be more modular, where you can simply connect only the cables that you need to use inside of that particular system. And if you need to add more later, you can simply plug them into that modular connection. And if you need to remove a device from your computer, you can remove those cables from the inside of your case. Here's a hybrid power supply that has some fixed connectors, but it also has modular connectors that you can plug in if you need them. Here's a power supply that is completely modular. You can see that they provide all of the cables that you would need to connect, and you can simply plug in the cables that you need to provide power for your specific requirements. If you're purchasing a power supply, you'll notice there are different models that will support a different number of watts. Generally, if you're getting a power supply that supports a higher wattage, that power supply tends to be more expensive. You can certainly spend the extra money to buy a power supply that gives you much more capacity than you'll ever need, but that doesn't provide you with any additional speed benefit for your computer. Even though different power supplies may support different wattages, the physical size of the power supply doesn't tend to change. So if you're upgrading a power supply inside of a computer case, you might upgrade to a higher wattage, but the size of the power supply itself will be exactly the same inside of that case. If you're trying to decide just how many watts you need in a power supply, then you'll need to calculate all of the different components inside of your computer and add up what the maximum number of watts might be required for all of those systems to work together. So you'll want to check your documentation to see what the CPU requires for wattage, what your storage devices will need, what your video adapter requires, and then any other components inside of that system. If you have a separate video card inside of your computer, these usually require a significant amount of power. And you'll want to check the documentation for that video card to see what the requirements are for power inside of that computer. A good rule of thumb is to get a power supply that can support 50% of your total load today. That means that the power supply will not be overloaded and you'll have plenty of room for growth in the future. Another useful specification when you're looking to purchase a power supply is the energy efficiency. When we're converting from alternating current to direct current, we lose a bit of power each time we make that conversion. That lost power is converted to heat, which of course creates more of a cooling issue for the computer that you're using. If you're concerned about this efficiency rating, you may want to check the different values associated with those power supplies. The standards tend to be somewhere between 80 to 96% efficiency, depending on the quality of the power supply that you're purchasing. If you get a power supply that's more efficient, then you'll have less power that is lost during that conversion process. And because you're losing less power, you have a lot less heat in your system, and overall, you're saving money not only in powering the computer, but keeping that computer cool. There's a certification program that power supplies can go through to determine their efficiency. You'll see power supplies rated as an 80 plus, an 80 plus bronze, silver, gold, platinum, or titanium. This means that the 80 plus with no rating would be the least efficient, and an 80 plus titanium would be the most efficient.
We're looking for adults 45 and under to be in our HPV vaccination ad. Sound like you?
Not me.
in a relationship.
Just actually acting.
Many organizations use peripherals that are able to accomplish many things in one single unit. We refer to these as multifunction devices, or MFDs. These might be a printer, a scanner, and a fax all in one device. And these might connect to a wired network, a wireless network. They might have a phone line connection for the fax capabilities, or you may be able to send and print jobs from your mobile device across the web. With the fax system, so many different things, there are also so many opportunities for things to your boss. A multifunction device at home might be a relatively small unit about the size of a double-T printer, but in an office environment, these might be relatively large, so you might have to find a separate area for setting those up that is outside of the office. These multifunction devices need a power connection, they often need a wired network connection, and you need to install them in a place that is accessible by everyone in the organization. We not only need to physically install this multifunction device, we also need to configure our workstation so that it can properly print to these devices. To accomplish
So IPv6 uses all Fs for broadcast. For IPv4, they use all 255, 255, 255, 255.
For a standalone printer, we need to find exactly the right printer driver for the operating system.
I was confused because ChatGPT keeps telling me that IPv6 doesn't use broadcast.
Well, that is the broadcast. Oh, if you're looking at this, that's a broadcast MAC address. FFFFFFFFF. So it is correct. It's not IPv6. It is for MAC addresses though. Switch layer 2 data link. Yep. So that'd be a 48-bit MAC address. So yep, ChatGPT would be correct. But the broadcast address for IPv4 is 255.255.255.255.
A page description language known as PostScript. This was originally created by Adobe Systems, and it's a very common language to find across many different types of printers. If we were to look at the communication that was occurring between your workstation and the printer, you would have output that's very similar to this. This is the PostScript language that is received by the printer. The printer is able to read this document and then render a printed page based on the information inside of this PostScript file. The printer is able to interpret that language, it renders the page, and then prints it, and the final output.
Sorry about that. Sometimes I have so many different things running around in my head. I too get them mixed up. So I apologize about that.
If you have a printer that talks PostScript, then you'll need to make sure you have a PostScript printer driver. There are some printers where you can select the printer to use either PCL or PostScript, so you want to be sure to use the appropriate driver for the configuration of your printer. These multifunction devices have many different capabilities, and of course, there's no operating system that we normally would have access to on these devices. When you start this system, it loads the operating system for this device that we refer to as firmware. This firmware controls what this device does when you send in printer output, when you have it scan information, or when you're sending a fax. There are many times the manufacturer of these multifunction devices will fix a bug, or they may release new features. To do this, they'll provide a new version of firmware for this device, and you'll need to install that firmware to either upgrade and fix those bugs, or to provide those additional features.
Just dropped it in the chat to reconfirm about the MAC address or broadcast address.
Process is used to properly install the firmware. Make sure you reference this documentation because every multifunction device has a different process for upgrading the firmware. If you're directly connecting to one of these multifunction devices, there are a number of interfaces that you might find.
Save money with Snapshot Protein. Instant savings on commercial auto insurance and vehicle management tool.
One is a USB connection. This is a very common connection that we're all very familiar with, but there are certainly more than one type of USB connection. For example,
Now, technically, there is no broadcast address for IPv6. However, the replacement for the word broadcast in IPv6 you'll see it start with FF02, FF, as the energy cast or multicast address. It starts with FF. Does that make sense? So yeah, they can't say broadcast for IPv6, but the equivalent is the FF02.
Device that does have an RJ45 network connection. You can see it's live on the network right now. This one also has a USB Type B connection on the back of the printer as well. Your printer might also connect to devices over a wireless link. Some printers will support a Bluetooth connection. Bluetooth, of course, has a limited
Great
range.
questions,
So to
great
place
questions.
Bluetooth as your connection, you'll need to be in close proximity to the multifunction device. A more common wireless connection is probably the 802.11, specifically the infrastructure mode of 802.11. This means that the multifunction device will connect to an access point, giving everyone on the network the ability to communicate to that device. Some multifunction devices support 802.11 wireless connectivity in an ad hoc mode. This is a point-to-point connection between two devices where an access point is not going to be used. If you have a single computer that needs to communicate to a multifunction device in an area where an access point is not located, the problem is that ad hoc mode. In many organizations, there will be single people with access to the device. And one of the ways that you can do this you normally use this as the operating system running on that computer. There's usually a sharing tab inside the name of that printer that will be used on the network. One of the challenges using this method of printer sharing is if the computer connected to the printer is turned off, no one is able to print to that printer. Instead, most organizations will use a print server. This is a separate service that's usually running inside the printer itself. Although there are also external print servers you can purchase. These print servers allow you to send print jobs directly to the print server, and the print server then manages the printing process to the multifunction device.
Welcome to Trend Torch Network, where innovation meets inspiration and trends are more than just fleeting moments. They're the fuel that propels us into the future. Unleash the power of possibilities as we navigate the digital cosmos, igniting trends and lighting the way for content creators, visionaries, and trendsetters. Join us on this visual odyssey as we decode, disrupt, and define the very essence of video trends. Interactive exploration. Immerse yourself in interactive journeys, where trends aren't just observed, but experienced. Join the conversation and shape the narrative with our community of forward thinkers. Why ride the torch with us? At Trend Torch Network, we don't just ride trends, we set them ablaze. Join our community of fearless innovators and trend architects who don't follow paths, they carve them. Subscribe, hit the notification bell, and become a torchbearer in the digital revolution.
Where the longer side of the page is on the left and right side of the output. As the page is going through the multifunction device, the page itself is not turning. The printer is simply printing in the orientation that you selected. You may find on some of these larger multifunction devices that there are multiple paper trays on that device. And when you're printing your output, you can choose which paper tray will be used as this final output. This may have a plain paper in the top tray, you might have letterhead in another tray, and you might have different sizes of paper in different trays. During the printing process, you have the option to choose which tray you'd like to use. This particular printer uses the letter tray as the one that is automatically selected, and that letter tray is tray number 1. You can also print to number 10 envelopes in tray number 2. You can print on legal size paper on tray number 3. You can print on 9 by 12 inch envelopes on tray number 4. So if you find that your output is being printed from the wrong tray, you might want to check your settings when you're sending that print job to the printer. During the printing process, you'll have the option to select the one that is automatic, or you can manually choose exactly which tray you'd like to use for that particular print job. You also have the option to choose what type of quality you would like for the final output. This usually gives you an option to decide what level of resolution you would like to use during the output, whether you'd like to use color or grayscale in that output. And if you are using color, you might have the option to use a color saving mode so that you're not using as much ink as you would with a non-color saving mode. On this printer, the resolution is defined as the print quality. You can see by default it's set to 600 by 600, but if you'd like to save some toner in this particular laser printer, you can set that to a lower resolution. This one also supports color printing. The default is a true color, but you can also modify that to be a different quality of color output, which might save you some of the resources in this multifunction device. If you do have a printer that is a unique style of printer, or it's one that prints very expensive types of output, you may want to limit who has access to print on that multifunction device. You can normally provide this through user authentication. This might be built into the printer sharing that you already set up, or maybe part of the print server that you're using. You would set rights and permissions for individual users or groups of users, and you can define who's allowed to print on the printer and who's allowed to manage that printer. One of the challenges that you have when you have a central printing device is that it's usually in the open where anyone can access that device. But if you're printing sensitive information, you may not want that information simply sitting on top of the printer. For that reason, you may want to enable badging. With badging, you would send your print job to the printer, but the printer is not going to print that particular job. Instead, the printer will wait for you to physically visit the printer and use your badge to authenticate yourself with the printing device. Then it will start to print the output while you're standing in front of the printer, ensuring security of that output. Printing anything in a physical format costs money, and some of these printers can output high resolution in full color, which costs even more money. For that reason, many organizations will want to audit who is printing to the printer and how much they're printing. Many printers include an audit log in the printer itself or in the operating system that's used to share the printer. You can usually find this in the security monitoring of the printer, or if you're using Windows, you can find that information in the event viewer. And some multifunction devices allow you to configure secured prints. This allows you to define a passcode for that printer. You send the print job to the printer, and then you have to visit the printer to manually input that passcode before the printer will start the printing process. This is another way of ensuring the protection of the information that you're printing without requiring any external cards or separate pieces of equipment. You simply visit the printer, type in your PIN, and it prints the output.
Hello. Do you want to play with me? Sure. You want me to help you with your groceries? This journey with childhood cancer comes at you in waves. Every day we wake up knowing that our 2-year-old has cancer. It's tough to get through.
The tumor is about the...
You would normally configure this on the printer. This printer supports Windows PIN protected printing, and inside of your Windows operating system, you would specify what personal identification number or PIN you would like to use. You would then visit the printer, you would input your personal identification number, and your output would begin to print. Not only can these multifunction devices be output devices, we can also use them as input devices. Many of these multifunction devices are flatbed scanners. This means that we can take a printed physical document, put it on top of the multifunction device. It will scan this device and create a digital format of that physical page. Some of these might include an ADF or an automatic document feeder, so you can put many pages into the multifunction device, hit one button to scan, and it will go through many pages and scan all of those to a digital file. Our modern multifunction devices can scan information and email you the results of that individual scan. For small scanning jobs, it might make sense to send that to your email. But for larger scanning jobs, your email inbox may not be the best place to send these very large attachments. Instead, you might want to scan directly to a shared drive on your network. We refer to this as scanning to a folder or scanning to SMB. That stands for Server Message Block, which is the standard format used on Microsoft Windows devices. This is effectively sending anything that's scanned to an existing Microsoft share, and then you can simply visit that shared drive on your computer to access your digitized files. And in today's world of cloud computing and high-speed networking, we can also scan to an external device that's located in the cloud. So we might want to specify a Google Drive account or a Dropbox account, put our paper into the scanner, hit a button, and everything will be sent to our drive in the cloud.
Jellyfish Lighting is an all-in-one permanent exterior lighting system. Through an app on your phone, you are able to decorate for all holidays like Christmas.
A laser printer is an amazing piece of technology. Take some high voltage, combine it with some charged ions, and melt some powdered toner on top of a sheet of paper, press it all together, and you get some amazing output from these laser printers. You can also print very quickly with these laser printers, making them a high-capacity output device. One challenge with laser printers, however, is they are relatively complex with a lot of different moving parts inside of the device. You also need enough memory and CPU inside of one of these devices to be able to render the page for the final output. And if this toner somehow finds its way outside of the toner cartridge, you may have to clean up quite a mess inside of your laser printer. When we mentioned the laser printer is relatively complex, this is what we're referring to. There are many different parts that make up the entire process for printing a single page on a laser printer. Everything in the laser printer focuses on getting information from the memory of this device onto a photosensitive drum that then transfers that image to a piece of paper. We start by charging this drum with a negative charge. This is done through a wire known as a corona wire, or it may be a roller that has a negative charge itself. Once you have this negative charge, the laser writes the image of what you need to print onto the outside of this photosensitive drum. Every place the laser touches gets rid of the negative charge. You then add to this photosensitive drum a negatively charged set of toner, which is going to stick to all of the places that the laser is touched. Since the rest of the drum is negatively charged and the toner is also negatively charged, those two will not stick to each other. A piece of paper is then passed next to the photosensitive drum, and all of that toner on the drum is transferred to the paper. Then the paper goes through a fuser that uses heat and pressure to permanently affix that toner to the page. Any toner that may still be stuck to the photosensitive drum is cleaned off, and the process starts again. As you can tell by that diagram, the toner is important for taking the image and memory in that printer and getting that represented on the printed page. If you run low on toner, you'll notice that the image begins getting lighter and lighter on the printed page, and of course if you run out of toner, nothing will print on that paper. Sometimes that photosensitive drum, which we refer to as the OPC drum, or the organic photoconductor drum, is inside of the toner cartridge itself. Some printers might also separate the OPC drum from the toner itself. That toner cartridge or OPC drum by itself are always shipped in a bag that prevents any type of light from getting in, so you want to be sure to keep it in that bag until you're ready to install it. The toner cartridges themselves are relatively modular. You power down the printer, lift up the cover of the printer, and you can pull out the entire cartridge from the system. From there, you can take the new toner cartridge, remove any of the packing strips or any of the packing materials, place it into the printer, and restart the printer. Here's a view of a toner cartridge where the protective cover has been pulled away from the photosensitive drum. This is not something you'll want to do with your toner cartridge, but you can see how the drum itself and the toner cartridge are integrated together. Some laser printers replace the toner cartridge from the top of the printer, or you might have a printer like this one where the toner cartridge is pulled out from the side. And if you have a color laser printer, you may have multiple cartridges, all with different colors, and you'll need to put those in their appropriate slot inside of the laser printer. With all of those moving parts inside of a laser printer, eventually pieces of the printer will begin to wear out. Fortunately, most laser printer manufacturers will create a maintenance kit which contain all of those important parts that tend to wear out over time. These kits contain feed rollers, new fuser units, and anything else for that specific model of printer that needs to be occasionally maintained. Of course, not every laser printer is used the same amount. You might have one laser printer that is used constantly during the day, and you might have another laser printer that is rarely used. You obviously don't need to go through the process of maintenance until it's required, but how would you know when that time might be? Fortunately, most laser printers will have a page counter, so you can remotely access that printer to determine how many pages have been printed since the last maintenance update. Most printer manufacturers will tell you at which point you would need to use this maintenance kit based on that page count. To install the maintenance kit, you'll want to power down the printer and replace those individual components that are included with the maintenance kit. Fortunately, most of these kits are relatively modular or can be easily swapped out inside of that printer. If you're working with a laser printer that has recently been used, make sure you're careful when you're working inside of the printer not to touch the fuser unit. Those get very hot during operation, and it does take time for those to cool down. Once you're finished installing the maintenance kit, make sure you reset that page counter in the printer so that you can now monitor it for the next maintenance time frame. When you replace a toner cartridge, you may notice that the new toner cartridge prints at a different density than the older cartridge. In that case, you may want to perform a laser printer calibration. This will print some test pages that allow you to determine if you're getting too much toner or too little toner on the printed page. There are usually settings in the configuration of the printer that allow you to fine-tune how much toner will be used during a normal printout. This can be something that is automated in the printer, or it may be a manual process where you have to evaluate the printed page, make the change in the printer, and then print a new test page. As we mentioned earlier, these laser printers can get very dirty with the paper dust that accumulates inside, and if you do have a toner spill, it can get very messy inside of the printer. You want to be very careful when working with toner. It is a very fine dust. It can get into the air very easily, so you want to make sure you handle it properly. Make sure you check the manufacturer's recommendations for cleaning your laser printer, and most manufacturers will use water or some type of isopropyl alcohol, or IPA, to be able to clean the printer. You do not want to use any harsh chemicals inside of your laser printer. On the outside, most manufacturers recommend using a damp cloth, usually with cold water. And if you're working inside of the printer to clean out the paper dust or the toner, you do not want to use compressed air, which will simply put that toner into the air around you. The best practice is to wipe that dust away, or to use a type of vacuum cleaner that is specifically designed to vacuum toner. If you do get toner on your skin, try not to use warm or hot water, since that could melt the toner and make it more difficult to remove. Instead, use cold water to be able to clean that toner away from your skin. If you're cleaning components inside of the printer, cold water is a good choice, and many of the rollers inside of the printer can be cleaned up using that isopropyl alcohol.
Stop taking meeting notes and let ClickUp AI Note Taker do it for you. It allows you to focus on your meetings, not your notes. It captures everything, from action items to key decisions. And after every call, you get a clear summary. But where it really goes to the next level is that it's the only AI Note Taker that connects your meetings to the rest of your work. So stop stressing about taking notes and get the AI Note Taker that works for you. Get ClickUp AI Note Taker for your next meeting.
At King Supers, you never compromise. You get up high quality that's guaranteed fresh and down low prices on over 1,000 items. With quality and savings that add up, King Supers shoppers never compromise. King Supers, fresh for everyone.
Inkjet or ink dispersion printers can create high resolution output in both black and white and color. The technology itself is relatively inexpensive, and the printers themselves operate relatively quietly. The output on these inkjet printers is also high resolution, and many people will output graphics and photographs using an inkjet printer. One of the downsides to inkjet, however, is the ink that is used. It's relatively expensive, and it is a proprietary method that is specific to the manufacturer of the printer. This ink also tends to fade over time, so you may find that an output that you create today looks very different a year from now. And one of the ongoing problems with inkjet printers is that the type of ink that we use tends to clog very easily. The industry has a number of different ways to address these clogging issues, and they tend to vary between different printer manufacturers. The process of creating output on an inkjet printer is relatively straightforward. Drops of ink are moved from a cartridge onto a piece of paper to create the final output. Normally, these cartridges have 4 different colors associated with them. Usually it's a black, a cyan, magenta, and yellow. You'll sometimes see this referred to as CMYK for cyan, magenta, yellow, and the K is for key, which is black. These are often installed in the printer as individual cartridges, although there are some printer models where all of these colors are within the same cartridge inside the printer. Some of these inkjet printers will combine the ink cartridge with the print head itself. This is an example of that, where you have a cartridge containing the ink, and on the bottom of the cartridge is the print head itself. This means that when you replace the print cartridge, you're also replacing and getting a brand new print head. Other inkjet printer models may keep these separately, where there is a separate ink cartridge and a separate print head located in different parts of the printer. Here's a close-up of that print head. You can see that it is a very small print head, and it is very delicate. If you are going to clean this print head, you have to be very careful not to damage that. This is also a relatively simple piece of engineering, and it's relatively inexpensive, which is why many printer manufacturers combine both the ink cartridge and the print head onto the same device. That way, when you replace the ink cartridge, you're also getting a brand new print head. You can see that the printer itself can be relatively small, mostly because this is a simple design.
All right, everybody, let's go ahead and take a break. I'll see you at 5 after.
You can see the feed rollers here that are right above the piece of paper. They're designed to pull the paper into the printer and all the way through past the print heads into the other side. Some larger inkjet printers can support duplex printing, where they will print up both sides of the page. This may be a feature built into the printer, or it may require additional hardware to be installed. You'll need to check with the manufacturer of your printer to see if duplex printing is supported. Here's a closer view of those feed rollers. You can see that they do get a bit dirty over time, so if you're having a problem pulling that paper into the printer, you may just need to clean off those feed rollers. One of the biggest problems you run into on an inkjet printer is keeping that print head clean. There are a number of processes used across different printers to be able to maintain this, and you'll want to check with your printer manufacturer to see the best practices for keeping that print head clean and able to work properly. For example, many printers run through an automated cleaning process every 24 hours. That's to wipe off any excess or dry ink that's on the print head and keep that print head as clean as possible. If you're getting streaks of color across the page, it's probably because there's some excess ink that is still on the print heads. Many inkjet printers also allow you to start this process manually. So if you use your printer a lot during the day, you may find that it needs to be cleaned more than every 24 hours. And if you're very careful, you may be able to remove the print head or the entire print cartridge from the printer and very carefully clean that print head off. Here's an example of an inkjet print head that has accumulated ink over a 24-hour period, and here's the same print head after cleaning. The ink cartridges themselves are usually either separate colors or combined into a single cartridge. You usually will find cyan, magenta, yellow, and key, which is the black color, and it's usually designated as CMYK. Here's an example of these colors in an inkjet printer. You can see that the cyan, magenta, and yellow colors are all combined in a single cartridge, and the black color is separate. On other printers, you may find completely separate cartridges for the cyan, magenta, and yellow, making it very modular to replace. These are usually very quick and easy to replace. They pop right out of their holder inside of the printer, and you can replace the new one in just a few seconds. Once you add a new cartridge, the printer will normally go through a calibration process, which takes a few minutes to make sure that all of those colors line up properly on the output. And because these are usually all plastic in their construction, it's usually a good idea to recycle your ink cartridges. Here's a good view of replacing one of those inkjet cartridges. They pop right out of the slot, and you can put a new one in its place. The calibration is an important step, and you may need to calibrate the printer even when you haven't replaced a new cartridge. This makes sure that all of the colors align properly with the information across all of those individual print cartridges. This calibration is usually an automated process, but you may find that making slight changes to the calibration can make the output just a little bit more crisp and have a much better result in your final printed page. Here's an example of a page that's printed for calibration. You can see a number of colors are on this page, and we have some marks that we can use to help line up all of those different colors together. Here's a closer view of the calibration page showing the different colors of the CMYK, and you can also see the calibration marks so that you can line up those very precisely. We send a lot of paper through our inkjet printers, and occasionally you will have one of those pages catch on the mechanisms inside the printer and cause a paper jam. Many inkjet printers provide you with a lot of access to the entire paper path, so you may be able to open the cover of the printer and easily remove that paper. Other printers may have a more complex paper path, so you want to be very careful when removing that paper to make sure that you're able to pull the entire page out without ripping any little pieces that might stay inside of the printer. Once you pull that paper out, check it and make sure that you didn't leave any parts of it inside of the paper path, and then you can try printing your output again.
There's a lot of things to worry about running a farm. The last thing we need to worry about is whether or not our website's online and working. Bluehost has helped us a lot in our growth. Since starting our website, we've seen our growth go about 300% over 5 years. So our business is definitely growing, and that's yielding more business for our farm.
Progressive makes it easy to see if you can save money with a commercial auto quote online, so you can get back to your monster to-do list.
Super helpful.
See if you can save money at progressivecommercial.com.
Thank you.
If you've checked out in a store or you've received a package in the mail, then you've either received a receipt or a label on a package that was printed using a thermal printer. Thermal printers work by using white paper and applying heat to certain parts of the paper. Every part of the page that receives that heat will turn black, and we'll be able to read the output on that page. That means there's no ink, we're not using any toner. Instead, we're using the chemicals built into the page to create that final output. Another interesting characteristic of thermal printers is that they're relatively quiet. Usually the only thing you hear is the motor that is used to send the paper through the printer, but the actual printing process is nearly silent. We of course are using heat to create the final output on this page. That's why we call it a thermal printer, because of that heat. But that also means that we need to be careful about what we do with that output. You don't want to put that receipt or that label near another heat source, or that part of the page will turn black as well. You'll also want to be careful about using clear tape on your receipt or your thermal output. That's because some clear tape will create a chemical reaction and turn that part of the page that it touches to white. Because there's no ink, there's no toner, and there's a very specialized type of paper that we would use, these thermal printers are relatively straightforward in their construction. The thermal paper is pulled through the printer using this feed assembly, and very often it is simply using friction to be able to hold that paper in place. This is a simple receipt printer. There is a roll of thermal paper that's placed into the printer, and you can see the cover is up on the printer right now. At the very top, you can see that feed roller, and it looks like it uses a gear on the right side to be able to propel that roller and move the paper through the printer. Here's a better view of that feed roller. You can see it's a relatively simple construction. You simply have a roller that's able to create that friction with the paper, and then you have a gear on the right side that turns it to be able to send the page through the printer. The other major component of a thermal printer is the heating element. This extends the entire length of the printing area. Very commonly, this heating element is one single piece and does not move inside of the printer. This means that we can simply move the page in front of the heating element. Heat will be applied to the element in different places as the paper is going by, and you will see that the paper turns a different color once it is past that heating element. You obviously can't use regular paper inside of a thermal printer. Regular paper is not going to change color when it gets any heat, and therefore won't be able to create any output in a thermal printer. Instead, you need a special type of paper known as thermochromic paper or thermal paper. This is paper that has a special set of chemicals on the outside that are designed to change color when heat is applied. This is the type of paper you see when you're using a cash register or a credit card terminal, or you receive a package in the mail that has a label. All of those different pieces of output were probably printed on a thermal printer using thermal paper. And if you touch the paper, you'll feel that it's a bit glossy and has a different texture than regular printer paper.
This is a team feeling zen. And these are the Dell PowerEdge servers that make them feel that way. They take care of themselves. So the team can spend less time stressing and more time growing their business.
We can start whenever you're ready. Ready? Yeah. Wait, no, stop! Wrong pedal. Other pedal. Wheelchair. What do you want? Stop the car. That's a kid. Kid. Did I pass?
Hello, DMV MVPs. Hi there, mister. Oh. Oh, no. How close did you come?
My life flashed before my eyes. I can't throw away my life in some dead-end job for crappy pay and no hope of happiness. No offense, Greg.
Oh, I wasn't offended until you said Greg.
Sorry.
What do I like most about working here? The constant rush of superiority.
Current homes are not a valid proof of residence.
Did you realize your job is to ruin people's lives? This is mine now.
It's out of ink anyway.
You guy. You started wearing makeup, stopped eating tuna. You staged the house. Don't blame.
If you're using a thermal printer, you don't have to worry about ink and you don't have to worry about toner, but you do have to worry about the paper that you're using. The paper inside of a thermal printer is designed to work for thermal printers only. We can't use paper from an inkjet printer or a laser printer inside of a thermal printer. There are also a lot of different sizes of thermal paper. That's probably because there are a lot of different sizes of thermal printers. You'll want to make sure that the thermal paper that you're using is specifically designed for the make and model of the printer that you're using. Fortunately, the process of replacing thermal paper is relatively straightforward, and on most thermal printers, you can perform this process in less than a minute. Here's how easy it is. We'll add a new roll of thermal paper to this printer. We'll extend the paper to the outside of the printer and close the top of the printer on top of it. We'll then push it down to lock it in place, and now we have a new roll of paper to use for our next print job. There might also be times when the heating element of your thermal printer needs to be cleaned. On most thermal printers, the heating element is usually easy to get to, and it's relatively easy to clean. We'll often use IPA or isopropyl alcohol to clean off the heating element without damaging the element itself. There are also cleaning pins that have IPA that make it easy to put the IPA in the exact place and quickly move it back and forth to clean off that heating element. Different manufacturers have different recommendations for how
Charles finally got all his files. Look at that.
And in every case,
Takes a village.
always check your documentation. There are also
Did you look at your settings? What was the problem?
inside of these printers, so you want to be very careful when you're swabbing and cleaning off that heating element. You might also find a cleaning
Wonder
card.
what it was.
This is very similar to sending paper through the printer, but instead the cleaning card is cleaning the pathways and ultimately cleaning the heating element of the printer as well. On any printer that you use over time, you'll start to get pieces of debris or parts of the page that are little fine pieces of dust that are inside of the printer. You will occasionally need to clean those out of the printer to keep everything working properly. If you're working on a thermal printer that's relatively portable, you can take that outside and use some type of air supply to blow out the inside of the printer to remove all of that debris. If you're not able to move the printer, you may be able to wipe off the inside with a damp cloth. In most cases, you would probably want to avoid using a vacuum. Anytime you use a traditional vacuum with a lot of dust, it tends to create static electricity, and as we know, static electricity is the enemy of our electronic components. Some organizations have specially made vacuums specifically for working with sensitive electronic components, so if you have one of those computer or printer vacuums, you might want to consider using that to clean out your printer. As the name implies, a thermal printer is using heat to be able to create the output that we see on the printed page. If another heat source was to come in contact with this page, it would also change the colors on the page. So you want to be very careful about avoiding any hot areas if you have any output from a thermal printer. You would not want to put your printed thermal output or label anywhere near a car dashboard, on a radiator, or anywhere near a hairdryer. If you do, the page itself will begin to turn dark, and eventually you won't be able to read any part of it at all. Also keep in mind that thermal paper tends to fade over time. So if you have a receipt or some other type of output from a thermal printer, and you need to reference that receipt a year from now, you might want to have an additional copy printed on a type of page that is able to be archived. Or you might want to take a digital image of that receipt so that later on you know that you'll be able to go back and reference the information that was on that page, even if the original tends to fade over time.
With the Amex Gold Card, every meal is a reward, earning you 4 times membership rewards points at restaurants and U.S. supermarkets. That's an opportunity in every bite, sip, slice, and scoop. Whether you decide to stay in or go all out. Earn rewards on everyday meals with the Amex Gold Card.
Lowe's knows when you need a new appliance, you need it fast. So we offer next day delivery on hundreds of appliances. Plus, members save more. And we'll haul away your old one. When you need it fast, we've got you covered. Shop Lowe's today. We help, you save.
One of the most common types of impact printers is called a dot matrix printer. This is because it creates an output on the page by using a small matrix of pins, pressing those pins against a ribbon, and eventually making a mark on the paper. And if you look very carefully at the characters that are printed on the page, you'll see that they are made up of very small dots. Those little tiny dots are the pins inside of the dot matrix printhead. Since these pins are pushing on the paper itself, it's perfect to use for carbon copies or multiple copies, where pushing on one page will create more copies of that page behind it. This is also a relatively low cost per page, so if you're printing a lot of output, you may be able to save money by using a dot matrix printer. But unfortunately, these are relatively noisy printers, so if you're working in a library or somewhere where it's very quiet, this might not be the right printer to use. And as you can see from the characters that are printed on this page, this is a very poor printer to use if you're trying to create any high resolution output. This is why we rarely find dot matrix printers in our homes and our businesses these days, and instead it is used in very niche cases where the best possible printer for that particular use would be something like a dot matrix printer. This printer head moves back and forth across the page. There are small pins inside the print head. The small pins are inside the very front of that print head. It is pushing those pins into the ribbon where the ink is, and that ink is being transferred to the paper that's behind it. If we were to look at the print head, it's relatively small, and you can see there's a pretty large heat sink on the back of it because these print heads do get relatively warm. But it is a single print matrix, so to be able to print on an entire page, we would have to move that print matrix back and forth across the page, and then move the page up to print the next line. Here's a better view of this dot matrix printer in use. You can see the print head moving back and forth across the paper, and you can see the page is moving underneath the print head to be able to print on other parts of the page. If we were to remove the print head from the printer and look at the print head itself, you can see that it's relatively small. This is the matrix of pins that are on the print head, and that is what is making connection with the ribbon and ultimately with the page behind it. The printer ribbon itself is usually one cartridge that fits inside of the printer, and the ribbon usually stretches all the way across the page, making it easier for that print head to move back and forth to make the output. This is a single unending ribbon, so it will cycle all the way through this printer ribbon case, come out the other side, and keep going over and over again until you replace the entire cartridge. Fortunately, it's relatively easy to replace these cartridges. They pop right out of the printer, you can put a new one in place, and usually that exchange only takes a few seconds. Different makes and models of dot matrix printers tend to use different sizes of printer ribbons. So when you're replacing this ribbon, you want to be sure to get the right ribbon for the make and model of printer that you're using. If we were to pop open the top of that printer ribbon, you would see that it is one long piece inside, and it usually collapses into itself in that repository area until it's ready to come out and make contact with the page. Not only do we have this ribbon that is moving as the print head is going back and forth, but very often we're using a tractor feed to pull the paper through the printer itself. This is regular printer paper, but there are holes on the left and right side. Those holes line up with these tractor feeds that are connected to the printer and that pull the page into the printer so that we can move it past the print head. These holes have to line up perfectly on each side so that the page is straight. If you miss one of these holes when you're trying to add more paper, or you happen to misalign it as it's going into the printer, then you're probably going to end up with a paper jam. We often refer to this paper as tractor paper because it has these tractor feed holes on the left and right side. This might be one long continuous piece of paper, or maybe perforated so that you can have standard size paper once it goes through the printer. Many of these tractor feed pages also have perforations so that you can remove those little tractor feed holes on the left and right side and end up with a page that looks relatively normal when you're finished. And in some IT environments, you might still be using green bar paper like the one we have here. This is commonly used on dot matrix printers. You can see the tractor feeds on the left and right side, and it was commonly used to output source code so that programmers could work on their output on something that was printed. One common use of dot matrix printers is to use a multi-part paper. This means that we can have one pass through the printer and have multiple copies that we printed using that impact printer. We traditionally used carbon or carbon paper to be able to create that additional copy, but a less expensive and easier to manage process uses micro-encapsulated ink on the back of that very first sheet. This uses clay on the second sheet that has a reaction to that ink to create that additional copy underneath. This creates that copy on the second page without us physically touching the second page itself. This combination of inks and dyes with the clay that's on the paper can create irritants in some people. So you may find that after you use these multi-part papers over a period of time, that you may have some irritation to the skin. Many organizations have found it easier to simply print another copy instead of having this multi-part paper with an impact printer. Ultimately, it might be less expensive and easier to manage than all of these moving parts inside of a dot matrix printer. And as the popularity of dot matrix printers is fading away, you may find it easier and much more convenient to use a different type of printer.
Welcome back to the strongest connection.
With most options, I've been waiting for something special, but it's been buffering. But underline, our connection is strong and ultra fast. This is gonna last.
Underline, local gigabit internet that loves you back.
Replacing the ribbon in a dot matrix printer is something that you will do from time to time because this printer does lose ink. This is one very long printer ribbon that is wrapped up and wrapped around inside of this printer cartridge. So eventually, after this printer ribbon rotates a number of times through the system, we tend to see that the information on the page gets lighter and lighter as we lose more and more ink. This will be very clear when you're looking at the output of the printer that it becomes very difficult to read, and so it's time to replace the entire printer cartridge. Fortunately, these are designed to be pretty modular. They usually will pop right out of the printer. You can push the new one directly in place and immediately start using it. And you'll find that replacing this ribbon cartridge inside of a dot matrix printer is a process that usually takes less than a minute. The print head itself is also something that you will occasionally need to swap out.
How's everybody doing out there in TV land? You good?
Tiny pins on the print head, and occasionally
Alright,
one or more of these pins will
quarter
eventually
to
stop
two.
working.
I'm gonna show a video just to remind you about Wi-Fi standards. So really no lecture, but just a video, a recap. It's about 10 minutes.
Warm, and you'll notice the back of this print head is really just one big heat sink. Some dot matrix printers have a few screws that you would remove to be able to take out the print head, but there are other dot matrix printers that have a release lever or a bar that you can use to easily remove the print head without needing to use any tools. And if you're spending the time to replace the print head, you might also want to take a few extra moments and replace the ribbon cartridge. This means the next time you print on this printer, you'll have the best possible output from your new print head and your new ribbon cartridge. Replacing the paper on a dot matrix printer can sometimes be challenging. These dot matrix printers don't tend to use single pieces of paper. Instead, they're using one continuously fed piece of paper that has these tractor feed holes on the left and right side. This means that you not only need to align these holes properly, but you have to pay close attention if you're using a page that has a form printed on it. This is because the printer is going to print onto the spaces of that form, and you have to make sure that it is aligned perfectly inside of that printer. And of course, you're not using individual pieces of paper. You're using one extremely long, continuously fed piece of paper that is being pulled through that printer. So you'll want to make sure that you don't have anything that would get in the way of that paper as it's being fed through the printer. If you do, the paper will tend to readjust and ultimately jam itself inside of the printer. So make sure that the entire length of the paper being fed into the printer and the paper that is being fed out of the printer is all working without anything that's in the way or is constraining the entire paper flow.
You know the feeling. You've written your first draft for an important writing assignment, and you're ready to get it past the finish line, but you just aren't sure how. I open Grammarly and select the text.
With virtualization, you can have one physical device and run multiple operating systems on that same computer. For example, you might have a computer like I do that runs Mac OS, and you can run Windows 11 and Linux all at the same time on that same system. This means that you have a separate operating system, a separate CPU, dedicated memory, and a separate network connection for each of these virtualized operating systems. If all of these different operating systems are virtualized on your desktop, then we refer to this as a host-based virtualization. This means you're running something like Mac OS as the primary operating system, and then virtualizing other operating systems on top of that. In an enterprise environment, we tend to use a single computer that has multiple operating systems running on it in a virtualized form. There is no desktop to choose from. Instead, you have a single device that has multiple VMs running on that single computer. And although virtualization has become very popular on our computers and our servers, this is a technology that we've been running since 1967 when it was first introduced on IBM mainframes. We're using that same concept that we used back then to virtualize our modern operating systems on modern hardware. There are a lot of things you can do with a virtualized operating system, or what we commonly refer to as a virtual machine, or VM. For example, if you're building your own applications, you might want to create a virtual machine that handles sandboxing. Sandboxing is an isolated environment that you can use during the development process to try out different aspects of code or to run things in a different OS to see what the effect might be. The benefit here, of course, is that you're running this in a virtualized environment that is designed for testing. So if something doesn't work properly or it even creates a problem with the operating system, the only thing that's affected is that single virtual machine. And because most of these virtualized systems have ways to take snapshots of the configuration at any point in time, you can create a snapshot, make some changes to that virtual machine, and if those changes cause a problem, you can revert back to the previous snapshot in a matter of moments. This also means we can create multiple virtual machines running multiple operating systems and be able to run that code in each one of those VMs to see what the effect might be. This means developers can write their own code, put them into a virtual machine in a protected and secure environment that won't affect anything if something happens to go wrong. And once the entire application has been written, they can put that code onto a test virtual machine that mirrors an actual configuration that runs in production. This means the developer can now run their test code in an environment that is very similar to what the end users will be using. Sometimes virtualization is not about application development, but instead being able to support operating systems that we don't normally use. For example, you may be running Windows 11 on your desktop, but you might have some applications that only run in Windows 10. One way that you can run both your Windows 11 desktop and the Windows 10 apps at the same time is through the use of virtualization. That's exactly what we've done here. I have a Windows 11 system that I'm running in one window and a Windows 10 system that I'm running in another. This allows me to switch back and forth between operating systems and run applications that may only run in one particular OS. This means I can switch back and forth between different operating systems and run the application that works best in that particular version of the OS. Here's a better view of this. You can see that we are running simultaneously on this computer a Windows 11 Pro system and a Windows 10 Pro system, both at the same time, and I can switch back and forth between either of these at any time without having to reboot my system. And of course, this doesn't have to be all the same type of operating system. We can have cross-platform virtualization like the one you see here. So you might run Mac OS on your desktop, run a Windows VM, run a Linux VM, and run other types of operating systems all on that same platform. You can also do this on demand. So if you need to run one particular application in the afternoon that only runs in Windows 11, you can start your Windows 11 virtual machine, run your application, and then shut it down. You have complete control over which application you're running in which operating system, and you don't have to reboot just to be able to change the OS that you're using. This is obviously saving time because we don't have to reboot or find another system just to run the application we need. And we're also saving resources because we're able to run all of these different operating systems on one physical computer. Here's a better view of this multi-platform use of virtualization. I'm running this on my Mac OS desktop, and I'm running a native version of the Mac OS browser on the left side. On the right side, I'm running a Windows instance and Windows applications inside of that window. And here in the middle is a window that's running Linux, and I'm running Linux applications in that window. I'm able to move back and forth between any of these at any time. I'm able to start and stop different operating systems and use whatever application I happen to need at that time, regardless of what operating system it uses. To be able to take advantage of virtualization, you need something that is going to manage the process of keeping all of these different systems running. This is the virtual machine manager, often referred to as the hypervisor. The hypervisor is the software that manages this entire interaction between the virtual world and the physical system it's running on. Hypervisors can run on almost any system, but many modern hypervisors can take advantage of CPUs that have specifically been built with virtualization in mind. And once this hypervisor is running, it can allocate CPU cycles, memory, networking information, and keep all of that separated between all of the different virtual machines. To understand more about how all of these different operating systems interact with the hypervisor, I've created this block diagram that starts at the very bottom with the hardware. This is the physical system that the hypervisor is running on. On top of that hardware is the hypervisor, and above the hypervisor are all of the different virtual machines. You'll notice that each virtual machine has its own guest operating system and applications running within that OS. Since each one of these virtual machines has its own guest operating system installed and running, there is a significant amount of overhead that takes place every time you start a new VM. This means you'll need enough CPU cycles, enough memory, enough drive space for all of these VMs to operate simultaneously on the same.
Okay, so the Saturday clock in mastery is missing for some of y'all on campus. Have you had it before? Okay. So you may start on October 1 for your mastery class. That's supposed to where if you clock in on Wednesday. Do you have one for Wednesday?
Or Microsoft's Hyper-V. If you're running a hypervisor,
you don't have one for Wednesday. Kevin, don't you start yours on October 1st?
Hypervisor or a hosted hypervisor. This means you would have.
I think I do, but I got an email saying that I should just jump into them and start getting the credit. So
yeah,
I have a clock in, but when you click on it, it says I'm not authorized.
Yeah,
so I just type my full name.
On top of that operating system,
okay.
we would then
I have one for Wednesday, not for Saturday. Okay, that's where Mr. Davies said he does not want you to miss class on Wednesday, so as long as you attend one on Saturday, meaning sign up for the camp and attend the morning or the afternoon session, that account for your mastery, so it doesn't interrupt you during the week in class.
Type 1, it's running on bare metal, and on Type 2, it's running on a hosted operating system. We mentioned earlier,
they will take that time and automatically apply it for you. So for those hours you have on the weekends, they will count that towards your mastery. Yep. Good question.
If you're running an AMD processor, the same type of functionality is called AMD-V.
Now you can still clock into mastery, and that time still works. So if you can you get into your mastery course and do the work?
So you have to make sure that you have enough RAM.
Okay, that counts as well. Yep.
Support all of these different virtual
that counts as well.
Simultaneously. And of course, each of those virtual machines contains a complete installed operating system, the applications that run in that operating system, and the data that you store in those applications. That means you'll need enough drive space to be able to
support did you watch the
fully built operating system and
did you watch the video and actually sign up for the class?
And from the networking perspective,
for the weekend?
You have complete control
or you just click the video to watch it?
Virtual machine is able to interact with other devices in the outside world. Most of the hypervisors that you'll run on your local computer.
You're fine. Yes, you're doing the work. Yes, that counts. They see you doing the work. You have to do the work. Yeah. So there's like one assignment per week. But to get credit for like the video or watching some kind of video, the weekend covers that. Yep.
You got here first. You did it. No, she's not that.
Good morning, guys. Wake up, good morning. It's a brand new day. Time for fall is a perfect day.
Dr. Lazarus.
I'm here so you can speak. What thoughts would you like to discuss? God, I've been speaking with him. And what have you been speaking with God about? You. He said you were a fake. Like father, like son. And I asked him to punish you, and you know what he said? What did he say?
Dad. It's Dad. He's dead. He took his own life. In his office.
So that doesn't feel right. There's been a lot of suspicious deaths over the years. My sister. It was 25 years ago. Yeah, but 2 unsolved deaths. the waves and the Cobra never caught. Where are you? I think whoever killed Sutton killed Dad. Dad's suicide note. It's not over. Some sort of code. It is messing with my mind. Care to elaborate? You're okay, sir. Ghosts. Right in front of me. I've been seeing people who have died, seeing them like I'm seeing you right now. They were murdered. So, Faith, you want medication? Right. My professional knowledge is telling me this cannot be happening. It must be a trick of my mind, but I'm seeing them.
We leave on once we leave these bodies.
You can't tell people you're seeing ghosts, son. They put you in the loony bin. I just wanted my dad back.
This whole thing looks like you went mental after your father's death.
You don't think I know I could be using my mind?
Did you find a dead body? You better start talking, because you... Hello?
Some hypervisors will configure a shared network address. This means that the hypervisor has its own IP subnet that's different than any other network that you're currently using. And when devices on that network need to communicate out to the physical network, it performs a network address translation to be able to communicate outside the scope of that hypervisor. You can also configure a virtual machine to look and act as if it's any other device that's on your local network. We refer to this as a bridge network address. There's no network address translation, and all of your virtual machines have the same IP subnet and act as if they are on your same local network. And if this is a highly secure virtual machine that should not be communicating to any other devices, you can configure your hypervisor with a private address so that virtual machine can only communicate with itself and any other devices that you decide. Security is always a concern when you're running so many different operating systems on one physical device. Fortunately, there have not been any significant security breaches relating to hypervisors, but this is something that hypervisor manufacturers and developers are always aware of. One type of security vulnerability that is top of mind for these hypervisor developers is a VM escape. This is when malware might find itself onto one virtual machine and use a flaw in the hypervisor to be able to communicate to other virtual machines that are supported by that same hypervisor. This would obviously be a significant issue if someone was able to do this. This would allow malware that would normally be isolated on one single virtual machine to be able to reach out and control or access data that might be on a different virtual machine. This would obviously be a significant security concern, and thankfully, we've not seen any significant breaches that are related to a VM escape. Of course, each of these virtual machines is its own self-contained operating system, and we have to be sure that we configure the security for that virtual machine as if it was a standalone workstation or standalone server. This means we would use traditional security controls on those devices. We would configure a firewall, we would install the appropriate anti-malware software, and configure the operating system to be hardened just like any other OS. One technique that some attackers like to use is to publish a virtual machine on the internet for anyone to be able to download and use. But of course, these malware authors are embedding their malware inside of that VM. And when you start running that virtual machine on your own environment, you're running an operating system that is already infected with the malware. This is why it's always a good idea to build your own virtual machine so you know exactly what software is running in those devices. And if you are downloading a virtual machine from the internet, make sure that you are completely aware of the information that is contained on that VM and that you're taking the appropriate security mechanisms to keep that VM and all of your data safe. Well, if we can run a separate operating system in a window on our desktop, why can't we virtualize the entire desktop? That is a technology known as Virtual Desktop Infrastructure, or VDI. This means that your desktop would run as a virtual machine on a separate device, commonly across the network or in the cloud, and the only thing that you would really need on your desk is a keyboard, a mouse, and some type of display. Sometimes you may hear this referred to as Desktop as a Service, or DAAS. This means you don't need a significant CPU, a lot of memory, or even a lot of storage on your local computer. All of the work is done on the virtualized client that's running on that virtual system. Obviously, we are sending information to update the screen that is running on our local device, so we obviously need some type of network communication, but these days we tend to have significant bandwidths available to us, which allow us to run technologies such as virtual desktop infrastructure. Once you're running the virtual desktop, it looks, acts, and interacts with you exactly like a normal OS. From the user's perspective, they're running an operating system that's running on their local device, even though they're really running this OS as a virtualized system across the cloud. We mentioned earlier that virtual machines need their own operating system installed on each individual VM, and that adds some significant overhead to the entire virtualization process. But what if you could remove that operating system component and only virtualize the applications? That's the idea behind application containerization, where you have separate containers that are built for every application that you'd like to run on that operating system. Just like a virtual machine, each one of these apps is self-contained. It has no idea that other application containers happen to be running on that same physical system, and none of those containers are able to interact with each other unless you configure that in the containerization software. And since there is no operating system, the entire container image is much smaller than the traditional virtual machine. This makes this very lightweight. You're able to transfer them very quickly from one place to the other, and they're very portable, which means you can move them from one physical device to another without making any changes to the application container. So here's a side-by-side view of a traditional virtualized application configuration and a containerized application configuration. You can see in the virtualized applications that each one of the VMs has their own guest operating system, but the containerized applications have a single host operating system. This certainly simplifies the process of managing the operating system, since there's only one OS that you'll need to patch, update, and maintain. On top of the host operating system, you would run containerization software. One of the most popular is Docker. And then on top of Docker, you would have the individual Docker containerized applications. One significant difference in containerized applications is they're relying on that host operating system, which generally means that each one of these applications must be configured to run on that host OS. You generally would not be able to run a Windows container, a Linux container, and a Mac OS container all on the same version of Docker. Of course, if you were running VMs, you could have different guest operating systems on each of those, but of course your trade-off is the overhead that you have with a virtualized application.
Trust isn't hoping, it's knowing. With a world-class network where technology brings visibility to every step. One more reason, UPS is the most trusted shipping brand. UPS, being unstoppable.
We can start whenever you're ready.
Ready?
Yeah. Wait, no, stop! Wrong pedal, other pedal! Here! What do you want? Stop the car! There's a kid! Kid!
Did I pass?
Hello, DMV MVPs?
Hi there, mister. Oh. Oh no. How close did you come?
My life flashed before my eyes. I can't throw away my life in some dead-end job for crappy pay and no hope of happiness. No offense, Greg.
Oh, I wasn't offended until you said Greg.
Oh, sorry.
What do I like most about working here? The constant rush of superiority.
Kurt Holmes and non-valid personal sentence.
Did you realize your job is to ruin people's lives?
This is mine now. It's out of ink anyway. You guys, you started wearing makeup, stopped eating tuna. You staged the house. Don't blame me for checking out the Zillow.
Oh, hey.
You see what I see?
The connection between them? When the menstrual pad stuck to her skirt.
How did that get there? It's a shame we could never, ever. Oh, it's baby done.
What we do here makes a difference. I love working here.
Why? I mean, why?
I love every single person who works here. We're one big happy family.
We've got a jump park.
Okay, as promised, just gonna play this video about Wi-Fi stands, about 10 minutes after. Then after that, we'll go ahead and catch our last break of the day, sir.
Free coffee, I'm out of here.
You'll often hear cloud computing described as a server that's simply hosted somewhere else. But in reality, cloud computing provides extensive...
Hello everyone. In this video, we're going to be talking about the different Wi-Fi standards. Now, Wi-Fi is a wireless...
Threat hunting is proactive. It goes on the offense. It doesn't wait for...
wireless technology that uses radio waves that allows networking devices the ability to communicate with other networking devices wirelessly using a device such as a Wi-Fi router or a wireless access point. And since the first development of Wi-Fi, there has been some significant changes in the technology and speed in the Wi-Fi standards. Now, the organization that created and maintains the wireless standards is called the IEEE, which stands for the Institute of Electrical and Electronics Engineers. And they are responsible for starting a project called the 802 project. And the wireless standards that they created was called and started with the number 802.11, which was the first wireless 2.11, which is also known by its more simplified name, Wi-Fi or Wi-Fi 0, came out in 1997. This standard used the 2.4 radio frequency band, and since it was the first Wi-Fi standard, the speed was very slow at 1 to 2 megabits per second. The next Wi-Fi standard was the 802.11b, which is also known as Wi-Fi 1. This came out in 1999, and this had a speed of up to 11 megabits per second, and this also used the 2.4 gigahertz frequency band. And also in 1999, the 802.11a standard, which is also known as Wi-Fi 2, was released. Wi-Fi 2 was the first standard to use the 5 gigahertz band instead of the 2.4. The differences between the 5 and the 2.4 frequency bands are interference, speed, and distance. The 2.4 gigahertz band is very common and is used in a lot of other devices such as microwave ovens, cordless phones, wireless cameras, and so on. So a lot of times these devices will interfere with other Wi-Fi signals. And this would cause problems because it would slow down the Wi-Fi network speed and sometimes could cause you to lose connection to the Wi-Fi router or access point. However, the 5 gigahertz band is not as common, so there was a lot less interference. So there was more privacy using the 5 gigahertz band. Another difference between the two is speed. Wi-Fi 2 transmits data at 54 megabits per second, which was a significant increase from Wi-Fi 1. But because it has a higher frequency, the range is shorter than the 2.4 because higher frequencies have a harder time penetrating solid objects like floors and walls in a building. And the next standard is 802.11g, which is also known as Wi-Fi 3. This came out in 2003, and this had a maximum speed rate of 54 megabits per second using the 2.4 gigahertz band. And it was around this time that Wi-Fi really started to become popular because Wi-Fi 3 was a significant upgrade over Wi-Fi 2 because of its faster speed and its improved ability to penetrate through floors and walls. And 6 years later in 2009, the 802.11n standard, which is known as Wi-Fi 4, was released. This standard was the first to use MIMO, or multiple input, multiple output, which is a technology that uses multiple antennas to dramatically increase its speed at a rate of 600 megabits per second. which was a significant increase from Wi-Fi 3. And it can operate at both the 2.4 and 5 gigahertz bands. The next wireless standard was released in 2013, and this was the 802.11ac standard, which is known as Wi-Fi 5. This operates using the 5 gigahertz band, and this was the first standard to use MU-MIMO, or multi-user MIMO. Now, prior to this standard, Wi-Fi routers and access points would communicate with multiple devices, but only with one device at a time. So each device would have to wait their turn to communicate with the router or AP. So as more devices connect to the router or AP, congestion happens. But in Wi-Fi 5 with MU-MIMO, it allowed all the devices that are connected to the signal to be able to communicate with the Wi-Fi router or AP simultaneously. So with this technology, there was a significant improvement in its speed, which had a maximum speed of 3.5 gigabits per second, depending on several conditions. Wi-Fi 5 also takes advantage of beamforming. Beamforming is a technique that sends transmissions in a specific direction, which strengthens the signal. But without beamforming, the transmission is sent in every direction, which can weaken the signal, which is what happens in previous standards. But with beamforming, the signal is directed to the devices that are connected to it. The next wireless standard was released in 2019, which was the 802.11ax standard, which is known as Wi-Fi 6. Wi-Fi 6 operates at both the 2.4 and 5 gigahertz frequency bands. Now, Wi-Fi 6 is faster than Wi-Fi 5, with a maximum speed of 9.6 gigabits per second. But keep in mind, that speed is shared across multiple devices. But speed wasn't necessarily Wi-Fi 6's main goal. The main goal of Wi-Fi 6 was not just an increase in speed, but it was to make a Wi-Fi network perform better when a lot of devices are connected to it. One of Wi-Fi 6's main features was OFDMA. This technology lowers latency and delivers data to multiple devices more efficiently, which basically means that it can deliver data to multiple devices at the same time. And just like the previous standard, Wi-Fi 6 also has MU-MIMO, but with an improvement. Because where Wi-Fi 5 can support 4 simultaneous streams, Wi-Fi 6 can support up to 12 simultaneous streams. And as I stated earlier, Wi-Fi 6 can operate in both 2.4 and 5 gigahertz. But with Wi-Fi 6E, where the E stands for extended, it can use a third band, which is 6 gigahertz. The 6 gigahertz band opens up additional channels for delivering large amounts of data to Wi-Fi devices, especially in crowded environments. These additional channels will result in a better network performance and a greater capacity to support more users. And in 2024, the 802.11be standard, which is known as Wi-Fi 7, was released. And this was dubbed as EHT, which means extremely high throughput. So where Wi-Fi 6 was focused on the goal of connecting and handling a lot of different devices, Wi-Fi 7's goal was speed, delivering a maximum potential speed of 46 gigabits per second, which is incredible. And just like Wi-Fi 6E, it uses the 2.4, 5, and 6 gigahertz frequency bands. Some key features of Wi-Fi 7 that makes it capable of this amount of speed is the introduction of a 320 megahertz ultra-wide bandwidth channel, which is twice as wide as the previous Wi-Fi standard. This allows significantly faster speeds by putting more data into each transmission. Another feature is 4K QAM, which allows more data to be packed into each signal. Wi-Fi 7 also features MLO, or multi-link operation. This allows Wi-Fi 7 devices to connect to 2 different bands simultaneously to achieve greater speeds. So it's this kind of speed and technology that makes Wi-Fi 7 ideal for streaming 8K videos and optimal VR experiences. And finally, the next Wi-Fi standard, which is due to be released in 2028, will be the 802.11bn standard, which is Wi-Fi 8. Wi-Fi 8 is currently being developed and it's dubbed as UHR or Ultra High Reliability. So as its name implies, Wi-Fi 8 is aimed to be an improvement in Wi-Fi reliability and not necessarily speed. So guys, I want to thank you for watching this video on Wi-Fi standards. Please subscribe, leave a comment, and I will see you in the next video.
Cool little recap, huh? Just to get it to stick. All right, everybody, let's go ahead and get in our last break of the day. I'll see you in about 10 minutes. virtual way. Y'all need to get anything from me? Y'all good? All right, just checking on y'all. All right, somebody wants to know what the pass-fail rate is. Anything but it's gonna have me sweating. So usually for first-time folks, the net plus is less than 60%. Less than 60% of the class. But it's something about my instructions. I get high pass rates. So, but the standard for net plus is usually under 60. But let me show y'all something. Hold on. Y'all can make me look good. You know, certification instructor of the year, quarterly instructor of the year. I mean, what I'm trying to say is, you know, I think y'all can do it. Y'all make me look good. I think what I'm giving y'all is the tools to be successful. So, my mic isn't picked. Well, here we go. Maybe that'll help. Maybe because I got to put my headset on. I don't know. Troubleshooting 101. Appreciate you, Mike. Let me start over again. I don't know. Maybe it's because of the hardware we have here. Maybe the certification instructor. Listen. Don't worry if that's a couple of years old. Doesn't even matter. What I'm trying to say is. No, I think y'all can do it. Just by the feedback. I know when people are in trouble. And I know when people are doing good. Y'all are doing it good. Okay? Y'all are doing good. I don't stay here. I don't like when people say, like, if I ask you a question and it's like, what's the switch doing? Well, it switches. I like getting down 1, 2. Because I know if y'all do that all the time, you do it through all your certs. Okay? Meaning you will learn more what you need about that device or whatever to answer those questions. So based on that and what we give you, I think y'all are okay. Okay? Took another practice test. Hey, don't worry about it. Sometimes walk away. Don't keep doing it. Just walk away for a minute. Pull up a video and watch it of something crazy like tipping cows or something. Free your mind, right? Free your mind. So, and then go back to it later, right? Take a break there, Charles. In Vogue, yeah. Free your mind, and the rest will follow. Yep. So, find something else to do. Watch The Matrix for a minute. Come back, try it again. Yeah. Do something else. All right? Cider, the reason why, now, from the time I first started, because I had to adjust my teaching. Because I saw, when I first started teaching IT like this, I noticed that there was a disconnect because by the time we got into certain things in Network Plus, it was too late. Y'all didn't have time to adjust. A lot of it was cider, switching, routing tables. That's why now firewalls, when I start teaching that in 1202. I give y'all a 2-week running start to run into it. right? So it's not a shock. So that's been showing some good fruit. So we'll see if that helps you on the exam. Yep. But don't sweat it, just do your best. That's all. Hey, I wish I could tell you everything that's on there and how to do it and do it in blueprint, but unfortunately I can't. But I think we laid a groundwork pretty good. It's better when it's practically. Yeah, it is. You're right.
Yeah.
Yep. Yeah, usually the mastery course, they'll drop some stuff, some extra stuff. Plus, I can't cover everything, right? There's always another instructor that gives you another angle that I didn't mention. So, yep. grab that out the chat. It's an example of what you might see. I had this video on the screen playing in about 5 minutes, so I won't interrupt you. Subnets and VLANs, just to recap.
Hello everyone. In this video, we're going to talk about the difference between subnets and VLANs. Now, both of these do the same thing. They are both used to separate or break down a network into smaller networks. And the main reasons for doing this is to make a network perform better, to add security to a network, and to make a network more manageable. However, both subnets and VLANs do these things using different methods. Subnets separate networks physically, while VLANs separate networks virtually. So let's talk about subnets first. Subnet stands for subnetwork. A subnetwork is a smaller network within a larger network, and subnets are created by using routers. So for example, let's look at a small local area network that's typically used in a small business. So here we have some computers connected to a switch. Now, when these computers want to communicate with other computers on this network, they will first send out a broadcast over the entire network. And every computer that's connected to this switch will receive the broadcast. This is known as a broadcast domain. Now, this wouldn't be a problem on a small network like this, with only a few computers. But if this business got larger and more computers were added, the amount of broadcast traffic would increase and flood the network with data, potentially causing a slowdown. Now, one way to prevent this is by creating subnetworks or subnets, which is known as subnetting. Creating subnets will separate and physically break down this network into smaller networks, and they are broken down and separated by using routers. And by doing this, this would alleviate the problem of excessive traffic because broadcasts do not go past routers. Broadcasts only within a network. So as you can see, the subnets are separated by routers. And each of these subnets has their own broadcast domain, which will not interfere with the other networks. Another reason for separating a network is for security. So for example, let's say that a business has 3 departments, such as sales, IT, and service. And in each of those departments are servers that contain sensitive data that no one in the other departments are allowed to access. Now, if this network was kept like this, meaning one big network where all the devices are connected using a switch, well, that means that everyone in all the departments are able to see all the computers and servers in the other departments. So the network administrator needs to isolate the network traffic between the departments, so that sales doesn't see traffic from IT doesn't see traffic from service, and so on. And once again, since there are 3 departments, the administrator can break down this network into 3 subnets using routers, so that each department has their own network. So now the network traffic from the different departments stay within their network, and each department can only see their own computers and servers. They are not able to see the other devices in the other departments. Now, a VLAN will do the same thing. A VLAN, or Virtual Local Area Network, will also break down and separate a network, but it will do it virtually. VLANs are created on a VLAN-enabled switch. The ports on a VLAN switch can be configured to separate network traffic without using routers. So back to our business example with 3 departments. So if you as an administrator wanted to break down and separate this network into 3 smaller networks according to their department, there's no need to move the computers and cables or add additional routers. All we have to do is configure 3 VLANs on the switch. So we'll configure 4 ports on the VLAN switch for the sales department, and then we'll call this VLAN 1. And then we'll plug all the devices from the sales department into these ports. And then we'll configure another 4 ports on the switch for the service department. And then we'll call this VLAN 2. And then we'll plug all the devices from the service department into these ports. And then we'll configure 4 ports for the IT department. And then we'll call this VLAN 3. And then we'll plug all the devices from the IT department into those ports. And once that is complete, these are now 3 separate networks with 3 separate broadcast domains. Each department can only see their own network traffic and their own devices because the network traffic is separated between the departments using VLANs. So this is why VLANs are so popular with medium to large businesses, because they can separate networks without adding routers, firewalls, cables, moving equipment around, or configuring IP addresses. They can just separate networks virtually by using VLANs.
Another little tidbit I want to show you. Waiting on 2 final exams submissions. 2 final exam submissions. Brian, I just graded yours. Good job. You can check your grade to see what your GPA is. Wow, it is 6 p.m. already. Are there any questions, everybody? Anybody? Anything else you got going on before we go and get on out of here for the weekend? All right, take advantage of that boot camp. That's tomorrow, Network Plus 009. Sign up for it. Use the link in your student resources. And at least make one of them if you can't do both. If you need anything, hit me up with an email. And remember, skibby hip. Oh yeah, pay attention to Pacific Standard Time, your time. That's East Coast time. When it starts to boot camp, it's a different time. Remember that. Good call out. Yes. You don't miss it.